Good morning and welcome. Welcome from the great state of Washington, from the beautiful Microsoft campus, newly renovated Microsoft Virtual Academy Studios here. My name is Jerry Nixon and you are watching the Jumpstart for exam 70483, C-Sharp Fundamentals.
Good memory.
Excellent, yes. I'm good with numbers. My name's Jerry Nixon. I'm one of your co-hosts today. I'm here with my friend and colleague Darren May. Good morning, Darren.
Good morning, Jerry. How are you?
That interesting and strange way that you talk is interesting to me. Okay, so I'm from Colorado. Darren also is from Colorado. Darren, you must be a native from Colorado.
I am, born and bred.
Yeah.
Highlands Ranch.
Also from Colorado, I'm a developer evangelist here with Microsoft. I tend to focus on Windows 8 and Windows Phone, XAML, and I've been friends with C-Sharp now for about 700 years, Darren. I'm not good with numbers, I told you that already.
Yeah, 699?
If you don't count college, I guess that's right.
That's probably true.
Now that you say it.
Yeah.
And Darren, tell me a little bit about who you are for a second.
So my name's Darren May, as we mentioned. I am president and CEO and co-founder of a company called Crank 211. We based out of Denver, Colorado, and we do a number of rich user experience applications and so on. Much like you, I've been using C-Sharp since year dot. Pretty much the early beta of C-Sharp and Visual Studio 2002, I guess it was. So that's a little bit of my background.
Back in the aughts.
Back in the aughts, back in the early days.
I talked to a guy, you referred to it as the Audis. The naughties, he finally said it.
Okay.
It was crazy.
Awesome.
So today, let's talk about some of the expectations that we want everybody to know, some of the level setting, and let's kind of move through that. So I'm Jerry Nixon. I do want to say that if you do want to find us online, I'll start with myself. I'm at jerrynixon.com. I blog with abandon, Darren.
You do.
It's crazy. And if you like the Twitters, then I am at Jerry Nixon, and you can find me there as well. Darren, where could we find out about Crank 211?
Funnily enough, next slide, www.crank211.com is where we are situated on the interwebs, and basically you can find out kind of what we do there.
Excellent, excellent. Crank 211 is a funny name. Where's something like that come from?
Have you ever seen the movie Spinal Tap?
A movie?
Yeah, there's a movie. It's a rockumentary, I believe they call it. And there's a particular scene where one of the members of the band is going through his guitar collection and he comes across this speaker. He says, "This speaker's special." And the interviewer's going, "Well, why is this speaker special?"
It's loud.
It's loud. It goes to 11.
Well, I thought they only go to 10.
No, this one goes to 11.
It's brilliant. All right.
Okay, moving on.
So today is going to be a jam-packed day. This is the agenda that we had to fit in a single slide, kind of like the fact that we're taking a 5-day course and fitting it into a single day. This agenda doesn't really give much justice to all the things we'll be covering today, just like this course doesn't really give much justice to the 5-day course that will be covering a great deal more content. So this is a jump start. It's intended for developers who either do or don't know C-Sharp at a level where they're ready to take the exam, or where they do know the exam and they just want to have a little bit of confidence and reminders kind of given to them as well. It'll be a good course. We'll start with some of the basics, and the first hour especially will be very little Visual Studio. We're going to talk about the fundamentals of object-oriented programming and some of the coolness that you may have forgotten is behind C-Sharp this whole time. Pretty neat. As far as prerequisites, if you are a developer and C-Sharp is, and you don't know how to spell C-Sharp, this course is going to be rough.
This course is going to be rough because we're going to introduce some of the foundational concepts. We're going to go through some of the assumptions around the language and so on, but we don't have the time to cover every aspect of the syntax. We don't have the time to really do a deep dive in every area. So some things we'll focus on because they are of more emphasis perhaps in passing the certification. Other things we'll just mention in passing and we'll talk about as we do the demos.
I think it's fair to share right now that this was a painful process because surely, that's talking to you.
Yeah, don't call me Shirley.
C-Sharp is not a shallow topic. And to cover it in one day, there's lots of things we just simply cannot talk about. And so in order to do that, We had to cut quite a few things out. And for us, who really love the language and just love helping developers, to be able to cut things out it was just a painful process to do.
I felt like I was a movie director. I was cutting out my favorite scenes. So that kind of speaks to some of the source code that we actually have to support here.
And a little bit of our own vanity to think about it like that.
Exactly.
Yeah, no doubt.
We have a lot of source code. There'll be links on where you can go and download that, so if you want to follow along with us. There is many, many more demos than we will actually incorporate during the day. And so if you go through and have a look at the project, you can see many snippets of ideas that we've had around how you can implement certain features and so on and so forth. So that's out there.
And if you're wondering which ones we cut out and didn't fully bake into this course, those would be the projects that are empty. The name is there. Yeah, those are the ones that we look for contributors to be able to fill those in if you're excited about it. So Microsoft Virtual Academy, just go through some housekeeping. Hopefully everybody knows where their own bathrooms are and things like that. We'll go in a series of modules with some breaks in between each one of them. There'll be 50-minute modules with a 10-minute break at the end of each. We'll break for lunch. Microsoft Virtual Academy, so both, not just for developers, also for IT pros as well. A lot of courses that you can take that have already been recorded, many in the hopper that are coming to you as well. Over 1 million registered users. That's pretty impressive.
It's a lot of people.
That M might mean, I don't know, maybe it doesn't mean million. Maybe it means 1,000. Let's go with 1 million. There's 1 million registered. Did you see that note?
I did.
That's beautiful.
The demo gods have paid us a visit
Required
already.
restart. That is a curse in the morning. That's wonderful.
Thanks, MSIT.
That's great. Over 1 million registered users with relevant training and really a fantastic catalog that you can pick from now. Not that expensive to take courses on Microsoft Virtual Academy.
And
right?
damn free to listen to us. So enjoy.
Free all the way around. All right, so earn while you learn. You can get MVA points. And with those points, do you know what you can get?
Point to win prizes?
You know what? You can do a lot with those points. If you'd like to learn more about it, you can go to MicrosoftVirtualAcademy.com, where it's all sitting there for you. If you want to get credit for this course, don't forget there's a code that you can use that expires March 29th. And you can get extra points. That's pretty cool. I wonder if they're like Xbox points.
I don't know, Derek.
I'll bet they are.
Mm-hmm.
I'll bet they are. I'll bet they're not.
Yep.
Now that I'm really thinking about it. I wonder if they're like big
Why don't we
points.
move on?
Yeah. Let's focus on what we do know to talk about more. All right. So Darren had alluded to the fact that we have quite a bit of source code that you can use to follow along with us or to do your own research and dig into. That is all up on CodePlex. There's a CodePlex project called XAML Show where you can... XAML Show is the beginning of showing off all the features of XAML in Windows 8 and eventually Windows Phone as well. But it's also the place where you can go to download these samples. It's right there on the first page. It's under Microsoft Virtual Academy where you can download it. XAML.codeplex.com, and it is a wealth of information.
It's a great place to go, as you say.
Yeah.
And it's going to get more rounded out as we move through.
Perfect. All right, listen, the first module is important. I don't want to take away from it anymore. You have it up and ready to go?
I have it up and ready to go.
All right, let's hit it and really start nailing this thing.
Okay, so the first module is really going to be an introduction into object-oriented programming, managed languages, and C#.
Is it pronounced OOP?
Not by me, maybe by you. So, the module agenda will initially hit, as I mentioned, object-oriented programming, just define those key concepts. Then we'll introduce the concept of managed languages and basically talk about those structures, what managed languages provide for us. Then we'll talk about why C# is a good choice for object-oriented programming, and then we'll basically wrap up. So, let's dive straight into object-oriented programming. So, what is an object?
An object is the foundational piece of object-oriented programming.
Okay, so when we're talking about foundational piece, what does that really mean? Well, fundamentally, an object is modeling a concept. It's an idea. It's something that represents an interaction, perhaps in the real world, perhaps in a problem domain. So there's usually three things that an object has. It usually is something. For example, it may be a customer. An object usually has data, so the customer's first name, their last name, perhaps their address, perhaps a customer ID. And an object usually performs actions, so you can make perhaps a customer preferred, or you can change the customer's first name and things like that. So we're modeling a concept.
So an object, just to simplify it down, is really just a thing.
It is a thing. Mm-hmm. And to define a thing, we have to talk about its characteristics.
We do. And at design time, or at when the developer is developing, they don't have the data yet, but it's going to be that container for the data that they'll have at runtime.
Absolutely.
Okay. Makes sense to me.
So what is object-oriented programming? Well, it kind of makes sense now we've introduced the concept of an object. It's effectively programming that's designed around the manipulation of objects. To be object-oriented, it has to be focused on objects, and it has to have certain properties and exhibit certain behaviors. This means the language generally includes 3 key properties: encapsulation, inheritance, and polymorphism.
If we got paid by the syllable, we're going to hit it on this one.
Exactly.
Yeah.
So let's talk about the idea of what encapsulation is.
Okay. Encapsulation, if you were to think about all the code that you're going to write, encapsulation is putting a wall around your code. Is that a good way to think about it?
It is.
And it's definitely meant to say people on the outside of the wall, I'll tell you how I do it, but I don't want you to look at it and get confused by it, start thinking about it, get distracted by it. I can take it and bring it all in here, and all you interact with me through the windows and the doors.
Yeah, it's effectively establishing a contract, a commitment of behavior, but obscuring the implementation details of that behavior, so that you know that a customer has a first name, but you don't care how that first name is actually stored. You don't care how you actually interact with that first name. You just know that you can pull it out through that first name contract.
Yeah. First name property.
Exactly.
And here we go on all the pieces. Encapsulation also allows you to take the code that you write and present it out to another audience as well. I could encapsulate my code and not worry about, say, intellectual property as well. I could make it so that I could give you my code because it's encapsulated. One, I know that you won't use it wrong. Well, I mean, you know what I mean. And the second one is I can have it all inside those walls and trust that my code can be protected through one of the mechanisms that I choose. Otherwise, my other option would just be to give you the source, and that is just not going to be good enough.
Okay, so the next feature of object-oriented programming is inheritance.
Ah, yes, inheritance.
So inheritance is fundamentally about the idea of code reuse. You create behaviors, and you can then have objects that inherit from other objects and obtain those behaviors through that inheritance chain.
Yeah, where the default definition in somebody's mind for inheritance may be the money they get from their parents, right? What this is more like is the funny nose they get from their parents, genetic inheritance, right? And whatever it is that your parents might have, you actually inherit their qualities. That's the same way with objects that inherit from other objects. You inherit their qualities as well, especially when we get to it, properties and methods and things like that, the signatures inside those objects.
Absolutely. And then we come to the final one, polymorphism, which everybody always loves to say.
Polymorphism.
Polymorphism.
I'm a monomorphist myself.
Okay. So polymorphism comes from the Greek, which is to have many forms.
Wow.
Shampoo.
Shampoo.
And so, in effect, what polymorphism is talking about, it kind of plays into the inheritance aspect as well, is if an object is inheriting from another object, then the object to which we were initially referring can be interacted with as if it was the object from which it inherited. Now that sounds really crazy to talk about, and so we'll be demonstrating it later on, but fundamentally that's what it means. You have the ability for an object to appear to be different shapes, as if they were different types, based upon how they're inherited.
If you saw the Transformers movie, you probably saw polymorphism constantly.
Are we going to do a Bugby meme now?
All right, polymorphism. Fantastic. Objects can become other objects, in a sense, other types.
Okay.
All right. Now, at its foundation, when we're going to be talking about CSharp, not just object-oriented programming, one of the things is managed languages, managed runtimes. It's an important topic. Let's talk about just what is a managed language.
Absolutely. So managed languages are fundamentally depend upon the services that are provided by a runtime. So in this situation, we're talking about CSharp. CSharp is one of many languages that compile into managed code.
C# is one of a few languages, surely, many.
There are many, many. There's COBOL, there's VB,
Yeah.
there is F# compiles into a managed language. Yeah. There are many, many different implementations. Obviously, you've got managed C++.
Well done. So, a managed language cannot exist unless it's enabled by a managed runtime. That part we know.
Absolutely.
Keep going. You were doing great.
So, the managed runtime in .NET is called the Common Language Runtime, and it provides a number of core services that the managed languages need to be able to perform. Such services include automatic memory management, where we're going to go into detail, but really it solves one of the key problems of using unmanaged languages such as earlier versions of C++ and so on, where the developer was responsible for very fine-grained memory management, such as allocating memory and remembering to release it when it was finished. That was a cause of major issues around memory leaks and so on and so forth.
And that's a very repetitive task, too. This is great.
Yeah. It's a lot of template code that you have to keep reusing, and that's not.
And it's the sort of thing that developers often got wrong because it is actually complex. And so what would happen is they would write an application that did all of the things that was in the domain of their application, and then they would get some of the boilerplate stuff wrong and make it look as if it was unstable. A runtime enables all of that boilerplate for you. It's really around, not just around getting it right, but it's also around productivity for the developer as well, so they don't have to build all of that. Just leverage what's already there inside the runtime. Certainly a runtime does more than that. There's also security elements, and there's also portability, right? That's also
portability. There. You've got the macro level exception handling. The Common Runtime provides that service. And there's also standard types, so standard ways of interacting with data. So we'll talk a little bit about types in a second.
All right. How about now?
Sounds like a great plan. It's almost as if this was a plan.
I do not want to talk about non-standard types.
Well, that's a good thing.
Okay, let's talk
We'll get to those later.
About standard types.
Exactly. So a type is a foundational building block of any application that's built in a managed language. The type really defines what an object is. It has metadata about that type. It talks about, or it has data around the memory allocation that's necessary to store that type. It has metadata that talks about what properties are exposed by the type, what methods or functions that type implements, what its level of access is, and so on and so forth.
So if I see an object and I want to know about that object, I need to interrogate its type. Type's a funny word because type defines what type it is.
Yeah.
I mean, it's tricky. But if I want to know about an object and what all is inside it and what all it's supposed to do and what all it says it can accomplish, I use its type. Now, I don't do that very often, but the compiler does.
Yeah.
If the compiler wants to understand this object that I'm invoking, then it is using its type and all of the metadata inside that type that describes the object so that it knows what to do with it and what not to do with it, which is probably the most important part.
Exactly. And that type metadata really helps you in your development environment when you're inside Visual Studio, because that is what helps you use things such as IntelliSense, get the compile time checking. The IDE brings that back. Excellent. So, one of the other advantages of standard types is that all types in the managed environment inherit from a common base, which is, funnily enough, called object.
Every object ultimately inherits from object.
Exactly.
And you don't see that in the syntax. Later we'll see how to inherit from something, and it doesn't say from object.
Exactly.
Everything is from object.
It's implicit, and it occurs for you automatically.
What about the cat object? It comes from object?
It absolutely comes from object.
Integer?
Integer, absolutely.
Everything comes from object.
Everything. That's really what it means when it says common base, Jerry.
Yeah, I really get it. All right.
Awesome.
So explain it to me. I come from object. What do I get from that?
So there are about 4 methods that object implements. One of them is toString, so that every time you refer to an instance of an object, every object has a toString method. Now, the default implementation of toString happens to print out the fully qualified type name, which we'll get to a little bit later on, which may or may not be particularly useful, but at least there is a standard implementation. One of the great features of object-oriented programming, and C# in particular, is you can give a new implementation of toString that may be specific to the object that you're using and to the scenarios in which it's being used. And so, that's some of the power of object orientation.
And back to inheritance, one of our big words, right, is because of inheritance, object implements toString, but that means because everything ultimately inherits from object, everything has toString, and it just keeps on going. You can kind of really see inheritance being driven there too, where whatever the parent has, the children have by default. So there's not really much implementation in object. Thank goodness, otherwise we'd have IntelliSense would be clouded with all kinds of things.
Absolutely, and also, you want it to be a template for sort of basic default behavior. You don't want to make assumptions around everything that all the objects should have. And so I think the things that it's got, such as the hash code and the default equality checking and those kind of things, make sense from that core object perspective. But it leaves the rest of the implementation up to you and the domain in which you're modeling.
So we can't do without types. And we're talking about the managed runtime, managed languages. Types are fundamentally at its base. All types are created equally?
Absolutely.
All types are the same?
No, they're not. We have 3 categories of types.
Interesting.
So the first type is a value type. Now, the interesting thing about value types is they basically point to the data directly. These are normally your low-level types, such as an int, a boolean, a double, and so on and so forth. They represent very much a very narrow definition of data.
A simple piece of data.
Very simple piece of data. The next
and I'll just jump in to say, and one of the reasons it's so lightweight or so simple is because they're so common, and if you started having all of these heavy things constantly, we'd have memory issues quickly.
Yes, exactly. I mean, it's an optimization characteristic. One of the interesting things about unmanaged languages, or managed languages rather, CSharp and so on and so forth, is it's constantly balancing usability, programmer productivity, and performance. And so there are these constant tensions in the language that keep it really true to a general purpose language that can solve most things very, very well. So we mentioned value types. The next type is reference types.
Reference types.
So reference types really speak to object instances. And the interesting thing about a reference type is the value is stored is a pointer to where the object data is actually stored. Okay? So a value type points directly to the data. A reference type points to a location where the object data is stored.
Yes.
Okay? So that's a key difference, and we'll come back to that. The third category...
It's almost like an index card in the library telling you where the book is.
Exactly.
Rather than the book itself, which is the value type.
Exactly. Pointer types are the final type, and these are only available in unsafe code. We're not really going to talk much about unsafe code, but fundamentally you have the ability in C# to mark a block of code as unsafe. And what this means is it is accessing memory directly as opposed to using the abstractions that the C# and managed libraries provide.
And those abstractions give a lot of safety for developers, a lot of safety also for the user of the system, so they can trust the application that's running. Fundamentally, we're talking about the managed language, managed runtime. It is a safe environment, and it is safe code. But at the same time, we've given the permission or the capability to developers to write unsafe, dangerous, awful code. Right? That's the short of it.
Fundamentally, it's there for those high performance requirements where you need to manipulate memory directly. And so, as I say, we don't really touch on any of those scenarios within this session, but be aware it's there, and it's useful sometimes perhaps when you want to manipulate bitmap data and so on.
There may be a COM jumpstart coming, and then they can touch on unsafe code all day long. Nice.
Okay. So the next section.
So wait. We're talking about managed languages.
Whoa.
We're talking about managed runtimes. We're talking about types and how important they are inside those runtimes. Now, we haven't talked much about C#, right? Here we go. How does C# play into all this? What's the point of C#?
Well, C# was basically developed to be a general purpose programming language. You know, it was designed to obviously be object oriented. It's the lead architect for it, Anders Kjellbergs, he invented Turbo Pascal and was the lead architect for Delphi.
I was a Turbo Pascal Delphi.
That's how you guys say it.
Yeah, y'all.
Delphi.
That's how weans say it that way. I was a developer for that in high school.
Yeah.
That was my first programming language.
Yeah. Was that on a wax tablet? Anyway.
Cut the slide.
In case you hadn't noticed, we do intend to have fun. Hope you guys
when's that going to start?
Yeah, exactly. Okay, so C#. It's pronounced C#, and that's why I keep saying C#. It's interesting we have that on the slide.
It looks like C pound is why.
That's right. Or we would say in England C#. Interesting.
Yeah. Everything is hash in England.
Oh, I say. Do you? So, as we've mentioned many times, general purpose language, object-oriented, focused on dev productivity. We're going to go through those features to kind of allude to why it is so productive and some of the capabilities it has. You get an idea of the fact that the main course is 5 days long, that it's incredibly rich, that there are a lot of capabilities built into this language, and we can only really lightly touch on most of those. We're going to do a deep dive in certain areas as we have time, but fundamentally use this as a launching pad if you haven't fully explored the capabilities of the language. There's a lot of great documentation out there around it, a lot of publications from MS Press and so on that you'll see linked to around this course, that you can really go in and deep dive into this language.
I think because it's based on some of the core C syntax, it's a very comfortable language for a lot of developers across a lot of platforms. Even now, most of the key languages are some variant of C syntax. So C# is a very comfortable place to come in. They naturally understand many of the kind of tricks around it that seem confusing. They've learned in other platforms as well. So I think it's very comfortable. We used to call it JUMP. I don't know if that was an official term or not. Java User Migration Path.
Oh, that's
where
right.
C# was a comfortable environment for developers who knew
So there's a common
languages.
core. So this next slide kind of is interesting to us that have been with the language for a long time, because what it really speaks to a lot is the actual core language was pretty much bait right out of the gate.
Yeah.
That there was a lot of really great core foundational syntax and style and capability in that core language. But it hasn't stood still. As certain trends have taken off within the industry, the language has responded. The team that is responsible for managing it have introduced new capabilities. And a lot of these new capabilities have really been focused around developer productivity.
Always productivity, it seems. It's such a productive language. It really is. It's a comfortable language, but also one that just every time they introduce a new feature, it reduces lines of code that I write.
Yeah.
I love that.
I mean, I can remember back in 2005 when C# 2.0 came out, and with the introduction of generics. Generics was a very big deal for me at that time. I was doing a lot of data access code, a lot of repetitive code was being written that I could have templatized if I had the ability to do so.
Yeah.
Generics introduced that ability, and we'll touch on that a little bit later on.
The other pieces that you see, I mean, it's interesting because you can look at code and see almost the pedigree of the code. You know, you can see I can tell you what year that was probably written in by just
exactly
what they're doing, and even now we're at C# 5, but you can still see developers that aren't. You know, they haven't gone into the features of 3.5 or into the features of 4. And so it's interesting to be able to see and kind of evaluate it.
Yeah. Once again, I have to thank Microsoft IT for popping that up over my presentation. Apparently, BitLocker is being changed.
Ah, fantastic.
Awesome.
We don't want it to stay the same. It's all about innovation here, and things can't stand still.
Exactly.
Especially BitLocker.
Exactly.
All right.
Okay, so let's talk a little bit about how C# implements some of those key object-oriented capabilities. So C# and encapsulation. So give me a recap. What's encapsulation? Well,
encapsulation, to go back to the analogy, is the wall around your code that doesn't let people see into it. But we do have these windows and doors, and so as you know, sake of analogies, that allows us to introduce this concept of public and private. And so inside the wall, I have everything that's private, and then I want to keep private, either not to expose the logic to other developers or other systems, or because it's so complex, I don't want to confuse or make the implementation so that it's wrong. So I have this idea of private inside the box, and then I have these touch points where it's public, and I allow them to interact with my code. That's encapsulation.
Perfect. So C# supports encapsulation by leveraging the unified type system, which is this type system that the Common Language Runtime provides for us. So that is a common way of sharing data. and exposing data out. It leverages things called classes and interfaces, and we'll get into those definitions a little bit more. A lot of more classic object-oriented environments only support the concept of classes. C# leverages interfaces, and we'll talk a little bit about why we need interfaces in C# later.
Well, I want to drill in just for a second to unified type system. A unified type, that is something special to the .NET runtime, and I guess at its core, what has happened is we've identified all of the repetitive types, all of the universal types, and brought them down into the runtime so that you don't have to recreate those up inside your own code, right? And so from app to app to app to app, you start having a commonality of all these types.
Well, and also it's language to language to language to language. You can actually share those. If you expose out a public property in an assembly written in, say, C#, you can consume that on the Metro side of the house or the Windows App Store side of the house. You can consume that in JavaScript. Maybe foreshadowing.
We'll have to talk about that later. Yeah, exactly. All right, on into inheritance, because inheritance is a tricky topic.
If you say so.
Oh, it's tricky. All right, so genetic inheritance is the best analogy, where you have the big nose just like your dad. I'm not really talking about you specifically. That was the arbitrary. That's right. Can we not do the profile shot?
Exactly. You have to zoom back out. Okay, so C# and inheritance. As we mentioned, we have classes in C#, and they model the overall template of a type. So they really help define exactly what a type is. In C# there is a constraint, and the constraint is that a class may only inherit from a single base class. There may be a chain of classes that get inherited, but each class can only inherit from a single base class.
That's important, because I think it comes up a lot where developers have implementation in more than one class. They want to inherit from more than one class, but that's not the way it works. The chaining is completely linear. 1, 1, 1, 1. A lot back to the way you are with your dad, my grandfather. I only have one dad when it all boils down to it.
Yep, one certainly hopes so.
I think.
So, and the reason that's key is there are many languages out there that actually implement multiple inheritance through classes. And there was a key decision point made during the C# language development to only support a single base class, and that came down to how C# implements polymorphism in terms of how a class can be represented as any of its inherited classes. Is it allowed the compiler to make a very reasoned and rational decision that was always going to be consistent about what was inherited and where it was inherited from, so that when you did casting, and we'll touch on casting a lot more later, you always knew exactly which implementation you were dealing with.
Yeah, if you had a zillion parents and they had features that overlapped, how would you ever be able to implement that in a logical way?
Exactly.
Yeah, it really cleans it up.
Exactly, makes it much simpler. So, how we were able then to support some form of multiple inheritance is we were able to leverage something called interfaces, and we'll go into interfaces in a little while, but fundamentally an interface is a promise. It talks about this is the behavior that any class that implements this interface will provide. You can use it to mark it as being something that is of this interface, and to also implement those behaviors.
Certainly understanding what interface an object implements allows you to understand it. It's a description of the class or the object, no doubt. But you're right, it is also a contract or a promise that says if it does implement it, or if it does have this interface, it must implement it, and we wouldn't allow it to compile if it didn't.
Exactly.
Beautiful.
So finally, C# and polymorphism. Wonderful word.
Polymorphism.
So here we start getting into things where the language, sometimes it's tough for us to express this concept in a way that makes sense, and so we'll be demoing this in a more visual way a little bit later. But basically a class can be used as its own type. Say, for example, we have a person class. We might inherit from a person an evangelist class, and we might inherit from a person a developer class. Sorry, I thought I was
trying to read your mind.
Exactly. You were trying to foreshadow there, wasn't it? Yeah. Cut to slides. Bam. Shampoo. So basically, we can then refer to a developer class as its base class.
Yeah.
Or we can turn around and say, I want to interact with this developer class as its base, which is the person class.
Yeah.
And so that is polymorphism, and we use an implementation called casting to move one type to its inherited type and back, and we'll touch on this scenario a lot more. We can also turn around and say, if we developed an interface called CSharp Coder, then both a developer and an evangelist could implement that interface, and we could then refer to those instances as C-sharp coders as well.
That's interesting, because now I can cast you into 3 types. I can have you as developer. I could have you as C-sharp coder, the interface.
Yep.
And that's easy enough. We share that. But we also both inherit from the same parent person, right? So now I could cast you into all 3, and that's polymorphism, is that you suddenly in my code can become any of those 3 at any time.
Yes, and that gives us a lot of flexibility, and we'll touch on that a lot more. There's another form of polymorphism that C# enables, and that is around methods. So a method is a function, it's a encapsulated piece of functionality that an object can perform.
Yeah.
We can define at a base level that a specific implementation, we mentioned toString before, a specific implementation of string could be overridden by a descendant, a subclass or a derived class.
Yeah.
So to use this scenario, say the toString method on person just says person, but we want a evangelist to turn around and say, oh yeah, shampoo, when we say toString.
Optimism,
exactly.
Optimism, inspiration. That's what an evangelist says.
Okay. So in the definition of the evangelist, we can override the toString method and ensure that it says exactly what we want it to say. When we cast that evangelist back to its base person, it will continue to say the evangelist implementation of toString rather than the base implementation of toString.
Now this is confusing, I think, a little bit, because as I cast a developer back to a person, I would expect for it to act like a person, not a developer. So casting doesn't change it back to a person then, Darren?
It depends on how these methods are implemented, and again we'll go into that because it is a complex scenario. You're absolutely right, and we'll show how you override a method impacts on how it rolls back up the types. But if you have basically a virtual method that you override in a derived class, that implementation follows it back up the chain.
So fundamentally, a developer can be cast to a person, to an iDeveloper or whatever, but it's still a developer. It's always a developer. It never loses what it really is. Now we can just interact with it differently. But developers also have, but now back to a real developer, a C# developer has the control to say, as you cast it around, what is it going to act like? What is it, like, if it goes back to person, is it going to use that base one? The developer can choose that.
Exactly.
Yeah.
Exactly. And as I say, we'll get into that in more detail and show you in code. So we mentioned a number of times that C# supports developer productivity.
Yeah.
And we showed that great graph of all the new features and capabilities that were introduced.
Yeah.
So I can't emphasize enough just how rich this language has evolved into in terms of the scenarios and so on. And its focus is helping a developer solve complex tasks without the language and the tooling getting in the way.
Yeah.
There's some languages that you may have used in the past that it's just like, I have a concept in my head, but I just cannot work out how to express it elegantly and effectively within this language. I find C# to be very, very useful in that environment.
Yeah. And I mean, obviously, C# is enabled by Visual Studio, right? Visual Studio and the tooling around it, other add-ons you can have, like ReSharper that you might install. I mean, there are all kinds of productivity gains that you can get from that as well. But truly, it's the language. And when you look at that map of time and you see the things that were introduced, the reality is C# has not changed that much over time. All it's done is increase productivity, and it is a beautiful language. And what's interesting is developers who use it, they're in love with it. Not only because of its elegance, not only because of how it's very logical, there's not a lot of compromise inside of it, but also this productivity piece around it is very important. Now there are some key things. What are some examples of productivity inside C#?
So I think one of the things that's most useful, and I use all the time, is the var shorthand.
Yeah, me too.
So
that means variant?
Absolutely does. Basically, when we're defining variables, prior to the introduction of var, we would always need to specify the type. So if we were using an integer, it would be int, variable name equals, and then a value. And as you start creating your own custom complex types, you typically have these longer and longer type names that you would be expressing in there.
You'd have to scroll to see it.
Exactly, and it would become longer and longer. The reason for having that is that C# is inherently strongly typed, which at its foundation means that you have to declare what type an object is before you start interacting with it, and it will always be constrained to be of that type or a base of that type throughout its lifetime.
Yep.
So it seemed very natural in the initial versions of the language to always be specifying that type.
And as an aside, this is different than languages like, let's say, JavaScript. JavaScript also has var.
Absolutely.
It does not mean the same thing.
It definitely does not.
Yeah.
Because in effect, you can place any value at any time into a JavaScript variable, and it will automatically become of that type.
And you can change the type constantly. You never know really what you have until you do an evaluation of it.
Exactly, and the reality is that environment depends upon the developer's discipline rather than placing constraints within the compiler.
Now, one of my favorite productivity pieces is LINQ. That's the integrated query language, and it is beautiful. LINQ allows me to save so much code. I can interact with different collections or enumerables and do all kinds of operations against it that I would have had to have hand-coded otherwise. And now, because of LINQ being integrated with it, I can do all kinds of things. Even one of my favorite is distinct. In order to find all the distinct members in the list based on some sort of criteria is a one-line operation now, where usually you would have a loop and some if statements, and you'd have variables or some sort of members that are keeping track of what is and what isn't. It's actually excellent. It
is excellent. And one of the key things that I find interesting is, imagine how hard it would have been to use LINQ if we didn't have var. For the return types.
Yeah, you'd always have to know exactly whatever's, yes, exactly.
Because, LINQ allows us to project into results that implement specific interfaces so we can iterate through them. But with the advantage of var, we, the developer, don't have to know explicitly exactly what type of enumerable.
Sometimes those types that are returned are just freaking long. I mean, if I got paid by the letter, then that'd be fine, but that's a lot of typing and more likely to get wrong than right.
Exactly. And then lambdas was also introduced at the same time.
Yeah, lambdas are a tricky thing. A lot of developers look at lambdas, and that makes them really nervous. I can understand why it does. It would make me nervous. It would make me want to. Avoid them when I first see them. But once you understand them, there's a lot of power. There's a lot of opportunity to create predicates inside a lambda. We'll spend some more time on it, but a lambda in general is a way for me to express a predicate in a small, tiny little syntax. It's very nice.
Yeah, I mean, basically it is a method that we can define in line and pass around as if it was a variable state.
Now, the C# syntax, generally speaking, is pretty clean. I mean, especially if you know C, but even if you don't, it's pretty clean. The syntax, for example, if you were going to build a class, like let's say lion, right? The lion class is a clean piece. You just define it. You can define whether or not it's public. You can find its name and then go into its members. Generally speaking, those kind of identifiers and pieces are very simplistic, right? You want to make it so that it identifies itself, but it's also at the discretion of the developer if you have a naming convention. We don't say classes have to be named like this. We don't say methods have to be named like this. We don't say.
Can we show the slide, please?
And generally speaking, it's very readable, right? I mean, one of the things, I was a Visual Basic developer for quite a long time, and I loved Visual Basic. You could read it out loud practically. But the reality is, C# is the same way. It's very clean and elegant and very discoverable by developers.
Absolutely, and as you mentioned, we have the identifiers and the keywords, and as we can see in this example here, the identifiers are the names, so we can see lion, sound, make sound, write line, and so on. And the keywords, they're actually colored quite nicely for us right now in the demo. So public, class, string, get, set, void, and so on.
And this is the simplest of the simple. We could make it very elaborate and say go to code decoration, and we can include attributes on some of those so that we can make them do even more. We can pass instructions to the compiler. We can tell other developers that are accessing and kind of indicate to them how they're supposed to use it. So that sort of decoration on the code is also very rich. We can go very simple, we can go very elaborate, and it's sort of up to to the implementer to decide how they're going and what they're going to include.
So wait a minute, you just said that C# is really readable and easy to understand. So does it really need comments?
No, it really doesn't. I think developers just, their code is self-documenting, right? I think we all have that. Of course it does. Of course it does. And there's a lot of different ways to comment. I think that's worth at least pointing out. You can do inline comments, right? / this is what I'm doing.
Yep.
But you can also do very elaborate. If you need multi-line, you can do that / and begin an entire paragraph description that nobody will read.
Exactly. War and Peace. Or if you actually want it so it could be externally consumed, rather than doing that big block paragraph inside that style of comment, you could actually use the XML documentation syntax, which will allow us to actually extract that information out as a separate XML file, and then we can use some tools such as Sandcastle, which used to be a Microsoft project, but I believe now has been picked up on Coplex and branched out, and this will replace, those of you who have been around a while may recall NDoc was a documentation production tool. We'll actually create standalone documentation that can be browsed very similar to what you see on MSDN, for example, to document your APIs so you can share across your team, and perhaps if you're producing a public API out to public consumers. When
we were talking about VAR, one of the most valuable pieces of VAR as well is the ability to do anonymous types. And I know we'll talk quite a bit more about this, but anonymous types allow me, the developer, to not have a full definition of a type. And sometimes that's very important because I need a type or a class that I'm interacting with, and I only interact with it for 2 lines. And so why would I go create a class, the full definition, and everything else, when really I just need to hold a few variables and pass them along and maybe put them in a list and then pass them along, and then I'll just destroy it, right? We could say it's a little bit of developer laziness sometimes, right? Not wanting to do that. In the past, prior to anonymous types, we had to go do that. And so now we can just quickly say this is an anonymous type, and the anonymous type is important because it allows us to, especially with LINQ and using VAR, to be able to interact with complex types very quickly. But the compiler on the back end is actually defining that for us. Where we were being sort of lazy, the compiler on the back end is actually implementing that class.
Absolutely.
And there are some downsides to them too, right? I mean, one of the downsides is they're not portable.
Exactly. They're defined within that scope, and so we can't share them. And because they're not one of the foundational types, they also can't be shared external to our assemblies and so on.
So they're really, really, really useful. But they're also useful only inside a scope.
Yeah, they're a great shorthand.
Yeah.
If you need to reuse the information and you need to share it around, then that's a classic scenario when you need to define your own class for sharing it, or maybe a struct.
Or maybe a struct, right.
Yep. Okay, so another great productivity capability of the language is extension methods.
Yeah, awesome. Terrifying are extension methods. They're almost like the Jedi Force. This is not the method you're looking for.
Okay.
It really is, right? Here I am. You give me an object, let's say. You've sealed it, and it's completely encapsulated.
I've created the string class in the .NET framework.
Right. Wow, that'd be quite a...
That would be quite a...
That's a resume bullet right
exactly.
there. I created the string class. And
if only we're true.
What's funny is string.toDog doesn't exist, right? There's no method that says
It's strange
toDog.
how that is. Why did they not put that in?
It is funny, but if I wanted a .toDog, right, I could totally create that method as an extension method, and then it attaches to that object for me.
But wait, I'm paranoid. I've turned around and marked my string class so it can't be extended. How do you do that?
With an extension method.
Okay.
Very powerful syntax that allows me to basically write a method, a static method, inside a static class, and then reference back to the type that I want to extend. From that point forward, every time I use a string class, I hit dot, there's that static method that I defined. That extension methods, they are sort of scary, right? Because it seems like you're extending an object that shouldn't be extended. Mm-hmm. But at the same time, it doesn't allow you to manipulate the code that's private and inside.
Yeah, so it doesn't break encapsulation.
It does not break encapsulation.
That's awesome. That's great to know.
Now, there are other features that are pretty cool inside C#. One of them is dynamics. This is new, right? It hasn't been around forever. A lot of developers don't use it. Some developers potentially use it too much. Well, generally, what is it?
So, basically, C# is a strongly typed environment, which means that you declare the type. This means that everything that's available to that type is understood. So you know that what properties it has, what methods it has, And those are all checked at compile time and dynamically exposed via IntelliSense.
Yeah, so we say it's strongly typed. The strong arm in that is the compiler.
Yes.
And the compiler says, this is the type, this is what it does, and nothing else.
Yep, if you type in a method that doesn't exist, then you get a red squiggly underneath that says, hey, this doesn't exist. If you try and compile, you get a compilation failure. So you never even get to run your code.
This is a warm fuzzy, too, because of the security around it. And then dynamics come along, and they allow us to shut down that security.
Yeah, so basically what we do with the dynamic keyword is mark a type and tell the compiler, ignore strong typing for this type. Do not enforce any rules around what interaction we do.
Right.
That's scary, but it's also very powerful, and it's also very necessary when you're interacting.
Give me a
with
use
things.
case. So, in fact, let me give you a use case. Let's pretend I'm interacting with some sort of external system, and it doesn't use that shared type system that we were talking about before.
Such as Microsoft Word.
Such as Microsoft Word, or some COM-based system that I'm interacting with, passes it back. Now the compiler will it still is treating it like a strong type, right? And I know there's a method there, but it's not exposed through any metadata that I can read it at compile time. So now I need to say .2dog on this weird COM object that's out there. I'm going to get a failure. So I have to use the dynamic keyword to say, ignore the strong typing of this. Let me do whatever I want to, and at runtime you'll see it really works.
Exactly, and I mean that's the key there at runtime. So the methods that you're specifying are evaluated at runtime, and if they don't exist, then you'll get an exception thrown. And we can then manage that within our application and deal with that. I mean, that sounds like it would be very powerful, though. Why don't we use it all the time?
Well, I'll tell you, it's because it's so dangerous, right? I mean, the reality is we spoke for a long time about the value of strong typing inside the managed language, inside the managed runtime. And that allowed us to say we trust our code, the user can trust our code, we have security around our code. Dynamics turns off all the strong typing. Now, and so it does allow your code that may not build, could build if you would go through and mark everything as dynamic. But it may not run.
Absolutely.
Right, and so that's the overuse, right? The overuse is, I can't figure out how to do this, I'll mark it as dynamic. That's great for the developer, it runs on your machine, but it may never run again.
Yep.
Yeah, it's very dangerous.
Okay, so we've kind of done a whistle-stop tour through a number of the key capabilities of the environment. But what we thought we would do is we couldn't go spend an entire hour without doing a quick dash into Visual Studio and showing the creation of a quick little application just to demonstrate some key
Let me pull up Visual Studio and just show a quick console app, and you can kind of walk me through some of the pieces that we'll see. So, when I pull up Visual Studio, I have a whole set of options inside CSharp. I'm just going to pick under Windows. I'm going to pick console app. Has to be the simplest of all the apps that you can
Absolutely.
write. Right? It's totally tiny scaffolding that you would actually...
This is where I learned most of CSharp, is just working and playing around with console applications, using the concepts.
Let me do it in a new instance here and just pop this over.
Is that a new instance?
A new instance, right. It's because it's Windows.
Oh, that's special.
All right, so I've loaded it. When I look at the console layout here, I don't have very much. I've just got a few properties here, and it kind of jumps a little, so you can look at it. I'm not quite sure what's going on there, but it's exciting.
I think whatever you're doing there, stop.
I can't. All right, I stopped it. Nonetheless, over there in the Solution Explorer, I've only got really Program CS. That's all there is. That's why it's so simple to do.
Yep.
I see a lot of code at the top already kind of baked in there. Using system, using link. What's a using?
So basically, using is allowing you to use a shorthand to reference types that are stored in what's called namespaces. So using system says by default any types that are declared within the external library system will be available to you as you start to type.
And later we'll talk about including other assemblies and how to do that.
And I just noticed another overload of type there. So type as in typing.
Yeah, it just goes.
It just goes.
So the usings aren't required. They're just meant to make productivity here. I could type system.collections.generic. Whatever is inside it.
Absolutely.
This is meant to make it easier for me. And sometimes I will have to do that still, right? There will be a conflict in name.
So that gets to namespaces. So as we see here, we have a namespace declaration called console application. As you say, you and I might be writing completely different applications, and we might create the same class. Let's say we create a class called class 1.
And if our different applications suddenly meet each other.
Class
Class 1 is a confusion. Right?
Exactly.
Two guys named Bob. 2 words named type.
Shut the hell up. And the compiler will be confused. It will turn around and say, there's an ambiguous class declaration here. I cannot resolve nor honor my commitment to making sure that this is strongly typed.
Yeah.
So we will then have to fully qualify that type name with Jerry's assembly or Darren's assembly dot.
It's bad enough you've confused the developer. As soon as you confuse the compiler, you're in serious trouble.
And it will punish you by not compiling.
That's right. That's right. All right, so now I see we go right into a class inside our namespace.
Yep.
And we could go from there. Now, namespaces, of course, can stretch across many different files, many different projects, actually.
Exactly. So, namespaces are generally used to group similar functionality into a common root namespace, so it's easy to find those things. Many companies would use syntax something like company name dot application dot functional area and so on to break up namespaces into chunks.
There's really no guide around namespace, or no restriction around it. If you need a namespace to say Bob dot keep going, right? Whatever it is you want, that's perfect. A lot of namespaces start with company name, maybe application name, things like that.
Yep.
And it's really meant to guide the developer more than anything else. Okay, so let's look back, right? We've been talking about some of the high-level pieces. We'll go more into console apps here soon. Now, at the highest level, we were talking about object-oriented programming and sort of how that is the way modern development is done, object orientation.
Yep.
And how we have safety now through managed languages. We have safety now through a managed runtime that enables those languages, and how C# implements the Microsoft implementation of that managed runtime for developers who understand the C syntax already, but also for developers who just want to be part of the trend. I mean, the reality is, I would say, I don't know the number, but it's a big percentage of applications that are C# and none of the others. You were right, there are a lot of .NET languages out there. C# is head and shoulders above the rest as far as popularity, right? Functionally, they're
certainly this side of the camera.
Especially right here, right? We're really into it. And yeah, I mean, we spent our careers mastering it, and so we're definitely into it, but that doesn't mean the other languages don't have the same functionality, because they end up using the same framework and using the same runtime. And then we talked a little bit about those core pieces and how productivity inside C# is enabled through things like var, things like link, things like lambda, things like extension methods, all of these pieces which are just amazing, right? They can take a block of code that is 100 lines and turn it into a block of code that is now 10 lines, right? And the fewer code lines that you have, the more maintainable it is. The more maintainable it is, also the less likelihood of bugs, which is really important. And also kind of the more discoverable it is as well, because even though we all are building these applications from scratch, hopefully someday we hand these off to maintenance developers, and those maintenance developers need to be able to look at our code and not cross their eyes because there's a million lines that they don't understand. So all of this productivity builds fast, but it also has dividends in the long run as well. A lot of power there. Darren, I'm looking forward to the whole day. There's so many pieces that we get to kind of dive into and talk to. Let's take a break right now, if that's all right with you.
I think it's great.
We'll go get some coffee. I don't drink coffee. I'm going to get some soda, and we'll see everybody in 10 minutes. All right, and welcome back. This is Module 2 for C# Fundamentals. Welcome back, Darren.
Welcome back, Jerry. Are you nicely refreshed?
I'm nicely refreshed, ready to go.
Raring.
All right. What are we going to talk about in this module?
We're going to talk about constructing complex types. So how do we actually start to build out and use this wonderful type system in modeling types that help us solve problems? We're going to start talking about object interfaces and inheritance, so really driving into those areas and really exploring those capabilities. And then we're going to touch on generics, one of my favorite parts of the C# and .NET Managed Runtime.
Beautiful.
Okay.
Got to say it again, we're going to be covering so quickly these things that need a day each.
Exactly, yeah. Brief skim with occasional scary deep dives. You're going to love it.
Yeah.
Okay, so constructing complex types. We have two foundational ways of constructing a complex type. We have a class and a struct.
They're not the same thing.
They're not the same thing. That's why they're two separate words.
Oh, I get it.
It's awesome.
It's interesting.
So a class or struct defines the template for an object. So what do we understand by that as a template?
Well, we were talking about interfaces. Is that the same thing?
That defines a contract, absolutely. The difference between an interface and the classes and structs is the classes and structs actually implement behavior, whereas an interface just promises that that behavior will be implemented.
I see. Okay. Got it.
I think that's foreshadowing as well.
Yeah, so we're going to have to talk about that later.
So, what does a class represent?
Well, let's see. A class represents the entire body of functionality, right? If I have a person, it represents the entire person, both all the things we know about it, like its eye color and its name and things like that, which we'll talk about as properties, but it also its abilities, right, which we'll talk about as methods, its ability to speak, its ability to do different things, and so we have those two things, as well as, and I know we'll get to it, events, and that's its ability to almost communicate back to us, right?
Yeah, so that sounds like it's pretty complex, and that's a lot of information. And it sounds like, what we build in that would take up a lot of space in memory.
Yeah, no doubt.
So, we probably want to employ
Depends on the person.
It's very true, very true. But we want to employ some way of managing what that memory allocation is and making sure that we're as efficient with that memory as possible. So that really is why we have reference types within the managed runtime. And so a class is used to define those kind of complex behaviors, and an instance of a class is a reference type, which is a pointer to where that object is.
So when we're talking about the person and it's all of its capabilities and features, am I talking about a class or am I talking about a struct?
Depends on how it's declared, because you could model a person as a struct, which represents a value type, but you want to be careful about when you use structs and when you use classes, and we'll touch on that in a little bit more detail in a moment. But a struct represents a value type, so every time we have an instance of a struct, we're actually saying we're occupying a chunk of memory for every struct that we're using. Whereas an object or a class can refer to the same object. And we'll touch on that in a little bit.
It's really about memory usage is what we're going to get to.
Yeah.
Yeah. There's that. So defining a struct is simple enough. The syntax around it simply says it's a struct, struct, and from that point forward, it's no longer a class, it's a struct.
Exactly.
It really is that simple, and we'll see that class syntax is exactly the same.
You're exactly right. And so if we flip over to a class, actually, if we talk about structs.
Yeah, let's get into a little more detail, because I want to talk about how what the implications are around memory.
So we just kind of mentioned that the idea is that a struct represents something that is more compact. Has a small number of members. Those members are generally value types themselves, and so the idea is that it occupies a fairly small footprint in memory. Or it's something that is commonly embedded within another type, i.e. it's internal. Perhaps you just bring it up whenever you create another instance, and so it just occupies a small footprint of memory. It's quick access.
And I'm hearing the trend, it's smaller, smaller, smaller. I mean, the more elaborate it is, you're probably going down the wrong track with a struct.
Exactly. It typically represents a single value. Now, that doesn't mean it's just a single property, but conceptually it models something, such as a point. A point has an x and a y coordinate if we're talking in 2D space. And so a point struct has an x property and a y property.
So it has two properties, but logically it's a single value.
Exactly.
Yeah.
The same thing with, say, you're defining a rectangle.
Right.
You have an origin, x and y, and you might have a width and a height. Again, conceptually, it's a very small value that you would reuse.
This would be extremely important if you have lots of rectangles.
Yeah.
Yeah. We'll talk about that.
Exactly. Typically, you want to make sure that these types are what's called immutable, which means they don't change over time. So you give it a value and you retain that value. That allows you to make certain assumptions about how you're going to use this. It's consistent. And if you want to change those values, in fact, you would end up creating a new type. Yeah.
And so if I'm interacting with a struct constantly, changing its values and all of the pieces like that, again, I might be going down the wrong track with a struct.
You might need to think about your strategy that you're using there. One other aspect is it's rarely boxed, and we'll talk about that in more detail, but it's a performance
Does this have to do with,
consideration.
this has something to do with Christmas? Boxing?
Absolutely. No, pugilism, in fact.
Ah, good. You know, Javi, I was just bringing it home.
Yeah, so basically boxing is, as I mentioned, something that we need to consider for performance. One of the key reasons you would use a struct is if you're doing a lot of computation expensive activities, the abstraction of having a reference type introduces additional steps if you want to access and manipulate those properties. So if you're doing some very intensive math computation, you may wish to use structs instead of classes, because that is just going to be quicker. And if you're iterating through that many, many times, then it will be faster access. The flip side is there's a memory concern if you're creating structs continually within one of those loops.
All right, so let's talk about classes now. So obviously I'm going to create something that's going to be, say, a little more elaborate. I'm going to interact with it. It's going to hold more data, maybe a series of points. Now I'm headed towards a class instead of a struct.
Yep.
And a class, we see the syntax. The syntax is just as simple. Just create it and start implementing on the inside of it. A class is special, it is a reference type, and to be different, a reference type is a pointer.
It basically points to the location in memory where that object instance is stored. And where that becomes powerful is we can have multiple references to that same object without duplicating that object's definition in memory.
So if I have a single dog, let's say that's my class, and I say there's the dog, and there's the dog, and there's the dog, and there's the dog, I've got 4. But in reality, in memory, I have 1, and all 4 of those are pointing back to the same one.
Exactly, and that's very efficient, especially if we start moving things around and passing them as arguments to methods.
And by contrast, if I had a struct and I said there's a dog, and there's a dog, and there's a dog, and I have 4 dogs now.
You have 4 dogs, and there's no relationship between those once you've created them.
Yeah, that's right. They don't know about each other, and certainly manipulating one doesn't manipulate the other 3. Where if I manipulate the first class of dog, because it's a reference, I'm actually updating the one and only reference of it. And so all of them get updated at the same time.
Absolutely. So there's some interesting things about a class in terms of you can decorate it and describe exactly what type of class it is. So you could turn around and declare animal is a static class.
Static class. Now this is interesting because I think we're probably going to be talking about invocation or instantiation, and that is to create the actual instance of a class.
Yeah.
Static is not doing that.
Static, you can't do that. It's actually, the compiler will prevent you from creating an instance of that class.
Why would you possibly do that? Why would you create a class only not to be able to instantiate it?
Because you can expose some static methods on that class, and so you can then just directly interact with those things. And what's key about that is there is no state being managed within a static class. It is effectively stateless. It just provides you with a series of behaviors.
Almost like a library of interactions and activities that it can do without the cost of instantiation.
Exactly.
Yeah. I like it. That's static. We can also choose from abstract. And abstract, just like static, cannot be instantiated.
Exactly. But the key difference here is the abstract class is actually an incomplete class. It may define behaviors that need to be implemented by anybody that inherits from that class, but it effectively is incomplete. It basically states that we are creating a template that needs to be inherited. Yeah, and we'll be demonstrating a lot of these capabilities shortly. We'll be bringing up a console application and going through some of these abilities.
And so an abstract class is important because it kind of goes back to the dog. If you have an animal and it inherits from, and you have a dog and it inherits from animal, nobody is going to instantiate an animal because there's no such thing as an animal. There's only a dog and then a cat, right? That's what really is there. And so you would mark those as abstract. BitLocker I rebooted, but it asked me again.
Okay, and then the final kind of modification we can place on a class is we can turn around and say it's sealed. And so sealed is one of these almost paranoid things you can do to a class. You can turn around and say, this class definition cannot be extended, nor can it be inherited from. And so you turn around and say, I have absolutely nailed this specification of this object, and nobody else will be able to go in and extend it any further, except if we use
Well, extension methods are right, but it's still
don't break encapsulation.
They do not break encapsulation, and it doesn't make available some of the internal data, right? It just adds to the functionality.
Yeah.
Let me show you something interesting. So when I create a class, and so this is I'm going to create a quick class here in a file, and let's call it dog. And so if it was dog, and I'll call it dog1 just to make the point here. One neat thing I can do with a class is I can mark it as partial. And this is important because a class definition could be extremely large. And the reality is you and I may work on the same team, and you're working on the part of the dog that walks, and I'm working on the part of the dog that talks, which is a lot harder.
Yep.
And the reality is, because it's one file, Visual Studio is amazing, but it still is one file. We could overwrite each other easily. So what's cool is I could create a second file over here, and let me change it back. This is just dog. It just happens to be in a file called dog1, and if I created a second file, I could call it dog2. This is important because now dog2, I'll change this back, and I'll also mark it as partial. Now, because they're inside the same scope, and that scope is its namespace, that's one class. Is spread across two files. You can go into dog1 and make all of your walking logic. I can go into dog2 and do all the walking logic. It's not two classes, Darren. It's one class, and the compiler knows what we're doing. And when it comes to actually compile my application, it becomes a single class again. But it allows us at dev time, right, to be able to be much more productive. I don't have to wait for you to finish walking in order for me to start implementing talking. It's very nice.
That's awesome. But I think there's another really useful scenario for partial classes, and that's when we're using something like, say, Entity Framework, which generates a lot of classes for us.
Yeah.
One of the great things about those types of tools is they generate code that we can use. If we didn't have partial classes, how would we be able to put additional behaviors in there?
Well, now that you mention it, man, if we didn't have code generation, imagine how much typing we'd have to do,
exactly.
Right? And we know the Visual Studio uses T4 templates to create most of that for us, and of course Entity Framework leverages that as well. But you say, you're right, it generates those classes, but the important part is it generates over and over and over. And so if we have our class definition that it's generated and we go in and tweak it, it'll just override all of the changes that we did, right? Because it is generating over and over. Partial classes allow us to cut it in half and say, don't overwrite my changes because they're in this file. We don't even have to tell Entity Framework or whatever code generation piece we have about it. Yeah, that's a very valuable piece. And I actually meant that earlier when I was saying I was going to implement talking, because I wouldn't actually write it. I would just
you just generate it.
Yeah.
Okay. It was great that you went into Visual Studio there and showed some code. We just want to point out that the first module was very introductory, and that's why we had a lot of slides. Moving forward, we're going to be in Visual Studio a lot, demonstrating some of these key code concepts and so on. Just want to make sure that's clear.
Now, so let's look at dog again. So I've marked it as partial, but look what else I can do. I can mark it as public. And so public has a special meaning, right? I mean, we're going to go through all of these different keywords, and the core piece is public allows me to create a class, or its members can be marked as public, and public is a special keyword that says anybody can see this. If you're referencing my assembly, if you're referencing my code, public means this is for you. Go, right? And then it allows me, it's basically around that wall of encapsulation, I'm now identifying where the windows are. So if I were to go say there was a method, say let's avoid, you like foo or bar?
Let's go foo.
Okay, so if I had a method, let's say, called foo, I could mark it as public as well, which means come use me. But I could also mark it as private. How is private different from public?
Well, private really impacts the scope of availability of that method. Where can it be used? So if I declare something as private, I can only use it within the context of the dog class. So another method in dog could call foo.
Yeah.
However, anybody external to the foo class or the dog class cannot see foo.
This truly is the beginning of encapsulation, where I say, this is the black box, stay away, nobody can ever see foo. You instantiate dog, dot, and foo doesn't show up.
Exactly.
But let's say I have bar, and I do want it to show up. But public is really too public, right? I want to make it a little bit more constrained. What are my other options?
So if you want to be able to refer to it within the same assembly, you could mark it as internal.
Internal, all right. And inside the same assembly is an interesting way of grouping, right? So
exactly.
How far out does an assembly go?
So an assembly goes, it's effectively scoped to a project in Visual Studio. So each project generally produces a an assembly.
Yep.
And all your code gets compiled into that. And so that would be your assembly scope.
Makes sense.
Awesome.
All right, so what else can I do here? Let's say, it's possible that dog isn't dog. Maybe it's, I'm going to have a dachshund class that inherits from dog.
Okay.
Be even more derived. And so I
have
shouldn't.
short legs.
I don't know how to spell dachshund correctly, especially with
So use poodle, because I'm sure you're familiar with poodle.
Yeah. What? All right, let's say it's poodle, and the poodle inherits from dog. Now this is nice. So now that it's dog, I can, if I did have, let's say it had an X method, in there I could say this dot, and I get, because it inherits, right, we get from dog, I get bar, but I don't see foo. Right, foo is not there, and the reason is, foo is marked as private, only this class, not even the ones that inherited. It really is the black box. But what if I wanted to just open the door a little bit, Darren?
Yeah, I think, a poodle should be able to foo. Good job you said foo.
It seems so.
Exactly.
So, yeah.
So basically we can mark out a method that's in the base class as something that derived classes can inherit from. And the way that we do that is we specify that it is protected.
Pretty cool. All right, so now I go down inside the poodle and I say dot, and I can bar. I changed it to bar so we could keep foo as a private option.
Okay, that sounds good.
So now I have one more. Now it's nice. It's not opening it wide to call it public so that anybody can see it, but it certainly is opening up to say, if you're going to use this as a base class and you're going to be inheriting from me, you're going to probably need this. I often include protected a protected event for raising events, right? Because you can't raise an event on a base, but you can call a method that does for you in the base.
Exactly.
When I call bar, is it executing inside the poodle or is it executing inside the dog?
Basically, it's executing within the object, and the object is both.
That's right. There is no dog and poodle. There is one object that inherits capabilities.
Exactly.
Excellent. All right, so that's interesting. We can do that to it. And
why don't we give the dog a name?
Let's give the dog a name. Now, do we want all dogs to have a name?
I think so.
I think so too. So I'll put that up in the base class. And what do we put there to hold the name? A variable?
You could create a variable. That would be an example. Now, what we need to decide is this name going to be publicly consumed, or is it going to be private and encapsulated within this class?
Yes. So we know it's going to be public because this is a dog, and the name is right there.
Exactly. And so the way that we encapsulate values to be shared externally is we use the properties.
Excellent. So I'll put out a public property in the dog class. It'll be a string, and it'll be name right there. And I see a get and a set in that property. What does get and set mean? We haven't seen that in the syntax so far.
Absolutely. So basically, the get and set instructs the compiler to create an infrastructure for us that will manipulate and store the value of name. So what we have here is a shorthand syntax for simple field access that will create behind the scenes a backing variable that will store name.
I'm glad you said that because I took a shortcut here for sure. I defined a property with a get set, and the compiler will blow that out to be the full implementation.
Yeah, why don't you do a full one?
Yeah, let's do a full implementation. Okay, so here's the full implementation. And what's special about it is not just that it has a get and set, but it also has this private member.
Okay, what do we call that? I think backing store?
A backing store, that's exactly right. So you're going to set the name, and in fact, I should have made it a string here, and we'll call it let's see, name, N-A-M-E, that's right, and we'll call the property. The Windows key here tricks me.
It does?
It does, but it's because I'm trickable. All right, so we'll call that name, and all right, so this is the long form implementation of a property. Why would I do this? It seems to me that the shorthand form is better, right? Because it's less code. Earlier we were saying less code, more maintainable, fewer bugs.
Absolutely, and I think that's why they introduced this syntax. But the longhand version gives us the ability to actually change the property to string, and
we're all debugging in our
exactly.
heads. Just show off the syntax.
I know, we can't help it. It's code. It's like we see those wiggly red underscores and we have to fix them. So, but what this allows us to do is additional actions whenever we're interacting with this property name. So we have the ability to extend the getter, which is fundamentally a method that interacts with the backing store. And not only do we say return the name when we say get, we could also initiate some other actions, such as do some diagnostic output right to the console.
Right. So if I have a setter coming in here, one of the things I might want to do is look at value. And that's the reason I might blow it out a little to say, if you're going to try and set the name, you can't set it as something.
Yeah, you might want to validate it. Oh, is that foreshadowing?
We'll have to talk about that later.
Exactly.
Excellent. All right, so often you'll see properties as that shorthand because it really is just holding a value. One interesting thing, can I do this? Can I put a keyword like this in the setter?
You absolutely can, and that's pretty powerful because what we're doing here is we're suddenly becoming very expressive with the encapsulation of this class. What we're turning around and saying is, in this scenario, for whatever reason, we are stating that you cannot arbitrarily, during the life cycle of this object, change the dog's name, which actually seems like a really good idea because Fido is going to get confused if you keep changing his name.
That's right.
So what we're actually saying is the scope of the name is shared publicly for consumption, but can only be created from within the class itself.
So we know there are three basic pieces to an object. We know that it has properties, which we're looking at here, and we see methods, which we can do, and we also can have events on them as well. The keywords are changing from one to another. Public is public, or what is it special when I get to events and when I get to methods?
No, that basically specifies the accessibility of all of these objects in exactly the same way. So if you have a public method, a public property, a public event, then they're publicly accessible. Same with protected and so on.
So foo is pretty simple, right? It's the classic demo here. But what if I were to create a more sophisticated method? What if I were to create a method that I needed to pass things to, a method that maybe even gives me something back? We can create something complex around that. Let's build something out for that.
Sure.
We've got a dog. A dog is going to speak.
Okay.
Good enough for you?
Sounds good to me.
All right. So we'll make it public because a dog, I guess, can speak. Anybody can tell a dog to speak.
Yep.
Huh, they really can, too.
They can.
It's really neat.
Yeah, they're often disappointed, but I think...
So now, a speak is not going to give anything back. It's going to cause something to happen.
Exactly.
So we'll mark that as void. But void is special. What does void mean?
Void basically means that the method doesn't return any value whatsoever.
Okay, void, nothing.
Nothing.
It's telling you what it returns.
Yeah.
Nothing.
It is very expressive, that's for sure.
All right, so I wanted to speak, let's say I wanted to speak something specifically. How do I pass it into it?
So then we would specify a parameter
Okay.
on the method signature. And the syntax declares that we would place that within the parentheses.
So I might pass in what it's supposed to say.
Exactly. And so what you've done there is said that what is a string.
And the only thing you can ask it to say are strings. You couldn't ask a poodle, let's say, to say a decimal.
Not without doing some form of conversion.
You would be a YouTube hit.
Yeah.
No doubt about it. All right, so here, this is going to be to do. It's a complicated thing to get a dog to talk.
It's a complicated thing, and you don't have code generation running right now.
I don't, not yet. Right. Just right-click, go. That's exactly right. And so that's very powerful to me. Now, what if what people ask dogs to speak is always the same thing? It's very redundant. I am appreciative of C# making me productive. How could I make other developers productive? Right? Are we not? Oh, with defaults. I jumped ahead, but
Exactly.
Let's do it anyway.
Exactly. Why not? Go ahead.
Yeah.
So basically, if you're passing in a common command and you want it to suggest to the developers that this is a standard way of utilizing it, and you want to give hints around it, you could specify a default value for that command.
Which is easy enough as just saying equals in the actual signature of the method.
Yep.
All right, so you might say bark, right? And that's the default what you ask a dog to speak.
Okay.
Anything else would be amazing.
It would be pretty good.
Not bad. So, although I've heard that dog that says I love you. Have you heard that one? The dog. I love you. You've never heard that?
No, I have not.
I love you. Never heard that?
I believe you.
I think it's a dog.
I believe you. Thousands wouldn't and probably don't, but...
Have you ever heard the goats that scream? They're equally hilarious.
Okay.
Oh, man.
Yeah, you spend much too much time on YouTube, apparently.
Oh, well, it's a learning experience. That's right. That's right. All right, so now my dog can speak, and the to-do will implement it here for us. All right, so let's talk a little bit more about method signatures and make sure we understand parameters. So I have created what we're passing into this method, and that is an argument.
The value that you pass into a method is an argument, yes. When you specify a method, you can specify its signature, which includes the parameters that method receives.
So the signature is a method that doesn't return anything, named speak, that takes a string.
And is publicly accessible.
And is of course, yes, and is publicly accessible. That really is the signature that makes it unique. I couldn't have another method that's identical to that in the same class.
You could not, because then for the compiler's perspective, that would be ambiguous. So ambiguity is measured based upon the signature of your class, or of your method, I should say. However, you could implement it if you change the signature. So how could we change the signature on this one?
Well, I suppose I could have another method. Well, I'll just have it right below it, also called speak, but I want to make it different. And maybe I say integer times. How many times is it going to speak?
Yeah, that would be awesome. And
so this doesn't conflict because the signature is really different.
Exactly. I mean, you can, if you go up and show how
now,
you
I'm getting a compile error only because we were showing off defaults. Let me reverse the order so that the one with the default is last, which is important because that's the syntax. You can't have defaults preceding others that are required.
Exactly.
And that is the difference. A default is not required. It's optional.
And that is a key point, and it's a very powerful point with a lot of these things. So why don't you go up and just show how these methods look like when you're consuming them and you're calling them.
You got it. So let me go down. I'll go to the poodle.
Okay.
Because the poodle is our dog of choice. All right. So now I can say this dot, and now I could say name. Of course, I did it both the long form and the shorthand. That's why there's a conflict in that. But now I have speak. But it only shows up once. I defined it twice. The compiler is clearly broken.
No, this is part of the power of the language. Now, if you actually start to implement it, what you will see with IntelliSense is it's detected that there are two implementations of speak which have different signatures.
Yeah.
And so you will actually get the option to choose which signature, just to hint which one. The other key great thing here is it's actually showing you your default value, so that you know that you could just close that off. If you wanted to use the default value, then you could just choose to use that and implement it straight.
So if I say woof, it will not call the method we created that implements times.
Exactly, because it knows this matches the first signature, and I won't call the second one. But if you wanted it to woof twice,
yeah, I could just say 2 comma, just like that.
Excellent.
Yeah. Now let's say I had a third parameter. I'm going to go ahead and add another one here to bark, and it's going to be it'll be a Boolean of whether or not to sit while he's doing it. Okay. If that's all right with you. And we'll just say, usually they will, so we'll go ahead and do it, right?
Okay.
And now I'm going to go here, and I'm going to say, I know that bark is defaulted. I'll accept them both. Now what's interesting is I'm only passing one value into this.
Yep.
Which of the methods is being called now? Because this signature only has one, so I would assume it's this one?
But we were only passing a number, and so the integer doesn't match that string parameter. Therefore, the compiler is going to search to see if there is an implementation that it can use, and so we'll therefore use the third one.
So we default to this one, or we call this one because of the defaults that are being kicked in. Actually give it several signatures.
Correct.
Yeah. And so what if I wanted to call times, Darren, but I did not need to change what? But I did want to indicate whether or not the dog should sit while he's speaking.
So you could do that in the longhand way, which would force you to supply the value.
Like this?
Exactly, which is inefficient. Or we could use named arguments.
Okay, so I just want to pass in true, and I assume it's like this. Of course, we know that fails.
We would know that fails because that doesn't match any of the signatures.
That's right.
You can't derive it. So you need to pass a name.
All right, so I can call sit.
Sit.
So I can call sit specifically like this. Now I'm bypassing what it's supposed to say, and I'm jumping directly over to sit.
Yeah, that's pretty powerful, isn't it?
That's unbelievable, actually.
Yeah. What if you swap those around? Could you
Change the order?
Change the order.
Oh boy, watch this. We're going to wreck the whole system. All right, so I'll go in and I'll take which really should be at the end like this. Now, we'll see that it doesn't work. Oh. Name parameters don't care about the order.
That's pretty clever.
Yeah, that's very good. Whoever wrote whoever wrote C#, not bad.
Yeah, they knew what they were doing.
Yeah, we'll give them 1 point.
Exactly. 1 point.
That's right.
For Gryffindor, yeah.
For Gryffindor, says the voice in the back.
Nice. Okay. Let's see. We talked about default value. Default values. Oh, we were kind of going back and forth actually around value and parameter. And I think just to double up what you were saying, sit is the parameters, is the method's parameter.
Correct.
True.
So from the concept of from the perspective of the method, those are the parameters.
It is a parameter. True, on the other hand, is the value of that parameter.
Correct.
It is the argument.
It is.
And so we have a parameter has an argument, and a method has a parameter. It's an interesting little syntax candy right there.
It is.
Yeah, no doubt. Easily misspoken by me over my entire career until recently. So,
so why don't you add an event?
Let's do that. So we know there's two things that a class can do: both hold data in a property, do something, and raise an event. So what should we call it? I'll call it, first I'll make it public because I want an event. We know that event is called an event, E-V-E-N-T, and it needs a handler, which we'll talk about in a minute. And let's say has spoken, if that's all right with you.
Sure, that works for me.
Done. So, that's full implementation.
That is awesome.
Yeah.
It's incredible.
It's stunning.
So what is an event?
So the event is the way for a class or an object to talk back to me. So I can invoke.
What, like the dog is talking?
It's similar to how the dog is talking, but the dog is only speaking here because I invoke it to do that. But something could happen at any time, and an event will be raised as a communication mechanism back to me so I can handle something. That's why we have an event handler. An event's very tricky because its timing is known to you because it happens after something. But there could be many things in between when it was raised and when you actually began handling it. Let's talk about how handlers work, but first let me raise the event.
Sure, sounds like a good idea.
So we know that if you call speak, has spoken is going to be called. So I'll say, you call it just like a method. Has spoken, and I'll pass in this as the reference to the object that sends it. This is the class that sends it. This is the keyword that represents the current class. And then I pass in some event arg because I took the most generic of all of them, event handler. There's nothing to pass in. So I'll say event args dot empty. And now I've raised that event. So you call speak, and then it does whatever in the to-do line. And now, when it's finished, has spoken will be raised. And now I can respond to that. I can handle it. I can do whatever needs to be done after it's. Maybe I have to make him speak again.
Is that a safe way of implementing?
It's not. It's not at all, because what if nobody is listening? That's a very important piece. That has spoken is now an event that if anybody's listening, I'm going to raise it and you can hear it.
So if nobody's listening, it's a null?
It is null. That's exactly right. So I would get an exception here that says a null reference. So a quick check would be right here. If has spoken is not equal to null. So
nobody subscribed to it.
Nobody subscribed to it, right? That's nobody is listening. The technical would be right. Nobody has subscribed to it. So I could speak all I want, nobody will hear it. I get this null check, and it actually helps in performance as well, that I'm not raising events that are useless.
That nobody's listening to.
Exactly.
Okay, that's interesting. So this is like to be a little bit more formal, this is the publish subscribe pattern?
It is.
So that's an implementation. That's interesting.
Okay. Now we could be more elaborate, of course, because an event handler, what is an event handler?
I think it defines the shape of a method that the event expects to be handling when you raise it.
That's right. So in this case, the handler, it has to do with the two methods, or the two parameters that will be populating.
It just trips up your tongue, doesn't it?
When we raise the event, right? That's the event handler, and of course we can extend that event handler. We'll talk about generics later with a generic that we could say it's not an empty arg. We're going to be passing back interesting things. How loud was he? Was anybody there? All kinds of neat things that you could pass back to that event.
Yeah, and the key thing here is, the event handler is a delegate, which we'll touch on a little bit later on, but it's such a common pattern. That's why there is now a class called event handler that you can use, because it's very common to just turn around and say, this is the object that raises the event, and in general, you're more interested in the event itself than any particular information that gets passed in that generic sense.
A common one might be like data loaded. And so after data had been loaded, then you can go find the data. You don't need to pass it around with the event.
Yeah.
Sure.
Yeah, and of course, if you want to be more specific, then you can define your own event handler syntax or signature and pass those around.
Yeah.
Okay.
That's pretty nice. Now, how many people can listen to an event?
I think more than one.
That's right. That's right. So if I have a dog out there and he's about to speak, and I have 10 trainers, all 10 trainers can listen for that event to be raised to respond to it.
Now, the difference between that scenario in coding is they are passively observing. They're not doing something to listen to the dog. Whereas with events within .NET, you need to actually subscribe to that event.
Yeah.
And you can have multiple people subscribe to that event, and that's the broadcasting to multiple subscribers is multicasting.
And a subscription to an event is like a string. I tie it to that object.
Yep.
And from that point forward, there's a connection between the object that I am listening to its event and me.
Yeah. Do you want to show quickly how to subscribe to an event?
Yeah, absolutely. So let's say I'm going to need an outside object here. So let me create another quick class of a trainer. And the trainer is going to, there we are, sorry, is going to, let's have void x again here. It's an excellent naming convention, by the way.
It is. It requires a huge amount of thought.
Let's change it to something that's more interesting, like let's not operate. It's going to operate. This is how a trainer operates,
okay.
Darren. I don't know if have you ever seen a dog trainer?
But that's fine.
All right, so let's do it then. So he'll have to create a new dog.
Yeah.
So I'll say var dog equals new dog, new poodle. So I want a real dog.
Okay. And the interesting thing is we can create new here, so we're seeing how we can create a new object. Because they aren't marked as abstract, we can create instances of them.
I can, that's right. I can create a dog, even though one may not exist. I may want to go back to mark that as abstract.
Yeah.
Because I don't want people to create dogs, I want them to create poodles and dachshunds. Wonderful. Or whatever. All right, so this dog, now when I look at it, I can see that he has a has spoken event right here. I'm going to remove this so that I don't get that red X and it looks like something's wrong when it's not.
Yeah.
So here's has spoken, and so that is the event that I want to subscribe to, and the subscription is with a easy enough plus equals.
So what does that plus equals mean?
It really means add to, because as it turns out, an event is a list of methods that need to be raised back.
Okay, so it's like a shorthand.
It is certainly a shorthand. And if there was anything that Visual Studio gives us, it's the ability to be productive with shorthands, right?
Yeah.
Not only can I just put plus equals, but it also is listening to what I'm typing, can see that I just typed plus equals. And look, it's already suggesting that I just press tab to do all the work for me. So I will. Bam! Now it knows I need a method, and it's going to name that method for me called dog underscore has spoken, where all the logic that's going to react to that event will be.
Okay.
I'll tab again. It stubs out that event for me, and it even stubbed out a not implemented exception so I don't get too lazy.
So how did it know what the signature of that method needed to be?
It knew because of the definition of the event. It's beautiful. We always go back to typing, don't we?
Exactly.
So now we can go back to where we actually define the event, and it is here that we said what the signature of the handler needs to be.
There's power there.
There really is, and it's neat because the compiler is doing all the work for us, seeing it all behind the scenes and implementing it for us, just making sure we don't do it wrong. Visual Studio, on the other hand, is helping us to go find that rather than say, okay, now what is that signature? I need to build it. It does it for me.
Excellent. So the next area that we're going to cover in a little bit more detail is object instances and inheritance.
Ah, nice.
Okay? So if we switch to the deck. So we've touched on inheritance, and you've obviously demonstrated the basic capabilities just there with
where a poodle inherits from a dog.
Poodle inherits from a dog. We also talked about the different types of modifiers we can place upon a class to indicate static, abstract, and sealed. So we show how that if we'd marked the dog as abstract, We could never create an instance of a dog, but we can create instances of a poodle.
If we had marked the dog as sealed, then poodle could never inherit from it because it is sealed, so it cannot be inherited from.
Exactly. We've spoken earlier about the idea of virtual methods, the idea that a virtual method can have implementations, but the key thing is we can change that implementation in the derived classes, which is an interesting...
It's very powerful, too. It allows you to really control where things are going to be run.
And so, if we kind of look at this inheritance hierarchy that we've put together here, so we have class 1, class 2, and class 3, and we have some code here that really outlines those classes. So we can see that class 1 implements string name, okay? Class 2 inherits from class 1, and we've seen that syntax from Jerry's demo earlier on. Class 2 also defines a property called age.
So now we have two properties.
We have two properties. And class 2 has name inherited from class 1 plus age that is defined itself.
Class 1 does not have age because it's up the hierarchy, not down.
Exactly. And then we have class 3 that inherits from class 2, which means it gets all the crunchy goodness that class 2 defines, plus it also defines its own property called address. So if I was to create a new class 3, I would have an object that has 3 parameters, or 3 properties rather.
Right.
Name, age, and address.
And if you were to create class 2, you would only have 2.
Yeah.
Yeah, and 1 would only have 1. That's fascinating. Now, from speaking back to polymorphism, I could cast up that tree if I did have a class 3, and it wouldn't lose those capabilities, or it wouldn't lose those properties. But because I'm casting it up and treating it like, say, like class 1, I don't see those.
You don't see those.
They are still there. I've just cast it up to look like class 1.
To a certain extent, what we've changed is the publicly exposed shape of that object, but we haven't really changed the essence of what that object is.
Yeah, that makes sense to me.
So do you want to bring up the understanding the virtual override and new demo, number 37?
Yeah, let's do that. So I'm inside our project, by the way, and I think in the first session we were talking about you can go to xaml.codeplex.com to download it if you'd like to go with us. Wait, tell me the number again.
37.
That's how far down we really are. Is it really 37?
It is 37.
Oh, it's right here, yeah.
Yeah.
I think you were in charge of numbering the projects.
Exactly. I started back from infinity.
Took a while. Yeah. But I got it. I was determined.
It's awesome.
Right. I was stuck on infinity minus 1 for a long time. All right, so what am I looking at here?
So basically what we have here is a set of classes. We've got a hierarchy of those classes, and we can see down here how they're defined. So we have base class.
Base class.
Which defines a method called name. And we've marked it as virtual. Now virtual basically declares that our intention is that this method can be overridden by inheriting classes. It doesn't have to be overridden.
Yeah.
And the reason it doesn't have to be overridden is there is a body, there is an implementation there already, and the method is not marked as abstract.
So here is derived override. So this is going to be the poodle, so to speak, right?
Yes.
And we can see that it has gone ahead and implemented this method for us, overriding whatever was virtual here. So we're basically saying whatever's in the base class, throw that baby away.
Yeah.
Right?
We are replacing that code block with the code block that now exists within this derived override
That is
class.
the power of override and virtual working together. All right, so now we have another class, derived new, and I see it's also overriding. Oh, it's not overriding. It's new. What is this keyword?
So basically, new is telling the compiler that we are replacing wholesale the implementation of new, and that it is completely and utterly unique to derived new. It has no relationship with the previous one. We can't invoke the base implementation of name.
Makes sense to me. And then we have one more called derived override.
Yes. Now this is interesting in that
there's no keyword here at all.
And there's no keyword at all. What we actually end up doing here is hiding the base implementation of the name.
I see.
And so we haven't said that we intend to replace it and you should obliterate it, but we've said that we are now hiding it just by virtue of declaring a name. So it's interesting that we're allowed to do that, because you think, oh, wouldn't that cause a problem? Now we do get warnings that suggests that we're hiding these things.
Because it is likely to cause a problem.
It is likely to cause a problem, and I would suggest using new if that's what you intend to do, so that it's much more declarative and speaks to anybody who maintains your code that this is intentional, not an accident.
So here I've created all 4 of these so that I can call that name in each of them. I want to see which one runs what. And so here I am calling all 3 of them. It's pretty interesting. Are they going to call the one that's inside their own class? Is it going to call the one that is in the base?
Why don't we run it and see?
Let's run it and take a look here. They all call their own. That's what we would have expected to happen.
That's what we would have expected.
Well, we haven't cast them anywhere. We're just using them as they are.
Yeah, we're referring to them as their base shape, their base or their existing type.
So look what we do here. Now I'm going to start casting them. Now I'm going to call base class. I can't cast that to anything. That's the simplest of all. I call name. Hopefully I'm going to see the same result of base class. But then I can call the derived, and I'll call name, and we'll see it's going to be very similar. But then what I can do is I can take derived new, cast it down to base class, and call name. And I can do the exact same thing to overwrite. That's where it's
actually, why don't you cast the
surprise.
derived override to a base class as well?
All right, let's do them all. So they all go back. Here we are. They all
how
go
finicky it is. You can't change code whilst it's running. Cool.
Yeah, the day will come. Well, you can't. Well, yeah, right. Okay. So here's the surprise. All 3 call from inside their own implementations, but now when you cast them back to base, 3 of the 4 actually execute what is defined and implemented in the base, not what's in the class themselves. And let's remember which ones they are. The first one, let's see, the second one is using new, yes, the second one is using new. Am I in order? There we are. Sorry. Yeah. The first one is
using override.
The first one is the base. There's only 3. Sorry.
Yes.
Yeah. The first one is using override, which is what you want to happen. But the last 2, new and kind of implied new.
Yep.
Both, when you cast them back to the base, act like the base only, and they lose that implementation of the derived class.
So what this is really showing is the power of virtual and the power of specifying that we're overriding that virtual method, because what it does is it says we wish to replace the implementation that is on that base class, and even if we cast back to the base value, i.e. even if we use the derived override as a instance of the base, we still wish our overridden method to be used in place of the one defined in the base.
Yeah.
We cannot do that if we declare new. That only works if we're using them as their existing type rather than casting them back to their base.
Now,
and I see a lot of people tripping over this.
It's an easy thing not to see at design time or at dev time. I mean, you just expect the behavior that doesn't happen.
Exactly.
And it's just a misunderstanding of how virtual works. Probably a very common one.
Yeah. The Visual Studio actually helps with implementing overrides. If you type the override keyword and hit tab, then you get a list of methods that have been marked as virtual that are available for you to override. That's the power of IntelliSense.
I'll tell you what's really powerful. So in slide 26 is we begin talking about generics, what has to be one of the most powerful pieces of, and new to CSharp just a handful of years ago, that allows us to reduce our code, right?
Yep.
And the reduction of code, again, there's a lot of benefits to it, but generics is special. Generics allows us to take a type and say it's going to interact with another type, but we don't know what that type is going to be when we make the definition of it. It's very powerful. What do you see with generics?
So generics, as you say, are really powerful, and I loved it when they came in C# 2.0.
Right.
I kind of mentioned the idea of this templated reuse of code, that you may have an algorithm that transfers across a number of different types, but there was no easy way to do it unless you had this base in class inheritance and so on and so forth, and you had this common object root, and then you specified that your method would receive this common object root, and you would manipulate it that way. With generics, it's possible to design classes and methods that defer the type specification until you're actually creating an instance of the class or method within your code. So one of the most canonical examples of this has always been around collections.
Right.
Prior to the introduction of generics, we would write an awful lot of code to ensure that a list only contained
Poodles.
Poodles.
Yeah.
You know, because by default, the
No doubt this was a big push for code generation too.
It was.
We're like, golly, I'm writing this collection over and over again. All I have to do is change the word, dachshund to poodle.
Yeah.
Surely I can have something build it for me. And what happened is, sure, you may have code generation, you may not, but what happened is you ended up with millions of lines of code.
You did. A huge amount of code bloat, which really increases the impact on your development, because say for example you want to change the implementation of your list. Now, because you've had to create all of these specific list implementations, you've got to change it everywhere.
Yeah.
Which is a pain in the backside.
Yeah.
So the language designers recognize that, and they introduced the concept of generics.
Now I'm looking at the code sample, and it's clear enough, right? At the top is the array list. I'll bet a lot of developers have forgotten the array list.
Yeah.
It's just one of those things that, especially because of generics, we just don't get into anymore.
Exactly.
But array list is just a list of objects.
Yeah. It's kind of, as the name suggests, it's similar to an array, which tends to be constrained in its definition, that you create an array.
Has an add method and things like that. It's very powerful. And so an array list, remember, everything inherits from object. That means I can put absolutely anything into an array list. And so the array list at the top allows me, I could put 1, which is an integer. I could put 2, another integer. That's what I expect. But I could also put the string of 3. And so now I've introduced a new type, but because everything goes back to object, it's okay. Right?
Exactly.
Because it's a generic kind of list. Now, the second sample is really cool because that shows the implementation of list that is generic. And so it's dangerous, I think, to use an array list because you never know what you're getting into.
You don't know what it is.
As you iterate through that list, you always have to check. Is this really an integer? Then I can use it like an integer.
I mean, what you've got there is the declaration, the variable name, objects, tells you that it's going to be objects. But say you turn around and said the variable name was dogs, you would imply from the variable name that it only contained dogs. So
Right.
when you took it out and tried to cast it from an object to a dog, and it threw an exception, you're in a lot of trouble.
The developer is really at the victim of this.
Exactly.
Generic solves it. It allows us to say it's like an array list, we just call it a list. But now you can see those brackets there defining that the internal members are only integers.
Exactly.
And so now, not only can I trust what is inside it, but I also can't start goofing around with it. You can see that the underline in red there is Visual Studio telling us that that list can't take a string. And what's beautiful about it is where before I might have I would have passed compilation, would have built, my testers would have discovered the problem. Now I can discover it at compile time.
Exactly. One of the other key things that we kind of brushed on a little bit earlier on is this concept of boxing and unboxing.
Yeah.
And generics really helps with this as well, in that boxing may be a little bit difficult to get your head around initially, but it's the idea that you have value types and you have reference types. You can take a value and treat it as an object.
Right.
And when you do so, that is called boxing.
Yeah.
Now the problem with that is that takes time. That takes effort from the runtime environment in order to take a value type, create an object, and copy that value into that object. And so there's computational effort associated with that. The other challenge is it can get complicated to track what's going on with that. So if we look at the example here on the right hand side, we have a value type of int count, which is equal to 1. We've created an object called count object. We then assign count to count object. Now from the developer's perspective, that's a simple assign. How hard can it be?
Right.
The
And we know
compiler,
an assignment is saying now they're the same thing.
Yeah.
But it's not.
But to the compiler, it goes, uh-oh, count is a value type. I cannot just assign that value type to an object because an object is a reference to an object. So what it has to do is it has to create an instance of an object and then copy the value of count inside that object, then set count object to point to that object in memory. Okay?
It's brutal. I mean, you really are looking at two objects now.
You are.
You want to change the value, you got to change them
You've
both.
at least doubled the memory space associated with it.
And which is really getting to the danger of not understanding boxing and unboxing.
Exactly, because if we imagine you're doing this inside a loop that was being run 100, 1,000, 200 times. You're doing that overhead every iteration through that loop, which is a bad idea.
Right.
The other thing is you've now broken the relationship between count and count object. If we increment count, so we're using the plus equal syntax here to turn around and say count equals count plus 1, count is now equal to 2. But because there is no connection between count and count object is still equal to 1, which was the initial value that was copied in.
So
that may be counterintuitive when you're just thinking about things from an object perspective.
Oh, it is. It absolutely is, because I think everybody thinks reference types. In their brain, they are always thinking reference type.
Exactly.
And I think it's fair to say sometimes you have to box and unbox.
Sometimes you have to. What you need to be is strategic about when you do it. Don't put it in the middle of a loop and so on.
So what we want to avoid is boxing as much as possible, and that's kind of where we get to generics.
Yeah.
Generics allow us to not have to reassign values, because what we're really doing is saying this is a type of types, and we're going to interact with it later, right? And so I can define my class, I can define my interface, I can define my method.
Okay. We actually got a question that came in that was asking us about a practical reason for overriding. Can you think of a practical scenario for an overriding method?
I can, because what you could do is you would build let's say you build a base class that interacts with a database. And there really is a generic way to interact with a database. So you have a handful of methods. But then you build a derived class that inherits from that and uses all of that niceness that you gave it. But this one type of database really has to be interacted with this special way. I have to override and throw away the implementation in the base and make it completely unique when I interact with it when I'm interacting with this type of database. So that's a practical use of override, where it is imperative that we throw away the implementation in the base.
Another key scenario could be where we need to do something incremental to what the base does in that scenario. So we could actually have an overridden method that implements, say for example, we have dog and poodle, and a regular dog we don't shave, but a poodle we shave.
Right. So you have a take care of method.
Exactly. And so there's a basic take care of, which takes your dog for a walk and feeds your dog.
Yeah.
And all dogs have that. But with a poodle, when we take care, we shave as well as do whatever is going on walking and feeding.
If you don't override, then you create a scenario where you have a poodle that never gets shaved.
Exactly. So we could override that method, and then within that override, we could then call the base implementation using the base dot
and screw everything up. You got to be careful so that override allows you not to screw everything up.
Exactly.
It says no matter how they cast it, obey this pattern.
So hopefully that answers that question. We will come across it in many other scenarios as we go through the day, for sure.
Yeah. So when we talk about defining generics, let's jump to the breakfast example. It's a pretty good one, where we have some simple inheritance. So at the bottom it's good. So we have offspring, and we have both an egg and a piglet. They're both a type of offspring. They really are.
Absolutely.
I mean, we don't know what they belong to, but we're preparing it. So you can see we have the egg class and the piglet class.
So I noticed that the offspring class is marked as abstract.
It is, because I don't want to, there is no such thing as offspring, but there is such a thing as an egg, and there is such a thing as a piglet.
So we're using the offspring class really to group things.
We are.
And so they're associated.
That's right, and that's important when we get to generics. Because if you don't have some commonality between them, you have to fall back to object.
Exactly.
We don't want to fall that far back.
And a generic class that can just do toString isn't very useful.
It's true, it's not. Good. All right, so here we have the breakfast method, and the breakfast method creates two things. It creates both a bird and a pig. What's cool is what it's really creating is an animal, and the animal then is a generic type class that's asking, you can pass in the type, and the type is really asking, what type of offspring does this animal have?
So
cool. I'm passing in, as I create the bird, I'm passing in an egg.
So why couldn't I say pass in dog to animal?
Well, this is important because I don't want to, first of all, that would just wreck everything.
Yeah,
I mean,
I have that for breakfast.
I mean, good gravy, the whole time-space continuum thing. So the reality is I want to be able to constrain it. So generics say, pass in the type and tell me what to do with it. But the where clause allows me to say, this type is going to be of a certain implementation. It could be a specific base class. It could be an interface as well. I mean, there's a lot of ways to constrain it, and you would want that, right? You don't want to pass a dog in as the child of an animal. You want to pass a puppy, let's say. And a puppy would surely implement or inherit from offspring.
Yeah.
And so because we've constrained it to where to the offspring.
We're not advocating a puppy for breakfast.
No, we aren't. Let's be clear that this is the breakfast sample, and in no way are we eating
puppies.
Puppies, that's right. So now we've created a bird, and bird is a strongly typed animal that has offspring of type egg. It's very powerful.
It is.
Because now, I mean, imagine if I were to do this any other way, I would have to fully implement dog. I mean, sounds gross. The fully implement bird, fully implement pig in order to have that.
This is a bad scenario.
Why'd you bring up dog? Oh, it doesn't matter. Anyway, so it's nice because look, I can define this class now in 3 lines.
Okay.
A lot of goodness there. All right, let's look back.
Let's look back. So that flew by. And during that time, we went through the scenarios of how you would create complex types, how you can interact with those types.
Keywords that make them very special.
Exactly, how you can constrain interactions with them, when they can be instantiated, if they can be instantiated at all.
Right. And some you don't want to be instantiated, including static.
Exactly. Then we also talked about object interfaces and inheritance and kind of described how we can share behaviors from a base through all the derived classes.
Or define a contract that describes what that object is, but doesn't offer its implementation yet.
Absolutely. And then we talked about generics and the power that generics provides. And again, we can only lightly touch on these things. There is a lot more to learn and a lot more to do with generics in terms of you can create generic interfaces as well as generic base classes and so on. It's a very, very powerful topic.
It's not that you need a lifetime to master, but you probably need more than the 10 minutes we gave it.
Absolutely.
Absolutely, no doubt. All right, that's it for this module. We'll come back to module 3 in 10 minutes. And between now and then, go take care of business. Welcome back. This is Microsoft Virtual Academy C# Fundamentals Prep. This is module 3.
3.
All right.
It's already been a long day.
It's great.
Exactly.
All right, so we have a lot to cover again, and we'll do the best that we can. Let's begin with kind of an agenda here. What are we going to cover?
So the key objectives we're going to address in this particular module is controlling programmatic flow. So really drive into how you can control what executes and when. And then we're going to revisit manipulating types and some of the ways we can control that, and then manipulating strings.
Pretty valuable. This is something that developers do all the time.
Exactly.
All the time. These are the fundamentals of fundamental. Keep going.
So, controlling programmatic flow. The C# language includes many statements that can help you control program flow. You've got 3 primary classes of those statements. You've got your selection statements, and examples of those are if, else, and switch. You also have iteration statements. Iteration statements allow you to repeatedly execute blocks of code, and you can implement logic to control those. And then you have jump statements.
And jump statements allow you to break that flow.
Exactly.
So something is going on, and you want to interrupt it for one reason or another. And all of these different ones like break is probably the easiest, continue, and continue is great actually because it allows you to go right to the next. And then return.
Optimize an algorithm basically.
Yeah, that's exactly right. And to hop through an iterated list. And then return, of course, for those methods that are returning something to the caller. And so there's more than that, and we'll go through all of them.
Sounds good. So let's have a look at the if statement. So the key thing about the if statement is it evaluates an expression. And this expression must return a Boolean value, either true or false. There's no truthy or falsy here. This is just true or false. And
or falsy.
It allows you to make a decision around which block of code you're going to execute or whether this block of code is going to execute.
If statement obviously is important because there are times when you don't want something to happen. So you just wrap it in an if and you create the Boolean expression.
Exactly. So if we look at the sample code on the right-hand side here, we can see if value is equal to 1. Now you notice that there are 2 equals there. That indicates that this is a Boolean equality check as opposed to an assignment. If you had a single equal there, we'd actually be trying to put 1 into the value. Interesting thing about the C# compiler is it knows context, and it will not allow you to do an assignment by accident. In C, you could actually do a assignment in this scenario where you could say value equal 1, and it would actually return the value of that expression, which would be 1, which the C compiler would turn around and say equals true, and would then actually go and process. The C# compiler prevents that by turning around and saying you cannot do an assignment here, it has to evaluate to a Boolean expression.
So I see if, and now I see else if, and I see else. That's the full family of the if statement?
That is pretty much the full family. You can embed ifs within ifs, but this is one of the most common scenarios that you'll see. And so what's going on here is this is kind of an efficiency play.
You mean else if is?
Else if.
So else if isn't just kind of syntax candy. It's not just something you do because it looks cool.
If we actually look through and look at this whole string of commands and work out exactly what's going on, we can see, first of all, it's evaluating if the value is equal to 1. If the value equals 1, then it'll do console write line 1.
And then it evaluates else if?
Then it basically exits. As soon as it hits the else if.
This is the efficiency. Because
the first expression was true, it executes that body and then moves beyond that entire block of if statements.
And I might want that efficiency because this is very, very simple, but it might be a Boolean that says, is anyone on the first floor? And it goes through a bunch of sensor arrays and detects, right?
Yep.
And no. Okay, so else if anybody on the second floor, another expensive, and you want it to stop if there is somebody on the second and not do the third, fourth, and all the way to the 100th floor. You want to be able to narrow that down. That's the difference of serial ifs versus else if.
Exactly. The else if is optional evaluation of the secondary and tertiary and so on expressions in the if block.
And else runs if all of the evaluations don't pass.
Exactly.
Nothing is there.
It's your catch-all. So if no preceding expression is true, then the final if statement, or the else statement, I should say, will execute that body.
And just like we have shorthand for everything, we have shorthand also for a simple if statement. And this is the ternary operator. And the ternary is fantastic. I love it. I think it's a quick way to be able to bring your code up. It can be overused. You know, you definitely don't want to nest them. I've seen that, and it's hard.
Some people hate it. Its roots, it was in the C language, and so because C# is based on the C language, it inherited that capability. But in effect, what you see on the right-hand side here is an if-else block, plus you see the implementation of a ternary within the console write line.
So those two are identical.
They do exactly the same logic and result in exactly the same output.
So you can see why you would want it, because it collapses your code and makes it skimmable and maintainable.
Yeah,
but be careful.
And you basically read a ternary in the same way as you would read an if statement. So you can see there's an expression there. So you'd say if value is equal to 1, do 1 or not 1.
And then what's the syntax for else if in a ternary?
There isn't.
So that's what it's just for the simplest if statement. You can kind of nail it. I use it a lot for value assignments. You're going to assign it to this if that. Easy enough. That way you can have a default or some sort of fallback.
Exactly.
Okay. Let's combine the next demo together.
Okay.
And talk about do whiles for a second, and we'll pull them all together in one.
Sounds great.
Do whiles are just while loops in general. They show up everywhere, right?
Yep.
A while loop is important for when I'm evaluating a Boolean statement, exactly like an if statement would do. A while allows me to continue doing it again and again and again while it continues to return true.
Exactly. So it's effectively repeats the expression evaluation each iteration to determine whether something must continue, and you have that body. Now, there are the two syntactic styles here. There is while, and then there's do while. The key difference between these two is that the while statement evaluates the expression first before executing the body. So if that expression is false, then the body may never execute, or if it's false, it will not execute. So
Can I type something for a second? What if I do this? What if I do a while?
Just cut to his desktop.
And I do let's say a console write line of Darren. What if I could do this, right? A Boolean true true is true.
Exactly. And this will run forever.
That's right. If you're wanting to burn down a machine, this is a great way to do it. But don't console write line. Do something very, very expensive.
In fact, this is reminiscent of the first program I ever wrote, which is, there's a store in England called Dixon's, which had computers in it. And when I was a kid, everybody would go in there and do, it was in BASIC, so you would do print your name, and then say go to 10, which was the same line as print. And so your name would be scrolling up the computer, and you'd be like, yes!
It's developer vandalism.
Exactly.
Nice. All right, so I could do the same thing. If I have a variable, it's brutal not to do it like that.
Exactly.
How many times have you done like even for if, you say if false, right, so it doesn't run, so you can do some debugging.
Exactly.
But here, what you would do is say something like this, or you would make it based off something. You want to end a while.
Exactly. I mean, there are times when you use these looping constructs, particularly in message-based systems, where you're starting up an application and it's going to keep running through. But what you want to ensure is that you have something that pauses your processing, because otherwise you'll tie up your processor all the time as it's going through that loop time and time and time.
I don't want to say it's an amateur mistake because I make it all the time, which maybe is okay to still say, but it is certainly a new developer mistake that happens frequently, that you don't realize a while holds the process.
Exactly.
And it can really kind of mess up the performance of your application. Do while's a little different. It's just the reverse. It makes sure the first one runs, and then it continues to operate like a while after that.
Exactly.
Makes sense to me. So now we have iteration statements, and they're kind of like a while, right? Because they do allow you to repeat. And so we have for. That's the iteration statement, I think.
Sure.
And so if we were to look at a for, let's look at the demo for a second. If I had a simple for, and I love using this snippet for this because, getting the semicolon in just the right place, sometimes I don't get it right.
That looks like code generation to me.
Yeah, well, it's not though, right? It's just a snippet coming from Visual Studio. And anyway, so a for, the syntax around for has 3 core pieces. Mm-hmm. Basically, it's starting point, and so that's where I am right now. I equals 0, and so this is going to iterate through a series of numbers, and it's going to begin at 0. The next one is going to be the condition of when it's going to stop, and so until is kind of what.
So that condition is being evaluated each iteration?
Every single time.
Okay.
Every single time, and it's interesting because it evaluates the variable, but that condition can be very complex if you want it to be.
Yeah.
And then I++ is basically saying after you read it, add another, increment it by 1, and so it continues going to 0, 1, 2, 3, whatever it is.
Oh, is that another of those shorthands?
It is certainly a shorthand.
Oh, that's awesome. So if we wanted to just go through this loop 10 times, what would we put in for length?
We would put in 9. It's 0 based.
No, because we got less than.
Oh, we have less than, yeah, so good. Yeah, thank you, that's perfect, yeah. So you could change it to this and then mess up your logic. All right, good. Right, so 0 to 10, it would never hit 10 because it starts at 0 and does less than.
The other interesting thing is here, you could also, during the initialization clause, you can actually initialize more than one variable. So you'll see a canonical example would be int I equals 0, comma, int j equals 0. And then on the increment side, we could also be incrementing j.
Which is
it's a comma.
A comma semicolon. There we are. Thank you.
So basically, you can go through and evaluate multiple variables and iterate through at the same time.
Yeah. A lot of interesting power there. Now, this is good, and you would do this a lot. Like, I have to do this 10 times. I have to go through a list of 10, and I want to reach out to them. But I can use other iteration statements as well, right? So
exactly.
I would say one that is very common, not for, but
for each. And so for each is very interesting in, it speaks back to collections. And so a collection are those lists that we were dealing with earlier on. So a list of T, a list of ints, and so on. Effectively allows you to move through anything that is enumerable. And there is an interface called IEnumerable that these collections implement that allow for each to work over those.
Collections, lists, arrays, everything is enumerable if it holds more than one.
Exactly.
Yes, and so now I say for each, and what's nice is, if let's say these were, this is a list of dogs, I can, these would be objects that I would be iterating through. That's very valuable.
That's an interesting syntax you've got there. That's an initializing list.
It is. This is yet more shorthand, isn't it?
Exactly.
Yeah, I could, instead of creating an array and then adding to it, I can create an array and in its initializer give it its initial members. And so that's what I've done.
But what type is var?
In this case, it'll talk about, whew. Well, var is a new array, and the array is of type integer based on what I initially give it.
Oh, so the compiler has implied what you mean.
This is one smart compiler.
Exactly. So this is part of the developer productivity that's going on. There could have been a whole bunch of typing that...
In fact, let me just go and show. This is the same, that I can explicitly say that it's an array of integers,
Yep.
but it's inferred based on its membership that
Exactly.
I've given it. And then I can go even further, and of course, I don't have to use var. I could explicitly say the type, and I could go even further to stop it here and start adding to it, changing its size, making room for it in the array. Very difficult, time consuming.
Exactly.
This
I mean,
kind
you
of
could turn around and say, the array has a size of 7, and then assign each of those values to the index.
That's right. That's exactly right. It's there as well that it says it can hold 7, all implied in the constructor.
Exactly. So as you can see, really, really powerful from that perspective.
Not a for each loop, but nifty nonetheless.
Exactly.
Yeah, absolutely. Okay, so now I iterate through it, and I only iterate through it one time, and that gives us some neat things that we can do. If I'm inside this list and I say, if item, because remember, item is going to be the individual ones that I loop through them. I can say if item, and I'll just check to see if it's even or odd. And so let's say it's odd, and this is the modulus operator. And so
Excellent.
if modulus 2, which would mean it's even, and then I can say continue. Now this is an interesting keyword because it allows me to say all the other stuff that I've got down here, which is all the hard work, doesn't need to be done for even numbers.
Oh,
right?
so we're just skipping. We're skipping straight out.
That's right. I don't want to jump out of this loop. I just want to jump to the next one.
Oh, okay. So say we were on 1. 1 wouldn't be an even value, and
Right.
so we would loop back round and move to the next item in that list.
That's right, and it's handy because I don't have to say go next or anything like that. I don't have to have a gigantic if statement that wraps everything in it and makes sure that it's odd or even.
That's very succinct.
Let's say that once I hit, let's say it's not going to be even. If item equals 5, I need to stop. Right? I want to completely stop. So I want to break out of this loop altogether.
Okay.
I want to break out of this loop altogether.
I see what you did there. That's clever.
That's a triple entendre. And so right here, where I have continue, I'll say return. And return, that will break it all. That is not what I meant to type. But that is a type of break statement.
Well, return will actually exit the X method, won't it?
Yeah, so if I had to do this would be done on every item, and when it's finished, it'll to do more. But if I pull a return right here, it exits altogether, and the method stops execution
So that really
altogether.
jumps the execution out of that method back to the caller.
That's right.
That's awesome.
So return is amazing, right? It's basically stop here.
Yeah.
But what if I didn't want to do that? All I want to do is stop going through the
You
list.
mean you still want to execute your to do more?
That's right. I still want to execute to do more. How do I do that, but still stop the for loop?
Do you want to break it?
I want to break it. I've broken code my entire life.
Exactly. Despite the compiler's best efforts.
That's right. It's me versus the compiler.
Indeed.
And so it's simple enough. I just say break. Break says to the compiler, whatever you happen to be iterating through, stop. And go to the line that's right after it. And so basically, this is a jump statement that says go to whatever is right after it. I could, I suppose, use the keyword go to. I'm a VB developer, so I certainly know go to. We had go tos everywhere. And go to allows me to set up a label, just like it did in VB. Set up a label and say go to label, right? And I could set up the label down here, like so. That's the way it works. It would jump exactly the way I want, but there's no implementation, so here I put a return below it. What is the problem with the label? I don't see this syntax in developers' code, even though it's supported. It seems odd. I think, for one, it's there because of kind of the legacy.
C legacy, yeah.
Yeah, the legacy of the language.
Absolutely.
But we don't see it though.
We don't.
We don't.
Pun intended.
We don't see Sharp. We don't see Sharp it.
We don't see it, and it's because we're striving in our code to be very predictable about our execution paths and where we go.
Is that right? We're 40 minutes over? That can't be right.
Oh, no, we're not. We're not distracted.
I'm like, wow.
We have a countdown here that tells us how much over we are, and we've been over some, but we were surprised to see 40.
We're setting a record.
Okay, coming back to where we were. So labels, go-tos, and so on.
Yes.
So we're striving to make our code readable, and we're striving to have very clear execution paths through our code. Go-to allows us to disrupt the execution path and jump around. We could have label could actually be above the for each, and go-to would push execution to be preceding the for each, so we go back through the for each again.
Yeah.
That would be confusing, wouldn't make much sense. And so what's been...
And potential for all kinds of trouble like infinite loops.
Exactly. And so what's been found over time is generally it is a poor idea to use go-to.
Now let me restate it with a little more passion. I am yet to see a scenario where go-to is the appropriate final solution. It's just the way it goes, and you can use them and they'll operate the way that you expect them to operate. But there are many other conventions and many other constructs inside C# that honestly, they are the better solution when it all boils down to it.
Sure, there is an interesting scenario in the switch statement, which we should demonstrate shortly.
Yeah.
Where you can use go-to case within a switch statement to actually jump to a different case within the switch. So if you had a certain set of values where you wanted to combine these two case statements, that you want both actions to occur for a specific value, then go-to case can be used to redirect from one case statement to another. But again, it's very much an edge case. And
you know what? I don't even want to talk about it anymore.
To Jerry's point,
I do not like go-to.
To Jerry's point,
I don't like it at all, Darren.
I'm going to hit you. To Jerry's point, there are not very common scenarios where you want to use it, but it's there, and so we touch it.
Well, it's important to understand it because you might run across it. Yeah,
yes.
You don't want to be confused by it for sure. Now, I could return that would stop the execution of this method, but I could also stop execution of this application. I could throw an exception that can really cause some damage, but it's another way of jumping, right? So I could say throw, and you can't just throw. You have to throw something. What are you going to throw?
An exception.
An exception. Oh boy, there was almost a visual. So I've just thrown an exception. Of course, we'll talk more about what exceptions are in a little bit. But this is certainly a way of interrupting flow.
Now, you mentioned before that this would exit the entire application. Mm-hmm. That would be true if it wasn't handled.
Oh, that's exactly right. I mean, honestly, we're a little bit ahead of exceptions, but certainly not handling an exception is the way you terminate an application by mistake. But exceptions can also be, they aren't necessarily a violent way of using it. That can be a good way of communication, depending on how you actually use it. If you have a violation of access or some sort of security violation, an exception may actually be the right way. So only your code that handles those exceptions properly continues, and anybody who's tinkering with your app, they get an actually thrown exception that causes all kinds of mess inside their app. Exceptions are powerful. We'll talk about them in a little bit.
Absolutely.
All right, so this is more about throw as another jump syntax. Excellent.
So we needed to do a quick demo of the switch statement.
Yeah, so let me pull up and build one real quick. And it's nice, there's a couple things that you can switch, by the way. A switch statement is sort of like an if statement, wouldn't you say?
It is. I mean, basically, you would use a switch statement when you had a number of different conditions that you wanted to check. It's a much more efficient and succinct way of stringing together a lot of those checks.
Let's see, I have a dog named Barney, Lassie, I'm trying to think, Snoopy. Think of another dog? I need one more.
Old Yeller.
Yeller. How do you spell Yeller? Yeller?
That'll do.
Yeller. All right. I've never heard of a dog named Barney. I'm a little embarrassed by that one.
Okay, then you should probably spell Lassie with 2 S's.
Are there 2 S's in Lassie?
See, everyone's a critic, isn't it?
All right. So we'll start with a switch statement, which is sort of an if statement, of course. But one of the things that it really uses, or really goes against, is enums. Enums are a way of us to create strongly typed options. That's a great way to think about it. And what?
I'm just wondering why the compiler's complaining.
Is it? It's actually asking if I want to do a symbolic rename from Lassie to Lassie.
That's crazy.
All right, well, let me...
That's because it's so helpful.
All right, so now switch state, the syntax for switch is actually very simple, but this is where a snippet really does help.
Yeah, exactly.
Because, so let me type switch, because that's what I'm going to build. And I'll do a double tab. That's how we do snippets. And right now, this is the base implementation of a switch statement. But now I'm going to say I want to make a switch statement against the dog's enum. So I'll say dags. I'll say dogs, actually. And as soon as I do, it will look at all of the possible values of enum and then break it apart like this for me.
That's
now,
pretty powerful.
It's really powerful. Well, it certainly saves a long time, especially on an enum that has several members in it.
Indeed.
Yeah. Now, the first thing you would do is remove that, because you can't do it to an actual enum. But I would say there's a variable that says, some type of dog equals dogs dot, and then we'll say it's going to be Snoopy.
Awesome.
Yeah, so far so good. In fact, just to make it clear and nice, I'll call him Snoopy. And that will be what I'm switching on. And the switch, in a lot of ways, is if else this, if else this, if else this, if else this, with the break to indicate don't continue.
Okay. So what if we wanted to treat both Lassie and Snoopy the same? How would we do that?
So first let me implement Snoopy, and then I'll show you exactly what's going to happen. So here, let's say it's going to be a console write. It'll say, hi, Snoopy. And now, this is all right, but yeah, you're right. Lassie comes in, and so we'll make it more generic so Lassie doesn't feel bad. Lassie comes in, nothing is said to him, right? Only to Snoopy so far, but we want both dogs to be able to have a little greeting. So I can take this break, and what actually happens is it falls through from one case statement to another. So although I haven't implemented Lassie, what I really have done is I've implemented Snoopy and allowed Lassie to fall into Snoopy.
So what if you had a hi Lassie underneath dogs.lassie? Would you be able to remove break and fall through to Snoopy that way?
Like this?
Yeah.
Well, I wouldn't.
Okay.
I wouldn't. As long as there's no implementation, I can fall through. As soon as there is any implementation, I have to implement break and close the body, basically.
Okay, so if we wanted to do call the Snoopy afterwards, this would be when you would use that hateful construct called goToCase Snoopy.
You could. I won't. All right, so now let's say somebody comes up here and says there's one more dog. One more dog. It's Fido. Fido comes in. Now, I don't have a case statement specifically for poor Fido.
Oh, goodness.
So what happens now when somebody comes in and they define Fido? The switch statement is looking for Fido. It says, is it Lassie? No. Is it Snoopy? No. Is it Yeller? No. That's why we have default.
Okay.
Default is sort of like the else in an if statement. However, default is optional. I don't have to do this. What I often do is, if I have a default, I throw a new exception of some kind that says not supported.
Okay, so you're basically giving a hint to any developer that comes in that this was an unexpected or unhandled situation,
right,
and you want to, they should be dealing with it.
Right. It's not necessary that you throw a not supported exception, but it's a good way of communicating back to the developer that they're in territory that isn't covered by this code.
So really what you're advocating there is a sort of defensive programming stance, that whenever you're coding and building methods and so on and so forth, don't think about just the golden path execution. Also think about, okay, what could possibly go wrong, and put some defensive aspects in there.
Yeah, you got it exactly right. That's
awesome.
perfect. And it's interesting because now it's telling me, see this little green underline, it says unreachable code detected, and it goes back to what we were talking about in that jump statement.
Yeah.
Throw stops execution. So it's saying it's never going to reach break. Actually, it's never going to reach anything after it. And so that's the end of that. So why have break there? You don't have to. It understands that that's another, that throw takes the place of break.
So basically each case clause needs to be completed by a jump statement.
That's exactly right.
Okay.
That is exactly right. I could put a return, I could put a throw, I could put a break, whatever it is, I just need to end the body somehow.
Okay, that's awesome.
Yeah, it's very powerful. And again, this is just the compiler helping us out. That's why it was underlined in green instead of red. It would still go ahead and compile. All right, so I see that we're going to be talking about casting. I want to kind of build out a scenario again, and I want to do some inheritance, and then I want to kind of cast into those so we can see what they do.
Okay, that's awesome. Just to point out to those guys who are sort of following along with us, we're skipping some of the slides because we want to spend as much time as we can in Visual Studio and sort of show you these things being developed live. So all of the content will be, or is in the deck and so on. It's just a lot more interesting, I think, for you guys, for us to actually be working in Visual Studio.
Oh yeah, absolutely. I think so too.
Yeah, it's more fun for us too.
Developers, this is how developers think. You know what I mean?
Exactly.
It's just right in their language, and it just makes more sense.
Yeah.
All right, so I've done something fun here. I've created 3 classes, animal, dog, and poodle. You can see the hierarchy coming. So we have the base class of animal, and then a dog inherits from animal, poodle inherits from dog.
Awesome.
What should we do next?
Well, I think what we should do is just sort of experiment with some of the casting and see which ways we can cast and which ways we can't cast.
Yeah, I think that's a great idea because you'll be surprised to see what you can't do.
Exactly.
that's for sure. Let me create a little. Keep going. I'm going to just.
So why don't you create a method that takes a type of animal as a parameter, and then we can experiment with what we can call and what we can't call and so on. That would be interesting.
All right. So I'll create a method. Isn't that funny? Boy, that's a.
I'm in your mind.
It takes an animal, and so the type that's going to pass in is animal.
Yep.
And there it is.
Okay, awesome. So up in X, why don't you start creating some instances of these types?
All right. This is going to be a dog, and this is going to be a poodle.
Hope you're enjoying watching Jerry type as much as I am.
Are you?
Yeah, it's awesome.
I know it.
There's actually been a very few typos, which is
It's just crazy because
good.
this keyboard is it's
You're obviously
virtual.
not thinking about the thousands of people that are watching you type right at this very moment.
That would be the last one that's typed correctly. All right, so here we are. I've got all 3 of them, and now I want to call take animal. It doesn't really matter, right? Just, I mean, this is just something.
Okay, yeah, sounds good.
And so now I'm going to pass in, and what can I actually pass to take animal?
So the parameter is specifying that it will only accept arguments of animal.
So I know that will work, right?
Yep.
No red underline? No red underline.
Once it catches up.
Yes.
Okay.
I'm faster than the compiler.
That's incredible. It seems incredibly unlikely too. But we've been talking about this object inheritance, and what we've said is, well, a dog is an animal, and we've stated that in that inheritance right there.
That's right.
So why don't we try and pass dog into take animal as well?
All right, DOG, red underline, doesn't appear.
So what we're finding out here is because dog can be treated as an animal,
good,
and it is supported through the inheritance structure, we're actually able to pass a dog to a method that takes an animal.
Yeah.
That's really interesting. Why don't you define a couple of properties in, say, dog or poodle?
Oh, okay, sure. Let's see, all animals have, here we go. You killed it, man.
Exactly. That's
all animals have temperature.
Okay.
Let's say, because they're alive. All dogs go to heaven. All dogs have a name. And a poodle has a shaver. All right? The person who grooms them.
Exactly.
A groomer.
Groomer. That sounds better.
Yeah, then shaver's funny. All right, there you go.
Okay. So now we're inside take animal, and we've got an instance A. So what can we do with A?
Well, we can treat it like an animal.
Okay, so what does that mean?
Well, because it's only an animal at the highest level, the only thing I can really do is interact with what's defined for the animal. Not dog, not poodle, so we have temperature.
Okay.
So A.temp, there we go, A.temp equals 10.
Okay, that's interesting.
Yeah.
But what we've said above on the line, I wish we had line numbers,
Me too.
the take animal has been passed a dog.
We're going to have line numbers now.
It's incredible. It's almost as if you understood what I said.
Did you see that quick launch up there? Visual Studio 2012, new feature, very awesome.
That's very awesome.
Very
Sorry
awesome.
for all you guys who are still on 2010.
Wah, wah. All right,
So-
I'm passing in a dog. I'm not passing in just an animal.
You're passing
There's
in
a
a
lot
dog.
of fidelity to a dog. I want that.
Exactly. How can you get to it when you have just an animal
So
inside that method?
I'm going to guess var dog equals animal, and then I'm going to cast it. Of course, I know the casting syntax.
So do the casting syntax. See what,
As dog.
well, let's try the other one. Let's try the one with where you try and cast it first.
All right, let's do it like this. Dog. So two types of casting, both cast to another type.
Exactly.
Go ahead.
So if we look at that, is that safe?
It is safe.
It is safe.
It is safe.
What if we just passed in an animal?
if I did just pass in an animal, it would not cast. And for that reason, it's safe. But it's not safe as far as the stability of my application.
Exactly, because what would happen?
It would not only would it fail, it would raise an unhandled exception that would just blow the world apart.
Invalid cast exception.
Right.
And so that could be problematic in terms of if we want take animal to be able to go through and reach into implementations that are in dog and implementations that are in poodle.
Which is nice. If I had dog dot, I do have name, which is special only to dog.
Exactly. So you could get that. So how can we, within the context of take animal, perform a safe cast that doesn't interrupt our program execution?
We we want to have the same effect, but we want to do it safely so we don't raise exceptions and blow up our application. Perfect. All right. So I don't want to do it this way. Perhaps I want to do it this way.
I love that dog name, by the way.
Yeah, it's good, isn't it? It's real catchy.
Exactly.
There we are. All right, so here we have, instead of putting the type in parentheses before the object, now we say the same object as the type.
Okay, so that seems pretty awesome. But what if A isn't a dog? What's going to happen? Say if we passed in a poodle. What?
Well, what we do know, because partly we were just talking about it, is it's not going to raise an exception. What I don't want is for something to just blow up for me. But I do need to test it still.
Yeah, because what is dog going to be right now?
It is going to be null.
Oh.
And null is going to represent failure.
And so what happens
So
if
let
we
me go
try
up and make a quick change. I'm going to pass in a poodle. Right? Poodle cannot cast a dog, but it can be cast to an animal. So I can pass it into the method, but I can't cast it to a
inherit
dog.
from dog?
Poodle, darn, this is too deep. Yeah. Let's see, I need to change it to bird.
No, do dog.
I'll just pass in the animal. The animal cannot be passed.
Okay, fair enough.
Yeah.
Yeah, exactly. Okay, so we would have dog equals null. And what happens if we try and invoke a method or a property on a null?
So right here, setting dog's name to Darren would fail. I would get the exception then. It would be a null reference exception that says dog is null.
Okay, so clearly we want to protect ourselves against that happening.
Simple if statement. If dog does not equal null. And this is my way of communicating with that as cast to make sure that it returned an actual value.
Yeah. Now say we had a whole bunch of expensive operations that we were going to do. We could encapsulate them all within that dog equals null, but say we wanted to preemptively check, is A dog?
Right, before we do anything, don't set it's a null, just don't do anything.
Yeah.
Yeah, exactly. But now we would precede the line with a check to see what type it really is. Now we know it's an animal, but it could be a dog, it could be a poodle.
Yeah.
All right, so what do?
We use is.
Is and as. They're all very good friends with each other.
Exactly.
All right, so if it is a dog, then we do some operation inside it, if animal is dog. Right, so we could do it just like this. Now, none of this would run if it's not a dog in the first place.
Okay, so we know that that A as dog will evaluate to a dog.
Yeah, that's exactly right.
But the interesting thing is A is dog just returns a Boolean. It actually doesn't do any casting or anything in and of itself. It just tells you whether this is a valid action. And
it chases up and down the hierarchy tree for you. It's very powerful, actually.
That is powerful.
Now, you might think that now we don't need to have if dog does not equal null, but null can actually be of a type as well.
Time flies when you're having fun, huh?
It really does.
It does. It's what happens when you start off with negative 40 on your timer.
That's exactly right. Is and as are pretty powerful that way.
Exactly.
Okay, so this is interacting with types, casting them, moving them around through the hierarchy. Let's do something with something else. Let's deal with strings.
Yeah, strings is a very common scenario where you need to manipulate strings.
Yes.
And so there's very rich support for string manipulation within the platform. But there are a couple of key concepts that you should bear in mind, because again, it can be expensive if you don't bear this in mind in terms of what you're doing. So a string object is immutable, and what that means is you cannot change a string once you've created a string instance. That seems counterintuitive in terms of when you might have some methods that can replace characters and so on. The key thing to understand is all of those methods actually return a new string instance. Okay? And so that's important to understand. Again, if you're doing this in a lot of looping and so on.
Not all developers understand this, that when they do anything to a string and change it in any way whatsoever, a new string is created. They have not manipulated an existing string. They've taken that existing string, redefined it, created a new string, and put that new value in it.
Exactly.
That's the immutable. What another? It's another one of those words.
Exactly.
You know what I mean?
Polymorphism, immutable.
It's incredible.
It's just lovely. So, what do you do if you know you're going to be doing a lot of manipulation when you're constructing a string? It seems silly to be using a string object knowing that you're creating objects, throwing them away, creating objects, throwing them away, and so on. Doing my little throwaway dance there. So, the framework gives you another capability to do that, and that's the string builder.
Yeah.
So the string builder effectively models a mutable implementation of a string.
The string builder is a class that tries to solve this problem.
Exactly.
Because strings are so common. You're going to be interacting with them constantly, building first name plus last name or whatever.
Yep.
And we need some kind of pattern for it. String builder is that pattern.
Okay. Do you want to open up the string builder demo, or?
Yeah, let's...
Number 12.
All right, thank you. Number 12, got it. All right.
So what we've got going on here is we created a new instance of our string builder class, and that exposes a number of methods. We've got one that appends a line. And so what that does is it takes the string, passed as a parameter, and appends it to any existing string content within the string builder. Because it's append line, it also adds the environment new line character to it. So if we were to squirt this out onto the console, then, to use the technical term.
You're just contrasting append versus append line.
Correct.
Append line includes the new line character.
Indeed.
Got it.
Absolutely. We also have the ability to use formatting. So we have a loop here that's going to append a bunch of strings into the string builder. And why don't you put a breakpoint and run that through to that point so we can actually look at the content of string builder.
You got it. All right, so here we are, we're running. This is live.
This is live.
Go ahead.
So basically what we've got, if we actually look at the contents of string builder right now, down in the locals section, we actually see that there is that's the view into the buffer that the string builder is building of all the characters. And so we can actually see that there are new line and carriage return embedded between those lines of the first two lines.
That's right.
As we move through this loop, we can see that we'll be adding in additional strings.
And this is append format, not append line format.
Exactly. And so we will have to add our own line breaks if we want to actually make sure that these appear on different lines.
Okay.
What we can also see is we have a syntax in here that allows us to specify a format for injecting values external to the string into the string itself.
And this is something common even with just the string object itself.
Exactly.
Format is very powerful for constructing a string.
So we can see a couple of placeholders. We have 0, which indicates the first item that follows the string will be injected at this point.
So this is the 0 is the zero-based ordinal position, meaning this.
Exactly. And we've got a little comma there followed by a value, and what that does is it modifies the format of the value being output. And what this is actually going to do is increase the size of the number that's being output in that location to 5 characters in total, and it's going to space pad it.
It's nice.
It's kind of nice.
Yeah, it's nice. There's a lot you can do with formatting. Now I want to look at some of the other pieces we're doing. This is just candy that the string builder gives you, the ability to replace throughout the entire string, or you can treat them as individual lines, and then toString. toString is an impressive piece where you've been building up this string and you need to generate the final result. That's where you do it. Now,
exactly.
Let's talk about ways of manipulating a string. So that's great with the string builder. Let's look at string manipulation, generally speaking. So this happens a lot. Right? We get data back. We get data input from a user. We need to do something with it, and so. The first one we can do is probably the easiest, and that's substring.
Yep.
And very common. Substring allows me to reach into a string and take any number of characters out.
And so, bearing in mind what we talked about before, is substring just returning back the characters that are in there, or is it doing something else?
Well, if we were right, and we always are,
indeed,
then whenever we do anything that makes a change to a string, it creates a new string object.
Okay.
And so we say substring, it brings back only, in this case, the quick brown fox, only brings back quick. That is a new object that has quick in it.
Okay, that's interesting.
Yeah, isn't it though? Yeah, thanks. So also the string object itself has a static method of concat. This is a great way to bring two together without having to worry about how you're doing it. If you're doing it right, you can let the framework do it for you inside this method. Concat puts together the two values or series of values that you may have, concatenates those together and returns the object, the new object, with all of the items concatenated together.
And that's a good point, because when you were reading this, you would kind of think that you were concatenating Fox onto the end of the value.
Yeah.
But it's actually the result of that is a new string. You're not changing value.
You could almost rename this to say string dot, create a new string object with these two values put together.
But that wouldn't be very succinct, would it?
No, it wouldn't. I'll talk about, you'd need IntelliSense for that.
Exactly.
All right, so we also have replace. This is a great one. You know, somebody puts in an invalid character, you need to remove it. Somebody puts in, a space and you need to remove it. You're good to go. Replace is a handy way to do it. Same as before, new object.
Yeah. I think everybody can probably work out what two upper does.
Two upper and two lower, changing the case. Yeah, it's really great. And what's nice is it reads the regional settings of Windows, and it does it properly. Right? It might actually be different depending on the language that you're actually changing.
Exactly. We have other convenience methods such as toArray. It's quite common to want to be able to iterate through a string character by character, and so this allows us to take the dog string and project it into a character array.
So these are kind of simple manual ways to do it. The high-end way, and with tons of capability, is certainly regular expressions. Regular expressions is in the text namespace. It allows you as a developer to be able to take a string and really interrogate it, to create patterns, and this is probably the neatest part. I'm not saying I want to go into this index and take this many characters. I want to find a pattern, things that look like HTML tags, things that look like people's names, things that look like addresses, and I can make very simple patterns that find a letter, or very complex patterns that find things that are only my invoice numbers that are in an email. Right? It's very difficult to find, but easy with regular expression patterns.
Or to match email addresses, so you could create expressions that map out what will be a valid email syntax.
Yeah.
And if you can find that match, then you know you've got something that matches that rule.
You can do that, and you could do that to validate data input as it comes in to make sure it does match. There are no matches, so they didn't type an email. You could also use it for nefarious reasons of like scraping the internet and finding all the email addresses out there. I've never done that, and I don't recommend you doing it, but I know some people do, and I hate them all.
Okay, sounds good.
Anyway, I will say one extra thing about regular expressions is not only are they give you all this power, they are insanely fast. The performance of regular expressions is almost unexplainable, practically instantaneous. It feels like so fast, and so you would think all these new patterns and all that. It's a language of its own.
It is.
Those syntaxes.
Yeah, there's a lot of resources out on the internet that you can use to go and learn these things. Obviously we're not going to touch and talk about how you create regular expressions and all the rules around it. But just understand that they are a very powerful tool, and the capabilities are exposed for you to use.
We could have a course on just regular expressions, and at the end of that course, you would still need the documentation at your hands, because the syntax is rich, and you got to keep a clear mind.
Absolutely.
Yeah. All right, so let's look back. We've done a lot in this module. We've done a lot. What have we done?
So we looked at controlling programmatic flow. So we looked at the different types of statements that can control where you go, what blocks of code are evaluated.
If statements, while statements, then breaking out with break and continue, return.
Exactly.
Sure.
So we showed that, those are how you can really control your program logic and determine exactly what your application behavior is going to be.
We also, remember, we also did a switch to do that, but then we kind of moved into what if it was an animal, and what if it was a dog? Where can we cast to? How can we safely cast?
So how can we really manipulate types and create those more common functions that operate at the base level, and then how can we specialize the types that have been passed in using is and as? Yeah, exactly.
And then some of those common behaviors or features or functions that developers put together to be able to go in, interrogate strings, manipulate strings, find patterns in strings. Very powerful.
Absolutely.
Covered a lot this time.
Well, indeed we did.
But now we're going to cover 10 minutes of nothing. And so we'll see you in 10 minutes. It'll be Module 4. Is that right?
Module 4.
Module 4 in 10 minutes, and we will see you then. Welcome back. This is Microsoft Virtual Academy. We're here for the jump start for C#. This is Module 4. My name is Jerry Nixon. I'm here with Darren. Welcome back, Darren.
Glad to be here.
What will we be talking about now?
We have the incredibly illuminating title of Features of C# Part 3.
Great.
But the overview is we're going to be looking at code reflection and obtaining type information from that process, and also working with garbage collection, which sounds incredibly interesting.
This is all very disgusting. All right, so first is code reflection, which is very powerful. We already talked about types and its metadata. We'll be getting into that. Beautiful. All right, let's jump into it and go to town here.
So, what is reflection, Jerry?
Reflection is reflection is a great name, actually. Reflection really does mean to look back. And then so reflection allows me to look back at my code or back at an object and interrogate it for whatever it has defined in its metadata. So I can say, for example, I'm looking at an object. I would ask, what methods does it have? I can use reflection to literally answer that question, to reflect into an object and bring it back to me. Over answered?
No, that's perfectly fine. So you talk about metadata, and so we've mentioned before when we're talking about types and how a type stores that metadata. So reflection is that kind of window into that metadata and allows us to use it programmatically, as well as allowing the compiler to interact and understand what capabilities are on a type.
And I can find out all kinds of things from an object, including just its simple name, but also its family. So where it comes from, what it inherits, what namespace it's in, what assembly it's in. A lot of information.
Yeah. And so, why would that be useful?
Well, it's useful for a couple ways. Wow, my goodness, there's so many
Exactly.
implications.
The mind boggles.
Oh, man. Well, for one, it could just be interesting, right? You receive an assembly from somebody else. It's poorly documented, and now you need to be able to understand it. You could use reflection for that.
Okay.
There are tools that already do that for you and bring it to you in a graphical way. But in a programmatic sense, it might be because you want to reach into an object, and you want to be able to get information that may or may not make sense. You give me a whole series of objects. I want to get the name, but first I'll check to make sure they even have a property of name, and I go through that because I don't have an interface to help me with that. So instead I can use reflection to verify a structure. That's one option.
Okay. So you might be interacting with something in a more dynamic way. You wouldn't choose to do this over and above the way that we've been interacting with them thus far, by creating an instance of the type and interacting with them in a strongly typed way by invoking their methods.
And I think the reason is, and this is worth remembering, is reflection isn't free.
Yes.
It can be very costly to do reflection. That doesn't mean you shouldn't do it. It just means you should do it with care.
Yeah, so basically the compiler, when we're interacting with the objects in the more traditional sense, knows exactly where the method is and doesn't have to worry about going and finding it and so on, and produces very efficient and optimized code. Whereas if we're using reflection, we have to interrogate the metadata of a type and then interact with that in a different way.
Consider is that we showed earlier. If you were going to see if an object is a dog, in order to use reflection for that, you would have to check all of its properties are present, right type, whether or not they're available, its methods, and all this other
And
business.
as you mentioned, we'd have to walk up that tree because we would need to find, okay, what does this type inherit from another type other than object? Yes, okay, go and get that type. Is that on there? No, okay. Does this inherit? And so on and so forth. So we would have to walk the tree.
Reflection itself is expensive, but this constant iteration is expensive as well. That's the reason we have these other ways. However, reflection is great, and there are right times to use it.
Exactly. Some typical scenarios when you would use it are dynamic extensions of your application. If you want to load a module at runtime that may be dropped into a directory, you could dynamically load in that assembly, and then you could use reflection to go and find, okay, are there any implementations of a specific interface in this assembly, and so on. It's very, very powerful, but let's kind of get to the nuts and bolts.
Including if it has a constructor and all these other pieces, so you can interact with it properly. That is an interesting dynamic way to do it. Speaking of dynamic, it might be, you could flag your code so you could inject things into it. And that flag is, you could reflect to find all the flags.
Okay, yeah. That's harking back to the attributes.
That's right.
Attributes, I guess you have.
That's right.
Okay.
Attributes.
Indeed.
Yes.
So how do we get this type data using reflection? I mean, there's actually two ways. We can do it at compile time, should we so wish. If, for example, we know that we're going to be interacting with a type of dog, we can use the keyword type of and mention the class that we wish to get the metadata for, and then we've got that type information available. You might argue, if we already have the dog type and we already know about it, why would we do it? It's a good question, well asked. The framework supports that anyway, should you need to. The other way we can do it is at runtime. We can...
one of the reasons you might is because of methods on the type that
Absolutely.
you might need to interact with it.
Exactly. Another way you can do it is at runtime, you can interrogate an existing instance of a type and ask and call its getType method. So that is evaluated type. Runtime will return back an instance of type.
Both techniques return a type. One is on the definition itself, one is on an instance.
Yeah. So the type class represents the metadata that any type in the managed environment returns.
Makes sense to me.
Okay.
Makes sense to me. It is nice. I mean, if you're interacting with a list of something, you can interrogate what type it is and change your logic based on it. And it's also, you could use it for security as well, to make sure the types that people are passing you are not invalid, not from a type safe sense, but from you shouldn't be using this type of user in this operation.
Yep. Okay. So typically, once you've got a type, if you actually want to start interacting with it at runtime, you want to call its methods and so on and so forth, you need to get a hold of an instance of that type. So there's a couple of different ways that you can actually do that. There's a nice utility class called Activator that's in the system.reflection namespace that has a create instance method with a number of overloads of that method. The first one that was around since CSharp 1.0 just returns back a object, which you would need to cast into the type that you're looking for. So this, on the right-hand side here, you see var new dog is equal to a dog instance. We're casting the result of the create instance method, and we're passing in the type of dog so that the create instance knows how to go and create an instance of this. That is basically calling a default constructor on dog to return back that instance.
Now, there is, of course, a way to call more than a default constructor if
Absolutely,
you want to.
and
of
we'll
course,
touch that
and we
later.
have generic dog, which is using a much nicer implementation, right?
Yes.
We're using generics, saying the type that will be returned. We don't have to do a bunch of casting. This is our way of communicating directly to it. Look how readable that is in the second line compared to the first.
I know there's been a couple of questions about, what is really the value of generics and so on. I hope this really gives you a good example because you know exactly what type the create instance is returning. And inside that create instance implementation, it's optimized to be able to deal with these types.
Yeah, that's right. It's very powerful. Now, being able to reflect and create an object just knowing its type, that's really neat. I mean, I can really start to use it without having to say equals new dog because I may not know new dog, right? We say dog, but it might be T.
Yep.
Yeah.
Absolutely. And so what we actually have here is showing how you can move through the constructors of a given type and actually bring those up. And actually, I noticed a typo on this one. That shouldn't be null at the bottom there, that final parameter. That should actually be passing in an empty array of objects, which should be the parameters passed. So that's a mistake on here.
Oh, that's in case the constructor takes 2, 3, 4 different parameters, arguments, different things to come into it.
Exactly.
Oh my goodness. Then there I can put them in an array, pass them into it.
Exactly.
I can't do it explicitly because it doesn't know. You're invoking an unknown method, so it allows you to do that with an array.
Correct.
Yeah, that's nice. So probably that's handy. I've done that a dozen times in my career. What I've done hundreds of times is reflect into a property. That's
exactly. You've already been passed a constructed instance,
yeah.
And so then you want to interact with that. And so there's a number of nice utility functions that are exposed out that allow us to interact with those. What we're showing right now is a slide that shows how you could interact with properties.
Yeah, that's right. And so, first of all, you get the type. You just can't forget that step, right? You get the type, and the type itself will give you its property. And once you get the property from a type, it's not enough. You have to go back then to the instance if you want to get its value. So here we are, we have a horse and it's an animal, its name is Ed. And so I get the type, and that's just animal. It's not the instance of what I have, I'm just pulling back animal again. And I can see there's a property called name. And of course I can see that I've interacted with it already. And now that I have a reference to that property called property, it's not a reference to the instance of that property. So when I want to get its value, I have to pass in that reference of horse.
So basically get property pulls in the metadata that defines a property at the class level, but now we need to turn around and say, and now we mean this property name
that's
on
right.
an instance.
So when we see that line that says var property, the value of that is actually property info. It's just the metadata that's exposed for that property from its type. It has nothing to do with the property itself.
Interesting.
Yeah, it's really neat. It really is neat. And so anyway, that's a great way to get it. Of course, there's a corollary to set value as well, so you can interact with properties without having to know the type directly or whether or not it has a property. Of course, I can say if property is null, and then from there I can say if property is null, don't do it, right?
Yep.
And so I can do a test as well, not interact with an object that may not have that property.
That's awesome. So how about methods? Can we do something similar with methods?
No, we can't.
No, that's a shame.
Yeah, let's go to the next slide.
That's disappointing.
Yeah, of course you can, right? Reflection is how it all works under the scenes. And this is a namespace that exposes it to the developer so they can do it too. And so method, of course, is a natural one. It works, honestly, very similar to invoking a class and calling its constructor. And so just like before, we have our horse. And in this type, so we get the type, and method now is not the method. Just like before when it was only property info, now we have only method info. And it's all of the metadata exposed by the type about that property. It's specifically its signature, return types, whether or not it's public to be able to call in the first place. Just like before, there's a method that allows us to call it. We're not getting the value of a method, we're invoking it. So you can say .invoke. Then we pass in the instance we want to invoke that on. In this case, horse. And so it runs it.
Great. So the demo project is 004, if you want to explore that.
I do indeed. Let me pull that up.
Here's one we prepared earlier.
Yeah, it's nice. All right, so here we are. Good. Dogs. All right. So this is very similar to the same process we were just demonstrating. So let me go down to the actual definition first, so we can see that we have a class. It's a dog with a property of number of legs. And so in its constructor, we set the number of legs to 4. Right? So this is the default constructor. This is the one that's called automatically if you don't specify anything. And so by default, it has 4. Or you can manually call a different constructor. This is an overload of its constructor to set whatever legs you want. Of course, you could set it in the property as well, but this is just to make the point. All right. So here we are. I'll go ahead and create dog. And what's interesting about it, I could use var like before. And var is a reminder. Var is just a shortcut, so I don't have to say this is a dog, right? But object is fun because I can bring it all the way down to the base of every type of class. So I can say object dog. Now dog really is a dog, but I set it as an object. Mm-hmm. It's nice, right? So now I can do anything to it. And I don't have to, though. I could do reflection against a strong type.
What methods are exposed on dog at that point?
So now dog dot. Nothing at all. These 4 methods that are in the ultimate base of object, and really nothing else. We know that dog has a number of legs, and so we can't get to it. If I were to switch this to dog, right, then it would be strongly typed to dog, and it would know I can interact with it like that. Or I could use var, and var will cast it back to an object. That's exactly right. That's because create instance doesn't know what it's returning. It just returns back an object. I need to cast it yet again. And so I could do that here as dog. And now because I've done that, of course the compiler is very smart and knows the var says, and var simply says, whatever's after the equals is what this is. There it is. All right, so now we've got dog dot number of legs is right there. Okay, so here we are. The first thing I want to do is find all of the properties inside dog. So the first thing I'll do is get its type. And I can say type of dog. Another thing I could say is dog.getType. The difference is whether or not you're interacting with the instance of the object or just the reference to its type. All right, so here we are. I have its type, and type has this property, get properties, returns an array of all of the properties. We only have 1 property, so it's going to be an array with a member of 1. And then I can get the property info. Remember, that's what we actually get from reflection. To get its property, and here I know that there's only 1, so I can go to its ordinal position. So many ways I could get it, right?
Exactly.
I don't have to say get properties. I could also say get property, and it just gets a single one, and I can specify its individual name of legs or whatever it is.
Yeah. So basically what we're showing here is just how rich the reflection API is. And, some of the challenges sometimes when you're working with these very rich frameworks is there are so many different ways to solve a problem that often it's challenging to know exactly which path to take.
Yeah, that's right. Yeah, that's right. I would recommend our path.
But that's just us.
Yeah, no doubt. I mean, this is where we're about now to we could get its value, but rather than get its value, so many other things you can do with it. It's checking it, and making sure it's there, so you don't continue with an operation if something is missing. It's really nice. All right, so what are we looking at here?
That's just basically allowing us to iterate through. So instead of saying get property name, we could turn around and say we might be looking for a property that's deals with the specific type. So if we were, say, assigning a handler, and we had a property that said what the handler was, we could iterate through the properties and look what the value is, and then we don't even need to worry about, do we know the name of the property? Because in many of these cases, if we were reflecting over something, we probably don't know what the property names are ahead of time.
Yeah.
Yeah, we're interacting with it.
This is cool because we're really introducing some interesting things here. So so we're looping through. Of course, we talked about for each in the last module. We're looping through all the properties, which are just property infos, not properties. And so we'll loop through each one, and then we do a quick interrogation. And it's interesting because property info will tell us the name, right? Because that doesn't have anything to do with the instance.
Yep.
And then we call equals. Isn't that an interesting method on a string? Of course, we know name is a string. Equals is it's fun. I mean, we're going to talk a little bit more about handling equality, but equals is looking for the value, not its actual.
Yes, because one of the key things when you're comparing reference types is it's checking to see, is the reference the same by default? And so if you mean something different, you have to be very explicit that you mean something different. And in the .NET framework, you have the ability to specify comparators and inject comparators into an equality statement. You can also turn around and say, okay, how should this comparison be done? So in here, for example, we've specified that the comparison should be invariant, i.e. not specific to a particular culture. You can specify to use the current culture. You can also specify things like don't look at case, don't worry about case.
That's exactly right. But that's important too, because often if you don't do that, you're going to have to call to lower, all these things you have to do, and you don't have to if you use everything properly.
Indeed.
This isn't even necessary. I mean, you could take it away and it'll default for you, but it gives you all this other power if you do include it. Yeah, no doubt about it. This is great, and so this is just, now I'm looking to see if number of legs is there, and if so, interact with it. Okay, and so here we are, setting.
So here's your setting value.
Excuse me.
Bless you.
Thank you. Yeah, so here I set the value. It's dog is the instance. Of course, remember right at the top, we created it with reflection just to be fancy. And so now we're setting dog to a value of 3. And there we are. That's tricky. And the third, and it's almost always null because it's a very special case when you want it, is whether or not there's any,
Indexes.
Yeah, and there rarely are. All right. So it depends on the type. It only depends on the type.
Yeah.
And then we write it out just so we can prove that we got it.
Here's this poor dog only has 3 legs.
Yeah, it's that dog. That's Lassie with 1 S.
Oh.
Good. And now we start interrogating the type itself. So now we have our dog, and we want to get the constructor on the dog. This is because we're going to call it, and we need to understand it. Like, what do we need to pass to it?
And so basically what we're going through here is illustrating how we can iterate through and find different types of constructor. So the first one gets the constructor that takes no parameters. And if we look down here, we have that constructor. Then we have a second constructor that actually takes an integer value. And so this is how we pass in an array that contains the int type. And what getConstructor does here is looks for a constructor that matches that pattern.
Right. What we're not asking for is all the constructors you have. We're asking for a specific constructor, and to be specific, we say what the signature is.
Now you might say, okay, well, how can we always guarantee that we're only going to get back 1? Well, when we created the type, the compiler will have enforced the fact that we can only have 1 constructor for any given signature.
Goes back to method signatures. Signatures are unique.
Strong typing.
Right, so we know we won't kill that. All right, so here we are again. Now we're calling for, we're invoking the constructor, which will return a type.
Yep, and it's going to invoke the default constructor. So if we look at dog, we'll see the default definition of dog will set its number of legs equal to 4. So on that console write line, we'd have output 4.
It's sure better.
It certainly better had.
Yeah.
On the second one, we've actually got a very strange dog. It actually has 5 legs, and so we're invoking the constructor with 5, and that will be the output there.
In fact, let me run this, and let me step into it right here. I may not have set this. Let me go ahead and set it as the startup project, and we'll take a look. Okay, so we've already gotten it, and so if you look at the output here, we have 3, which is because it's reading from what we set, right? This is the line that reads the number of legs that we set because we are doing it through reflection. And then here comes the default constructor, and oops, F5 over here. And we create the first one, which the default constructor sets it automatically to 4. Then we use the custom constructor, which sets it to 5. Powerful.
Wonderful stuff.
Yeah. Interact with the methods, interact with properties, create the objects if we want to. A lot of power.
Now, we've really just touched the surface of what you can do with the reflection in terms of interacting with assemblies, loading them in, moving through those assemblies, and so on. You also can interact with generics using the reflection. And that starts to get to a little bit more complex syntax and so on. But if you find that you need to do that, there's a lot of good documentation on MSDN and elsewhere in terms of how to actually interact with those.
It's worth knowing you can. Sometimes that's the most important part, is just to know you can so you don't chase a rabbit.
To a certain extent, that's really what we're trying to achieve with this particular course, is really to open everybody's eyes to some of the richness around there, to give you those elements that you can focus on for passing the certification and so on. We're condensing those 5 days into 1 day, so necessarily we can't dwell on all of these subjects to the depth that perhaps they deserve.
Darren, do you remember a few modules ago we were talking about handling an event? And when you handle an event, it was like a string between that event and your listener and your handler. And so then there was this issue of you have this string, and then here we are in reflection, we're creating objects. Now there are a lot of consequences to memory. And we know, of course, that in a managed environment, that's handled with garbage collection. So let's transition over to garbage collection. Very fun to talk about garbage collection. It's not as gross as it sounds.
Indeed not, because you don't have to get your hands dirty on it.
Not at all. That's right. There's a garbage man.
Exactly, and that is the runtime for you.
Yes.
It's a garbage thing.
The runtime doesn't have a gender.
Indeed.
Yeah.
It is a thing. Let's call it a thing.
It's a garbage.
So what is garbage collection? Well, as Jerry just alluded to, it's the implementation of automatic memory management within the .NET framework and the CLR. And what it does for us is it worries about objects we're no longer using and cleans them up for us. The key thing to understand, though, is that it doesn't necessarily do it straight away. So, and there are many good reasons for that. One of them is performance, that it can be computationally expensive for the garbage collector to iterate through all its object store and to follow any reference chains to ensure that the object is no longer referenced. In order to do that in an efficient way, it breaks things up into a number of different generations. So those short-lived objects get reclaimed first. Those that have been around for a long time tend to be held onto for a little bit longer before they get disposed.
A garbage generation is complicated. Let me try with an analogy.
Go for it.
So imagine the Serengeti, right? We've got wildebeest running around. And it's the natural course of nature for families of wildebeest to run around the Serengeti. But we also have lions, and the lions are prowling around, looking for the baby wildebeest that strays away from its family, and it's out there by itself just causing trouble, and the lion eats the wildebeest. That's garbage. The lion is garbage collection.
I see.
Because what you have is you have your code, and everything's in the family. Everything's referenced. Everything is working the way it's supposed to. And every once in a while, you have these orphan events that go off by themselves, right? Or I'm sorry, orphan objects, right? They no longer have any reference. You're never going to use them again. They're off, and really all they're doing is taking up space and eating from the Serengeti when you don't need to.
So basically, it's harvesting the easy ones first before it starts looking at the harder targets.
That's the truth, actually. That is the way. I mean, there is a heuristic around garbage collection, and the lion really is the example of it's cleaning up all around, but it's leaving the herd, right? It's leaving your application so that everything is referenced and done properly, just moves on. But if you have to spend time now chasing out all of these things that you don't reference anymore so that you don't take up all the memory space with them, that's a mess for you. It's a pain. C++ developers do it today. .NET developers don't, because they have garbage collection that takes care of the whole thing.
So a good example of an easy victim for garbage collection would be a local variable that's defined within the scope of a method. When the method closes,
that's right.
There's your baby antelope.
It's over. Yeah. Now it's antelopes. Yeah. Exactly. Sounds delicious.
Indeed. Yum.
Now, it is important to say that for the sake of the computer that's running, garbage collection isn't free.
It's
right.
Not
it's
free.
Doing work for you, and it is real work.
The line gets tired when it runs.
It does indeed. Yes, sometimes those orphans are fast. Now we're eating puppies for breakfast.
Now we're stretching the
killing
analogy.
Orphans. Yeah. Right, okay.
Okay, let's move on.
It's terrible.
Okay. So So, as you say, it's expensive. The system has an algorithm which determines when to run, and it normally does so when it detects pressure.
And it's not us that's doing it.
Exactly.
Right? Yeah, we don't influence it, but we can. No, we don't control it, but we do influence it.
But there are scenarios where we can.
Yeah.
And when we can turn around and say, I want garbage collection to run. And so if we look at this particular slide, you see on the right-hand side, we've got GC collect. GC represents the global garbage collector. We have wait for pending finalizers, which will come to what they are in a moment, and then collect again. When this is executing, everything stops. Your application waits until the collect completes, then waits for any pending finalizers. So these are processes that may be running on objects that are currently prepping for being collected, and then it collects again to clean up those ones that are just finished their finalizers. That's expensive, and you'll only want to do that in specific scenarios. Typically, when you detect that you have a situation where you have reserved a large amount of system resources and you wish to clear them up before you get out. So a particular scenario that makes sense is a Windows service. So those of you who may not be familiar with Windows services, they are pieces of code that you can register with the system that get run on a periodic basis. It may run once every 24 hours, once a week, or whatever. If you imagine one of these services that is responsible for, say, running through every file and working out whether it's open, it could, in theory, have a lot of resources. If, say, it's creating a list of all the file names, that takes up a lot of footprint in memory. Once it's finished with that list, it wants to get rid of it. It doesn't want to leave them sitting out there impacting other applications' performance. And so you could turn around and say, I want my Windows service to release all of those file names, all of the resources related to those, and to do it now. Then once I've finished this, I go to sleep for 24 hours before I run again. And so it's a very good way of being a nice citizen.
It's back to the analogy for a second. You're about to create an orphan, and you know that it's an expensive, a hungry orphan, right?
Yeah.
That goes out and is eating everything. You call in the lion.
Exactly.
Like, there it is. And so imagine a loop where I'm going through, and every iteration of that loop, I'm doing something very, very expensive, and at the end of it is something, I do release it, but I know that it's still referenced in memory, and here I go, that loop's going to start again. I could call GC collect and say, now it's time to clean house, and I'm going to have to do that in every loop, but I have to be careful all of a sudden. A loop that calls GC collect.
That's a bad thing.
Yeah.
But I think your intent is great. You know you've got resources that you want to let go of. How do you do it? If GC collect is bad, what's a better way to do it? And fortunately, it just so happens that we have a capability to do that. It's implementing an interface called iDisposable that effectively marks up an object as complying with what's called the dispose pattern that allows us to preemptively release resources prior to any garbage collection. And so that allows us to be a good citizen, give things back, and then let garbage collector do its own thing in its own time.
Yeah. So iDispose, that's common. We see iDisposable all the time. I'll throw a caveat. iDisposable is not in Windows 8 app development, right? It's a different mindset. But in all of other development, we get to see iDisposable because of the way it communicates to garbage collectors. So it's an interface, which means I have to do it.
There's actually an interesting snippet around, you mentioned Windows App Store development. One of the things that has been done is the close statement has actually been coerced into a dispose to allow you to use using for closing, which is actually pretty interesting, and we'll get to that shortly.
Yeah.
So this is a definition. This particular slide shows disposable objects, and for sort of ease of reading, I've added in a definition of iDisposable, just so we can see that all it does is state that anything so marked has to have an implementation of the dispose method.
And that's it.
And that's it.
It doesn't say what it does in the dispose method. It doesn't say how big the object is, small nothing else. And from that point forward, all we have is .dispose.
Yeah. And so we have a demo class here that implements iDisposable. You can see the syntax there. And it's got an implementation of dispose. And so if for example, we imagine that demo had a member variable of an array, and we instantiated the array with 10 million integers.
Yeah, so now it's getting full.
That space is reserved. That space is allocated to this demo object. In the dispose method, we could deallocate that by setting the array to 0. set it to null, get rid of it, release up all those memory. So that places that memory available for reuse again, even though the demo object itself hasn't been reclaimed yet by the garbage collector.
So this is our implementation of doing some mild garbage collection almost.
I like to call it housekeeping.
Doing some housekeeping.
Exactly.
iDisposable is not appropriate for every class.
No, sometimes it doesn't make sense. If you're not actually hanging on to a significant amount of resources, then don't worry about it. If all your variables are in fact defined on a local scope, again, don't worry about it. If those things that you're exposing out should last the entire lifetime of that object, again, don't worry about it.
If your class represents a stream, if your class represents outside resource, something that's very expensive, even mildly expensive, now iDisposable works.
Exactly.
But if all you have is an animal class that has name and number of legs, iDisposable is not appropriate. You could do it still, but what are you going to do? Very little.
Yeah, you go through and set all your properties to null.
Yeah.
Not that useful.
There was a time in Visual Basic when that was a big deal.
Exactly. And that's, again, it's because you're generally interacting with external elements.
Yeah, that's right. Okay, so there's a simple disposal pattern. We know there's an advanced disposal pattern.
Yeah.
Now, give me the shorthand of that one.
Yes.
Okay. So we know there's an advanced, but we also have using.
Exactly. So the advanced version, just briefly, what this allows us to do is to deal with a couple of different scenarios where we're not only dealing with managed resources, i.e. those types that are defined within the managed runtime, but also with external resources such as COM and whatever. That this allows us to expressly go out and release those external types as part of our dispose cycle. We also introduce in here, if you look down the bottom, we have this little wiggly, then advanced demo. So that's the tilde symbol. That is what's called a finalizer. So that is the inverse of a constructor. And it allows us to perform operations at the end of the life cycle of a managed type. It's not very common that we actually need to do this. Typically, the only scenario in which you would do so is releasing resources. And this implements the advanced pattern. Now, what we have is, you can see we implement iDisposable. So we have a method that returns void, and it's called dispose. And inside that, we call another implementation of dispose with a true parameter, which maps to a disposing parameter. In here, if we're disposing, we can then release managed resources. So what you would have inside there is other managed types that implement the dispose pattern. And we would call dispose on those. So it would cascade dispose down what's called our object graph, our related objects. Outside of that, we would also then set to null any references to external, say, COM objects or whatever. So we release our reference on those as well. Once we do that, we're then remove the need to run the finalizer, which is going to call dispose. And so what we have then is, after the dispose method, we actually turn around and say GC, garbage collector, suppress the execution of finalize, suppress finalize, and we pass in this object instance which says don't run it. And effectively that stops us having to worry about the finalizer trying to rerun and redo dispose. If we haven't called dispose, when garbage collection actually runs, it will call our finalizer, advanced demo, which will then call dispose false. The interesting thing about this scenario is garbage collection will only run if we don't hold references out to other objects that are alive, so we don't need to dispose our managed resources in this scenario, hence we pass in false.
Yeah.
But we still let go of the managed objects. That's about as quick as I could go through that one.
It's tricky business.
It is.
It is. This is actually, if you are going to implement iDisposable, odds are this is
the way you're going to have to
do it. Yeah.
Yeah.
It's just it's also a friendly way so that you can call dispose without relying on garbage disposal to do it, or garbage collection to do it. All right. So if let me show you a fun demo here.
Yep. Go for it.
So let's pretend I'm gonna read a file real quickly, and what's nice about it is when I read a file, it comes back as a stream, and we'll talk about streams.
So we want to see your desktop, yeah?
Yeah, let's do that. So let me set a fake path here, something like test.txt. This is how I would set up whatever the path is. Let's say it's a real file. This one isn't one. And I want to say, var file equals file.open, and then I'll pass in whatever its path is, and then a quick little note that I want to open it. Now, file, let me show you the type of file. File returns a stream. And so stream is actually it's a great example of something that is a resource that you want to release. And so now that I have it, this is actually locking the file.
Oh, that's painful.
Well, it's okay for me because I'm writing to it, but everybody else, you might want to use it.
Yeah, so you don't like to share?
Yeah, I don't like to share.
Yeah, that's me.
Yeah. So the reality is, while that's open, it's important that it be locked because I'm interacting with it and I can't have it be indeterminate, right? I have to know what's going on. And so it
That's
locks
a good
on
word
purpose.
too. It's like polymorphism.
Yeah, I know. It never stops, man.
Indeed.
All right, now, in to-do here, I have some sort of interaction with the file.
Okay.
And let's say I'm writing, reading, parsing, whatever it is I do to it, and then I'm done.
Okay.
And that's the end. And so I can't forget to release the stream, right? I can't forget to dispose of it.
I actually think you can forget.
Oh, yeah. Oh, yeah, you can. I shouldn't, I guess is what I meant to say. And so to do that, I'll say file.close.
Oh, what if you leave it open and trying to open
Well, let's say you do forget, which is what I really actually do a lot. If you do that, the file remains locked.
Okay.
And there are processes that will eventually unlock that, but there's a long period that suddenly this file is no longer accessible.
So if you try to open it again, you get an exception?
Yeah. So we're going to be doubling what we're going to do in a minute. But yeah, so if I were to run this again, access the exact same one into a different variable, like file2, that would fail because it's already locked and I can't access it the way I want to. However, if I call close, I could do it again here, and life would be happy. Because now it's unlocked because I've closed it. Now, because it is easy to forget, there is a nice keyword that we have. And that's the using keyword. It allows us to create a block. Of course, a block is just
Hang on a second, though. Don't we have using at the top of the
Yes,
program as
we
well?
do. Yes, kind of like type. So using at the top, just to be clear, which brings in namespaces so that we don't have to reference them completely, is really a different word altogether. And you can know the difference only because they're in different contexts.
Okay.
You certainly can't you can't do using namespace inside a method. You can inside a namespace, interestingly enough.
Yep.
But the using that I'm talking about is the one that defines the beginning and end of a block, and it looks like this.
Okay. So that's a key one. A lot of people get confused sometimes when they see that in here, and they think it's making some sort of reference out to something, and can't quite work out what's going on.
No, you're right. It's especially when you're just talking it, when you're just speaking it.
Exactly.
You know, you don't have the opportunity to see the context.
Yeah.
And so it's the same. Everything else is the same except for we're wrapping everything in a using. And so if I were to I would take the same line that would reopen the file so I could read or manipulate it, and I would just jam it into the using description or the using definition, and then in its implementation, I could still have to do that would interact with file exactly like I had before. No change in the code. The one good thing you don't have to do is file.close, because as soon as it runs out of scope, which means it just exits that block, then it will automatically dispose of the object for you. It's very, very nice, especially with streams. It's not unheard of, but it's almost unheard of to see people interact with streams without using a using, partly because it ensures it's always called correctly.
So using calls dispose?
Using will call dispose for you. Yes, that's exactly right.
So that's interesting, but you had file.close.
Oh boy, here we go. Well, we'll talk about the difference between close and dispose in just a second. But before we do, I mean, so that we can make sure we cover it generally. It is almost uncommon. It is almost unheard of to see the interaction with a stream, not only because it makes sure that it's disposed of properly whenever it falls out of scope, but also because it allows you to visually see that you're using a type that it is a resource or does have a cost and does need to be disposed without you having to interrogate it to the next developer. I always think about that. You know, the next developer is going to have to figure this out. This is a good way to communicate to them, not only to be safe, but also what you're working with and why.
Yeah, it's very expressive.
It's very expressive. I will say there are times when you don't want to use using. There are times when you need to keep that resource open, and you need even from one method to a method, even when you're changing scope.
Exactly, and sometimes you can fall into a trap there if you just get into the habit of doing using and then you try and return these things.
Yeah.
You know, the framework is actually very clever around how it manages those things if you actually try and return a value from inside there. But bear in mind, you can get some gotchas there.
It does. So let's go back to dispose and close, what we were talking about. So if I dispose of an object, I really am destroying it, right? This is a trash can operation.
Exactly.
I dispose of it, I throw it away.
If an object is disposed, it is effectively unusable.
Right.
Even though you may still have an instance of it available.
By contrast, let's say a file, which is a good example, a file that I close, I'm not destroying anything.
One hopes not.
I am closing that lock. And I could, right after close, I could say open again. And that allows me to have kind of this toggle on and off depending on cases. And so one big difference between dispose and close, well, probably the big difference, is that dispose isn't reopened, right? It's communicating to the developer this is the end. A close communicates that there is an opposing open, and you can call that open again if you want to, right? But there is also another case, right? We could dispose, we could close, or we could stop. And stop is different. You don't see it quite as much. You made the point earlier that close is can also use a using, especially in Windows 8 development. But stop is different. How is stop different?
Well, stop again it's contextual, I think. You have close, which you tend to talk about things that you've opened. Stop tends to be associated with things that you start. So you might have a timer as an example. You start a timer and you stop a timer. You might restart that timer. So again, these are almost verb actions that you're placing against these methods or these objects to interact with them. One of the key things is, by convention, if you have something that you stop or you close and you're implementing a dispose, you want to ensure during that dispose implementation that you close or stop what you're calling. And so that's why what Jerry was doing before worked, in that he could dispose the interaction with the file stream, and the file stream went, oh, I'm being disposed, therefore it would make sense if I close any streams that I have open.
Right.
Which is pretty slick.
Yeah, and so if I dispose, it's destroyed. If I close, then I could reopen, and it maintains at least a pointer sort of reference to it. But if I stop, it maintains its state, so that I could start and it comes back to where it was actually stopped.
Exactly.
Yeah, it's really nice.
Sounds good.
Okay. A lot of things here in garbage collection and working with streams. There are a couple penalties to not handling things like this correctly. One of them, of course, we talked about locking the file. Another one is it sort of locks the memory. Sort of makes it so that we have what we would call a memory leak, and so we maintain all of these resources when we don't need to, and our application suddenly has a nice footprint, and it's getting bigger and it's getting bigger.
So you mentioned memory leaks, and we've just been talking about how great garbage collection is in the managed environment. You know, it manages all the memory for us.
Why doesn't it solve this problem?
Why?
Yeah.
You know, that seems crazy. And so there are a couple of little gotchas that you can fall into when you're building these things. What you have to understand is that garbage collection looks at an object and sees, is this object referred to by any other object? And if it is referred, then it will not collect it. And so there are ways that you can actually create relationships between objects whereby you've created that reference and you haven't explicitly released it, but then you've removed your ability to interact with that object, so you can't ever get back to it. And so it kind of sits there out there as it should be orphaned, but you're hanging on to a reference to it, and so it never gets garbage collected. And if you're doing that in an area of the application that gets called repeatedly, then you keep allocating memory without releasing it until you close down the application. That's really the definition of a memory leak.
Now let's go back to the event, because this is the one that I think really gets people as well. When I listen for an event, I am making a reference now to that object, and the one that's raising the event. And so
it's actually strongly coupled rather than loosely coupled.
That's right. There is that string between them is tight, and it doesn't break. And even though it falls out of scope inside your application, you know, what might happen is I'm interacting with that dog that's going to bark, has spoken, is being listened to by a trainer, and that dog is now gone out of scope. I feel as if I've deallocated it. But the reality is, as long as there's a trainer listening, it's always there. And even though I can no longer interact with it, garbage collection will not collect it. And so if that dog happens to be an expensive resource taking up a lot of memory, and I create dogs over and over that we listen to, and I'm always having that event handler being listened to by a trainer, all those dogs really are still taking up all this memory in my app domains, but I am not able to collect it until I break that reference. But I'm not breaking the reference because all I am is trying to deallocate it from the dog's perspective. How do I break that string? That's the thing, and I think this happens a lot, even in Windows development and standard development, where I'm listening for, let's say, a window that's open in WinForms or WPF development to have some event that fires, and then they close that event, but then they may open up or close that window, and then they may open up another one, and I listen for that one, and they close it. And little do I know that all those windows are still there, even though I can't interact with them anymore.
That's crazy.
It's brutal. It's very dangerous because it turns out that's a bad case of memory leakage.
Yeah.
Yeah.
Okay, awesome. So that sounds scary. It sounds like you're alluding to a couple of coding practices that can be used to offset that. And so one of those is, typically if you're binding to events during a loading activity, you may want to release that subscription to the event during an unload activity.
Yeah. Earlier we were talking that you can handle an event with that plus equals.
Yep.
You can unhandle it then with the minus equals, and it removes that delegate from the delegate list of the event.
Awesome.
Yeah.
Sounds like a good practice. But it sounds like there's probably some other scenarios that we can do around those references. That maybe we've got something that is listening, but we really don't care to keep it around if it should be disposed of.
And back to this interesting analogy of a string it's a much thinner string, right? There still is this connection between these objects. We call these weak references. So we have a standard reference or a strong reference that really does keep the reference from being collected. But we can also establish a weak reference to another object. And then garbage collection will see that and say, those don't matter, right? Only strong references matter.
So if there are only weak references on an object, the garbage collector will dispose of it.
That's exactly right.
That's perfect.
That's exactly right. So back to our wildebeest. If the wildebeest runs away and the herd is watching it, that might be a strong reference. Everybody forgets it. That's the weak reference.
Okay.
Along comes the line.
So if I have a weak reference to something, I can just check its value to see if it's null. If it's null, then the reference has been deleted basically because the garbage has been collected.
No.
Oh, because garbage has been collected.
Exactly.
Yes.
Yes.
Exactly right.
Well, I'm glad we agree.
Yes, now we're back on board.
No problem. But there may be a situation where we're doing an atomic operation where we've checked, do we have a value in this weak reference? Yes, we do. Okay, then I'm going to do this, this, and this on that object.
So I've implemented the pattern where it's a weak reference, but for this moment, make it a strong reference.
Yeah.
Yeah.
I mean, how do we stop it from being collected partway through?
Well, the quick way is to create another reference.
Okay, so we create a local variable that then points to the value of that weak reference.
Right.
Okay.
And then that reference is the one that keeps it alive. Yeah. So we haven't really changed the weak reference to be strong. We've added another reference that holds it alive and keeps garbage collection away.
Perfect.
Nice. Okay. All about it.
Absolutely.
Should we should take advantage of the time.
We should.
No doubt about it. All right, let's look back. All right, so we had a big topic at the beginning, talking about reflection, the ability to take advantage of the metadata that is exposed from types so that we can look into objects that are handed to us to understand what they're like, what properties they may have, the ability to set and be able to read those values. That's really nice, as well as execute methods or invoke methods, and to instantiate an object by only knowing its type and interrogating to see what the constructor is and whether or not it has a specific signature and obeying that signature. Very powerful.
Very powerful.
Reflection is there. I think we talked about that reflection is both powerful and dangerous, right? Because there is a cost to it, and there are many, many other pieces to the framework that allow you to do most of what you're wanting to do. But there are times when reflection is the right solution, the best solution, all the way around, and you just absorb that cost.
And often the only way.
Often it's the only way. That's right.
Awesome.
And then we talked about garbage collection, and this is really more about memory management and the way that the framework will look at what isn't referenced, what's been deallocated, and it will suck that right out of memory. And then the mistakes that we can make by accidentally keeping things in memory even though we want them to be out, by creating strong references to those and the option to create weak references so that those can be removed.
Perfect.
Yeah, it was a good session, I think.
It was a good session. Covered a lot of ground.
Okay. Now it's lunchtime. This is the end of Module 4. Now we're going to take a...
Starting at 1. Starting at the top of the hour.
We are going to take a break until the top of the hour, so I will see you all in 50 minutes. Bon appetit.
And then you're off looking into space.
It's not on yet. It's not on.
You're on!
Cameras aren't even running. Hi and welcome back. This is Microsoft Virtual Academy Jumpstart for C#. We are going into Module 5. You have just eaten lunch. You're feeling good. You're ready to learn. We're ready to teach.
Let's hit it.
Let's hit it.
So what we're going to cover today, or in this module I should say. So we're going to look at type and value validation.
Ah yes, validation.
Validation is a key problem that we have to solve. It's unfortunate we can't trust our users to put in the correct stuff, but it's one of sad life.
We cannot even trust other developers to give us good value.
And I don't trust you.
I'm not sure who I trust.
Indeed.
Ah.
That's it. Good job the compiler's there.
The only person I really trust is the compiler.
Exactly. So let's type and value validation. Clearly we had too much sugar at lunch. And then we're going to move on to encryption techniques, which is obviously a bit of a deeper topic.
But awesome.
But very awesome.
Yes.
Okay, without further ado.
Let's begin validation.
Let's do it. Type and value validation.
Validation is really a mindset, Darren. It's, you really do. We were joking earlier about who do you trust. But as a developer, you have to not trust anything that's coming into your system. So how do you get data into your system? Well, there's a lot of ways. A service can give you data. You can read from a file that you're going to be parsing. You could be exposing an API that somebody is passing values into. Like you alluded to, a user can be typing information in data entry forms.
You can put your whiskey down there.
Yeah. There's no camera. There's no camera. Nobody knows what you're talking about. There's a camera right now.
There is a human being on the end of this camera. And
I'd like to do a quick
humor.
call out to Barry, our camera switcher. That's the way he says hi.
Exactly.
Where were we going? Where were we?
We were talking about validation and the fact that there are many sources of data.
There really are a lot of ways for you to get data, and the moment you trust any of them is the moment you introduce instability into your application.
Yeah.
You want to be good-natured, you want to be trusting, but you can't write an app that way. Like we talked about it earlier in the morning, you want to be defensive. You want to write assuming that your application could really suffer from bad data, suffer from what the user passes in, you want to be able to write your application so it's robust, so that it handles those and doesn't get broken because of something that's broken outside of it. So that's where data validation comes in.
Exactly. It's only paranoia if the users aren't out to get you.
Right. I always say users are the worst part of software development.
Exactly. Software is perfect until it gets used.
Or tested. Testers are just as bad.
We actually love them all.
Mm-hmm. Yeah. Well, you do.
Exactly.
Yeah.
Okay, so that is fundamentally what data validation is.
Well, let me back up again and keep going, because I think the problem with it is it's not just that the data's bad, it's that it could be okay, but it's out of range, right? You expect the number to be between something and something, and they've given you one too many, or they are typing in like we talk about with regular expressions, an email address. They give you a valid string, but not a valid email address.
Exactly. You know, it's more about we place constraints on our expectations. You know, in order to develop an application, we're building a finite state machine. It's not an infinite state machine. So we have to constrain the scenarios that we're dealing with. Otherwise, we would never complete the activity that we're trying to code.
Yeah.
And so in order to allow our system to operate down those constrained guidelines, we need to put limits, as you say, range checks and those kind of things. So that's a lot of what we're talking about right now.
And sometimes it's more than just stability we're trying to protect. Sometimes it's security. And the reality is there are ways to overflow an application and take advantage of it, to do SQL injection and things like this that can really be detrimental. So this pays off not only in stability or maybe performance, but also in security as well.
Yeah, I mean, we throw in that term SQL injection. And so basically, to those people who aren't familiar with what SQL injection is, there was a class of sort of naive applications that allowed you to type into a text box, say in a web application, and submit that, and that information was sent directly to a SQL database, and the SQL database executed that as if it was a command, and so you could do malicious activities such as deleting tables, deleting records, and so on and so forth. And so a whole class.
This sounds like an edge case, but it was common for a long time.
It was very common. It was a common attack vector, and so. You have to program defensively. We talked about this a little bit beforehand.
Yeah. Validation's the way to do it too.
Exactly.
All right, so let's talk about some of the techniques for validation. I love this. I love talking about this. I believe there are true best practices that we can give to developers that they can use. So the first one would be to trust the compiler. So the compiler does a lot of work for you. They make sure that we talked about type safety, make sure the type is right. The compiler cannot do the value validation. That's really going to be up to you. And so we have a couple nice ways to kind of work through validation. One of them is debugging just the application itself and tracing. And what we can do, a lot like unit tests, where you can have asserts inside a unit test. You can do debug and trace asserts that evaluate to a Boolean condition like an if statement would. And that assertion can be something like number not less than 3. That would be a type of assertion that would return true or false. We can put that inside a debug, or we can put that inside a trace assert, and if it fails, it will literally stop at that point and notify the user. There's a difference between debug and trace, Darren. Debug happens during a debug session while I happen to be attached to a debugger, so I can step through it.
Yep.
Very big deal is trace. Trace, of course, happens all the time.
So we can trace in a release build as well as a debug build.
Common mistake, a big problem when your application is showing debug information in release.
Yes.
I would say that is a non-optimal behavior.
Suboptimal for sure.
Somehow, yeah, I don't want to say non-optimal.
Well, that would be dumb, yeah.
Thank you. Thank you.
You're welcome.
Gosh, I was right about you. So, another thing you could do, this is a way of not just validating, but reacting to an invalid state would be through raising an exception, especially when we're talking about things passed to an application. So the arguments that are being passed to a method, arguments could be null, so you could raise an argument null exception. It could be out of range, you could pass an argument out of range exception. You could also just pass a general argument exception. This is a good way, a typed exception like this is a good way to say this isn't just an error, this is a type of error, and that type of error is whatever that type is. So here an argument exception speaks directly to say what is going wrong, and then you can add to that exception to say more detail, add a message to it, and things like that as well. So it points to a specific one. If we were to look at this, so we have a sample on a method for set name. And so set name is easy enough, a small little method that all it does is set the value. And if you really look at it, all it is the very last line, this.name equals value. And all this other is just extra. It's almost like commenting. It just feels like stuff you don't need, but it's stuff you absolutely must need.
I mean, a point I'd like to make here is that often when people are looking at sort of sample code and they may be out at MSDN and so on and so forth, people often comment, well, it's not real code in that I don't have to, there isn't all of this defensive programming in there to ensure that these things are safe. What people have to understand is that those examples are out there to demonstrate how to use a particular feature, not to repeatedly show you how to do defensive coding. In this demonstration, we're really focusing on showing you some of those concepts that you need to leverage whenever you're actually building true production applications.
Yeah, that's right. I mean, it's funny how it goes both ways too, right? You make a simple demo too simple, and it's not real world. You make it too complicated, and it's not simple enough. It was hard to win, but the reality is demos are demos, and they're really meant to demonstrate something. This is a beautiful demo that represents the full scaffolding around protecting your data. Now, it may even do more than what we really want, but let's take a look. So the first action that it does is it looks to validate whether or not it's empty. And empty is great because string has a method that gives us a way to check it. This would be the same thing as saying that it's not null and it doesn't equal empty string. but wraps it all into a nice little helper function for us. And then so naturally I would raise an argument null exception, right? There's really nothing else you could raise. There's no argument empty exception. And then it's nice because we're able then to pass value to indicate the exact argument that had a problem. If I had multiple arguments in this method, I could indicate them all, and I would have some sort of test for all of them. All right, so the second one is validating a conflict. So in this case, if let's say that the value they're passing in for name is already name, and so I'm going to raise an argument, or I'm going to raise an exception because they can't be the same. You can't set it to itself. Now, what's important is if you're going to create a scenario where an exception is going to be raised, it is imperative that you also create a scenario where the developer can avoid that exception. So if you're going to raise an exception that says, value equals name, and you can't set it to itself, you should only raise that exception if the developer outside of your API is able to check that first, right? You don't want to let exceptions be the way that you message between applications.
Yeah. We've mentioned exceptions a lot, but we really haven't gone into much detail around them. But the name actually is the clue. To raise an exception should be the exception, not the norm. Something exceptional has occurred that hasn't really been planned for, can't really be dealt with within the context of the set name environment. It needs to be dealt with external to that. Therefore, we're raising this as an error condition. If it's something that could be anticipated, if, say, for example, we could deal with a duplicate name just by not setting the value and just returning back as if it was successful, then we should do that. We should only raise exceptions in the scenario where we cannot cater for the scenario that we've encountered.
Yeah, so we were talking about earlier using is, and is a neat way to check to make sure the value is right, or the type is right. That's going to be an important check as well, especially if you have some sort of derivable type that you don't know for sure what's going to be passed in. So look at this slide. So this slide gives us three more options. So let's go to, I'll just let you handle it for now on. Go back one.
Well, thanks very much for that.
All right, so check it out. So the first one is if the cat is a dog, right, which we know isn't true, so we say it's a not supported exception. By the way, choosing the exception type is going to kind of be up to the developer. You could create custom exceptions that are way more explicit. You could say cat is not dog exception if you really wanted to. That's because there is a base exception, and really the only caveat around that is to make sure you make it serializable so that it doesn't ruin any of the services you might use it in. If cat is dog, that allows me to see if it's the type, but it's neat because we also see in the second one, if cat double equals dog. And so not equals to dog doesn't mean that they're not the same type, doesn't mean it's not a specific type. It means it's not the exact same object in memory. And so this is important because what it's saying is, because it could potentially be true. Cat could equal dog if we had two variables and they equaled each other, right? So that it doesn't imply necessarily that it couldn't be true. And the last one is using the dot equals, and we talked about this just slightly, kind of leading into it in the morning. And equals is different because equals. It can be implemented different ways, and you can do a custom implementation of equals so that it goes in and checks specific properties, but doesn't check, say, like a key or something like that. Either way around it, it's not looking to see if they're the same object. It's looking to see if they have the same values. On a simple value, like integer, it just checks number to number. But on a complex object that you might create, you might override equals so that it checks exactly what it needs to make sure they're equal.
For example, you could use name. If the name is the same, then these are equal.
It could be that simple of logic. Yeah. That's really right. Okay, perfect. The data validation process is imperative. It's very important that we do it. It's imperative that we do it. But there are other ways to do it as well. And data contract, I absolutely, positively love data contracts. And so data contracts, they have been around for quite some time in the .NET framework, implemented sometimes in a CTP, implemented sometimes in a also with an add-on to Visual Studio. And here's the way it works. Design by contract is the concept that's basically saying I can predefine how you interact with methods. I can predefine how you interact with properties based on just the same way that an interface is a contract for a class. I can create a contract for all of these other mechanisms that also become a way of data validation. And so data contracts are powerful for two reasons. One, it is a a consistent way of doing it. If you're checking for this and raising whatever exception, I don't know what's going to happen. If you, that's typical validation, and it doesn't go away. You can't get away from that in a lot of situations. Contracts are different because it's a uniform way of approaching it, but it's also cool because I get to check what's coming in, just like you would expect to be able to check the arguments of a method or the argument of a setter for a property, but I also get to do the output as well and validate the operation of the method is what I would expect it to be. That's a big difference. Contracts enable this, where I can have preconditions, whatever's coming in, and I can have postconditions of whatever's going out, and making sure I'm really defining my class and my methods that much more. And
so how does that work or help us in comparison to, say, using exceptions and your debug traces? What's different about using contracts?
Well, there's a lot of similarity. So one of them is, well, first of all, being able to check for the output is very difficult, right? So that second part would be a huge amount of scaffolding for you to put together anyway. However, much like traces, I can create, so if I have a trace, I could create a trace listener. And so that allows me to receive the trace messages and put them somewhere in a file or wherever it is that I want them to be. I can create a type of trace listener, a listener for code contract violations as well, and put those somewhere as well. So in that sense, they're nearly the same, right? I still can get an exception raised, a contract exception whenever it's not valid. But what I can't do with regular validation is at code time, at compile time, in the static environment of development, I can't check to see whether or not they're being violated. Contracts are special. So contracts do run at runtime, like you would expect, but they also run at, I guess, design time. When I'm developing my application inside the static environment, behind the scenes, it's an add-on to Visual Studio that makes sure that whatever it is I'm passing in, whatever it is I'm using, whatever it is I've set up as a contract for this method or property is true even now. So I were inside inside some code, I set up a contract, cannot be null, I'm passing null to it, I would get an error right here in Visual Studio. It wouldn't even have to run the application.
So it's basically using the compiler's understanding of what you've written to explore your code and evaluate all the code paths to ensure that that contract will be satisfied.
That's right, and it's it's because they're discrete and defined predicates that define what an individual contract. So I can have many assertions in a contract.
What's a predicate?
So a predicate, well, that's an excellent point. So a predicate is what's the short word for a predicate? Predicate is pred. A predicate.
Well, a predicate is fundamentally something that evaluates to true. It indicates membership of a set of some form.
It
so
does.
You're supplying an expression that you're turning around and saying, for this contract to be honored, then this expression must be true.
Yeah. Usually when you write an evaluation statement of some kind, it really does boil up to be a predicate. It's like a where statement in a SQL clause almost.
Yeah.
Right? I mean, really, that is.
By returning true, you indicate membership of the where set. Otherwise, it's false and it's excluded.
Yeah, that's right. So each contract uses a predicate as its definition. That can be executed by the compiler inside Visual Studio. Very powerful. Very powerful.
Awesome.
In fact, I'm gonna pull up a project and we're gonna take a look at it.
So it's number 23.
All right. Let's see. Perfect. So let's take a look at the kind of setup. So we have a class of animal and a cat that inherits animal. So we really like animals in our demos, no doubt about it. Yeah. So we have a single property, its name, and a single method of set name, very similar to what we had done before. And so there's a lot of power here, right? So this is the demo we saw. In fact, wait a minute, let me make sure they all make sense together. Yeah, this is the demo we saw before. If we actually, I don't know if it's 23. It does say 23 though, doesn't it?
It does say 23.
That's all right. I'll put it together. And so these do the simple non-static validations, but I want to take all of these out, and I want to add instead data contracts to it as well, which beautifully are in dog. If I had only scrolled down a little bit more.
Indeed.
Dog
it's almost
and
like
cat.
we prepared this.
Dog and cat, yes. Golly, I'm so not disappointed in myself now. All right, so dog does the same thing, by the way, right? See, you can see that simple set name, and I set it with the validation, and now I have set name as well. But look at the power of it. It's really neat. Set name creates a contract that says dot requires. And dot requires are those preconditions that talk about the values being passed in. And so dot requires says that not the predicate is not string is null or white space. That's me saying that the value being passed in can't be null, can't be white space. And if it is, there's a little message that I can pass to the user. Just to say, this is like a message being passed to the user.
Exactly.
Yeah, something really great. And all right, so that's the first one. This is great because it truly does replace all of the pieces in that we did above, right? It can do, all of these predicates can be replaced with a contract. Now what's nice is contracts also enable me to write in this longer syntax if I want to. I don't have to use contracts. I can do this and I can define a contract block and still use the same code, and it could still execute at static time, which is really nice. Now,
Frank,
this is what I've accomplished in set. So I do all of the preconditions using requires, and I could add again and again all the ones that I need, like so. Right? And I could change those predicates to check whatever it is that I want. Now here's where it's cool. Here is getName. getName is a method that returns something. I can use contracts here just like I did before, but I'll use them in post conditions. Here I'll use ensures to make sure that I can do it. And contracts have a neat method in their namespace here that says contract.result, which is a reference to what will eventually be returned by this method, and it allows me to set up the contract here even if it's going to execute at runtime later. And so I can say, so here's the predicate, same exact thing. I cannot return an empty string, right? So I can't set name to empty string, neither can I return it to empty string. And just like before, I could create several different post conditions, all depending on whatever. And what's special about it is not just that it works, which is cool, but also that it works while I'm interacting with it as a developer at like this is static time. Now, just a reminder, two quick caveats that developers need to know is that contracts only run statically if I am in, this is what we need to install.
Yeah.
If I have the add-on installed, and so the extension installed, and so if I do have that installed, then it changes what Visual Studio does so that it'll work statically at design time.
Adds a UI as well to enable you to interact with it.
It adds a UI to the project, into the project properties that allows me to configure it and also to kind of turn them up and down as far as volume, depending on how I want them to respond. They could cause build errors if I want to. And probably the most important thing to take away from contracts is, as much as these really do replace most approaches so that they can be a single approach to data validation, they can be overridden. And so let's say one of the tests is going to be a security test. A security test will then result in a contract violation, and so it will be raised and you can handle it from there. However, I can actually handle that event so that the contract violation is ignored. And so you shouldn't, this is better of a best practice than anything, you shouldn't use contracts for security checking. Mm-hmm. But everything else, it just makes sense. It's a common language to use this way. It works at runtime and at compile time. It's very powerful, I love it. So back to this, it's not the wrong way to do it by using the standard approaches. At all is it the wrong way to do it. In fact, I can say right below it, contract in contract block, and from that point forward, everything above that statement actually rolls all that to be contracts and treats it like contracts, and so their failures become contract exceptions.
Awesome.
Yeah, it's very powerful, and it gives me the static capability as well at design time. So there's certainly nothing wrong with this. Why would you choose contracts? Is because this sort of use of predicates is a unified way of handling both input and output. A lot of power there.
A lot of power. It's awesome.
Yeah, thanks.
There's that word again.
Is it awesome?
I believe so.
Awesome.
Yeah.
Okay.
Seems to be my word of choice.
Seems very awesome.
It's better than bloviate, I guess.
Yeah. Better awesome than not.
Indeed.
All right, here we are.
Okay.
So that's data contracts.
That's data contracts, and that's a good form of validation. So if you flick to my slides.
Flick.
So we have spoken an awful lot about exceptions, so we should perhaps talk a little bit about how do we handle them elegantly within our code itself, rather than just throwing them out into the ether. Because fundamentally, the runtime will ultimately handle any exceptions that we don't handle ourselves, but they'll do so by terminating our process with extreme prejudice, basically.
Yeah, that's exactly right.
That's fine. You know, it's a strategy if that's how you wish to deal with exceptions, is just leave it for the runtime. But unfortunately, you get a big fat dialogue that pops up and scares the heck out of your users. So I really wouldn't recommend that.
And can result in your application no longer being stable. Even if your app can, they click continue and it still tries to run.
It's in an unknown state, effectively.
Yeah, I think you made a good point though, that the runtime will actually catch the exception. I mean, we say unhandled, but it's not endlessly unhandled. What we really mean is it bubbles all the way to the runtime and you expect it to do it, right? It will, but it's not happiness.
And in a lot of the development frameworks that you use, such as WPF, Silverlight, if you're using that, and so on and so forth, is at the main app layer, there is generally an event that gets raised which represents any unhandled exceptions that have occurred in your application. So you can actually trap them at that top level. And that is a strategy if you want to turn around and say, oops, something bad has happened, unfortunately we're going to have to shut down, and that's the strategy that you put in place.
Yeah, so let's talk about catching exceptions.
Yes.
Right? That's what we want to do. We want to catch them.
Exactly. And so imagine the scenario where we have this process, if you're looking at the code on the right-hand side. This process could throw exceptions. If we wish to
you mean the process?
You see? Yeah, it's English, American, bruised, not. There is this process method, and it could potentially throw exceptions which would disrupt the execution of our application and potentially leave it in an unknown state. So we wish to handle those. So the syntax in which we can say that we wish to handle this scenario is to leverage the try followed by a code block.
And try is nice, it's readable, and it really, what it means is try this out, and if it breaks, then, and there's stuff that comes later.
Now, if we follow this on, we can see that it's followed by a catch statement. Now, there are a number of different ways that we could actually use catch. We could use catch without any parentheses or anything that follows it, and that would just be a standard bucket that would catch any exception and then execute the block that followed.
Yeah.
Now
that, what you just said is, now it would catch any exception. That's very similar to the third block, where it's catching exception, which is the base of all exceptions.
Correct. Yeah. There is actually one type of exception that doesn't inherit from those, and that is a COM-based exception.
Oh, yeah.
And so catch would actually catch that. It's funny how we call these words things that are actually useful. Catch, catch, catch.
Yeah, it's nice.
Okay, but we can also chain together catches, and the advantage of chaining together catches is if we move from most specific to least specific, we can catch a number of different types of exceptions and deal with them in a different way. For example, here we have a divide by zero exception.
Yeah.
So if we want to be able to give a different action, or say, for example, whenever we get a divide by zero, we just want to return a value of 0, then we can intercept that exception and set the return value of this code block to return 0.
Divide by zero is a great example of raising an exception that really communicates what went wrong.
Exactly.
A generic one, it's still the same, but the only reason you would use a typed is because you want to really be able to communicate what went wrong.
And it gives you the flexibility to respond to them in a different way.
That's right, because now you can have a catch for each type, and you can respond to what exactly went wrong, maybe differently. So you could potentially get something like file is closed, or file is opened by another process. And so you could in your catch wait, or perhaps look to see what's using it and let it release it, something like that.
And so this really speaks to the design process, the technical design process of implementing a solution, that you want to consider some of these scenarios and think, okay, if I am the developer of the process method that we're invoking at this point, what support and infrastructure do I want to provide to somebody who consumes this method?
Yeah.
And then one of the good uses for XML comments is to list out all of the exceptions that this method could throw, thereby inviting a consumer of this method to actually catch any ones that are useful, and then to use a bucket to catch all the remaining. So that's actually pretty cool.
That's, by the way, I want to jump on that because it's actually important. If you have a method and you have done a good job of documenting all the possible exceptions that can be raised, then I can actually test for those conditions. I can create a unit test or some sort of test that says, I'm going to lock that file, and then I'm going to call your method, and I better get that file locked exception, right? And then I can test to make sure not only that it does what it's supposed to, but it does everything it's supposed to when the conditions are wrong. And so there's a lot of power there too.
Exactly. And for anybody who's involved in estimation for software development, these are the cases that you have to consider that normally screw up your estimates. That we typically estimate how long we think it's going to create to build the golden path. We don't necessarily consider all of the if scenarios that we need to deal with in that environment, and often that adds a significant amount of development time onto the process of actually solving the problem, is dealing with the real world data validation, exception handling, and so on and so forth.
It goes back to the reality that the worst part of software development is users.
Exactly.
Yeah.
You know, it works on my machine, TM.
TM. Yeah, too late for that one, man.
Shampoo. Okay, the other aspect of the try block is it can also optionally be followed by a finally statement.
Yeah, this is important.
Now, this is very important. We can actually use try and finally without having catch at all. What finally is finally is a promise. And that is, regardless of what occurs during the try block, the code that's contained in the finally block will always execute.
There is no exception to that.
There is no exception.
And I think that's important. Finally is reliable.
It is.
Because you may be doing something in that try, let's say process. You're doing something in that process that's very expensive. It opens up files, it opens up resources, it holds open streams, whatever it does, and there's going to be a failure. And you could handle it well enough in the catch, but then you need to do something in the finally to release all of that stuff.
Exactly. And now a trick to bear in mind whenever you're dealing with the finally is make sure you cater for scenarios where everything's worked correctly and it's also gone horribly wrong. So say, for example, you open multiple files. The first file may open successfully, however the second file may fail and throw an exception. If you assume in the finally block that you've got all your files open and you need to close all of those files, you could actually end up in an error state. So you need to perform checks in finally to make sure that you deal with any partially completed try activity.
Yeah.
Does that make sense?
It's funny, man. I mean, we do data validation to make sure that the user or whoever isn't giving us bad data. Then we use try catches to make sure all the stuff we're calling doesn't fail and do stuff we don't expect. We got some serious trust issues, only to move in now to encryption.
Yeah.
I mean, holy smokes, this module is all
how long
about.
have you been coding? We've all got scars from
all
poor assumptions.
Well, yeah, that's right.
Exactly.
You probably do. Okay, so let's talk about encryption. Oh, we already did data validation, Tim. I don't think I can do much more there.
I think we're good.
And definitely it's around, with the takeaway, it's around contracts, right? Doesn't matter what framework you're using, there is a version of contracts for you.
Exactly.
Yeah. And so let's look at encryption.
Encryption.
Yeah.
Okay, so what is encryption?
Encryption is. I wanted to get it started. So, but the reality is encryption is taking data and making it not readable.
Correct.
Yeah.
Don't confuse encryption with security, although there is an aspect of security in terms of security by obscurity. You know, if you can't read it, then the data contained therein could be considered to be secure, but encryption isn't fundamentally about security. It is about making data unreadable.
Right. It can certainly increase security, but does not establish it.
Exactly. And, you know, when we're contrasting security there, we're talking about the ability to access something, whether you're authorized to access something. Encryption just makes it difficult to read once you get access to it.
Now, once you make it, let's just say impossible to read for fun. Nothing is impossible. We know that. In fact, whatever it is we're going to talk about can be undone. Just like anything that all levels of security can be unwound with enough effort. But encryption makes something unreadable. But we can read it.
We can read it because obviously with encryption there is the ability to decrypt it.
Decryption. All right.
Okay. And so we've talked about how rich the platform is in terms of the capabilities it provides. There are 4 foundational types of encryption that we can support within the .NET framework. And the great advantage of these encryption capabilities is they are implemented at the operating system level. They're part of the core of the system, and we're leveraging those within the managed environment. Okay.
And these are natively part of the framework waiting for you to use.
Exactly. They're baked in there and so on. And so they're going to operate as fast as your system can operate in terms of implementing encryption. Now, as we look at these in terms of the order from file encryption down to symmetric and asymmetric encryption, there are increasing levels of processor capability needed to perform those operations, both encryption and unencryption.
So encryption is expensive from a processor point of view, and the more intense the encryption, the more expensive. Don't
Absolutely.
pretend like it's free and it's going to happen like that.
Exactly. It's, with everything comes a price.
Right.
So, as I say, we have file encryption, which is simplest and is really based around you, the user. We then move on to Windows data protection, which, as it kind of implies, is baked into the Windows operating system. We have hashing, which we'll touch on, is basically used for signing and validating data. And then symmetric and asymmetric encryption, which is really about sharing beyond your user space.
Yeah.
So, if we look at file encryption, as the name suggests, it encrypts and decrypts files
On a file level, and it doesn't mean a file that's inside your application. This is just a file that's on.
It's interacting with your Windows file system to actually encrypt them within a file system.
Yeah.
It's very fast because it's a native part of the system, and it's effectively going to encrypt it on the disk. You may have seen encrypted files. They're highlighted green by default in Windows Explorer, and it's basically setting a bit flag on there indicating that this is compiled.
Let me encrypt something, can I?
Sure, why not? Go ahead.
I'll show you something. I'll just encrypt it. So here's my. Here are all of our slides for today.
Go for it.
Now that here's
Let's do an earlier one, not a later one.
Module. Yeah, I don't want to blow it. Yeah, exactly. So I'll go to its properties, and this is neat because this is one of the reasons it's so fast. It really is built in. This is just you reaching out and switching this bit, and so I can look at the advanced properties of this class, and I can see from here I could compress it, which of course is not encryption at all, but I could just encrypt it right here. Now, when it does encrypt, it's encrypting for me, right? Is it making it unreadable for everybody, or is it anybody on my system?
You can choose. You can choose your scope. So basically, it's based on your user credentials, but you can really depend on where it's going to be.
Right. And so I'll go ahead and encrypt it. I'll say OK, or only this file. It goes. A couple seconds spin. Several seconds spin. It spins for a couple seconds. There's some spinning going on, and all of a sudden, like you said, the file is green, and that green is just a visual indicator for me to realize that this is an encrypted file. And so that's nice. Somebody else comes onto this machine, they navigate to my folders, they go in, they can look at all my slide decks until they get to Module 1, and Module 1 is encrypted for my user. Very powerful, and this is what we get to do inside .NET. All right, that's file encryption.
Okay.
Simple.
If you want to flick back to me and look at my desk. So this is how you would actually implement file-based encryption within the source. So what I have here, and this is a project I'll be reusing for each of the major encryption types. Here is the data that I wish to protect. So effectively I have a string, and as I can say, it's a bunch of super secret content that we wish to encrypt. Typically we're going to
Would you use encryption for just regular secret content? Does it? Super is important.
Super is definitely
level of encryption you need.
Exactly.
Yeah. All right, got it.
So we typically deal with arrays, byte arrays, when we're actually dealing with encryption. And so what we're doing here is this is a method within the encoding class that will take a string, and we're applying Unicode encoding, which converts each character into 16 bits that can be expressed in the Unicode character set. This gets those bytes and converts it into a byte array. And so we're going to use this throughout our our scenario.
And the reason we're using byte arrays is because ultimately we're bringing everything back to numerics that we can interact with, right?
Exactly. We're dealing with those. And so now I've got a region. So this is a little piece of syntax that allows us to create collapsible regions in our editor. And so I can use this to break up my demo. What we're now doing is I'm just creating a file name to access a particular...
Nothing to do with encryption here. Just where's the file go? You're going to put it in my documents folder.
And so we have the ability to turn around and say, get the folder, and we've got a special folder, document enumeration, and we create that together.
Nice.
Now I'm using a static method on the file class to write out to a file name the data to protect. So this is going to contain this on the file system.
One of those methods, again, nothing to do with encryption, just an easy way to write text to a file.
Exactly. Now we get to the one part that is for encryption.
Now this has something to do with encryption?
It does.
Okay.
Do you know how you can tell that? It says encrypt in it. It's awesome.
I was reading the comment, actually.
Oh, I see. So basically, this is all we need to do to encrypt this file and protect it on our disk. The advantage of this is that if you lose your system and somebody attacks your hard drive, takes your hard drive out and places it into another system, without your user credentials logged on, Windows will not be able to access the contents of this file, and so it is secure. So it's a great way for securing personal information on a system.
The best part is this is, without a doubt, the easiest implementation of encryption for .NET developers.
Absolutely. So now let's flip back. So the next level of encryption that is available to us is Windows data protection. Now again, as its name suggests, it's leveraging capabilities of the Windows operating system. So that kind of implies that there's going to be scope based around your environment and you. It's again very fast to encrypt and decrypt, and it's based upon your user credentials in the same way that file encryption is, i.e. it creates internally a key that can be used to encrypt and decrypt based upon who you are.
Yeah.
So if I flick back to the session, so if I open up the Windows data protection, should have done this yesterday.
Yeah. Yeah, you should have.
Indeed. So we're again still interacting with the data to protect that we created up here, data to protect as an array, and we're basically saying protected data dot protect.
And protected data is the namespace where we're finding it. Okay.
This is actually, yeah, the static class, and this is the static method on protected data that will take this, compile it, or encrypt it rather. What the heck?
I changed your keyboard over lunch.
Good job. Good job. So this is an optional byte array that we can use that will vary the level of encryption by putting in additional random sets of bytes here. You can offset how the encryption is placed, and it includes an extra level of protection should you so wish. It's quite common to just pass null in this scenario.
Yeah.
And we also have the ability to say scope. So if we say data protection scope, current user, then obviously what that's implying is you have to be logged on as my user account in anything that I encrypt in this method so that I can then decrypt it.
This is exciting because I'm passing in current user. I think I might be able to pass in other things.
And here we go. We can see that we can also pass in a scope of local machine.
Anybody who logs on to this machine can decrypt this data that way.
Yeah, so if you think about a family scenario, you could encrypt data that you wish perhaps it's financial data that you and your wife wish to share. We can encrypt that and store that on the local machine. We can both access it by logging onto our machine, but if we lose it, then we don't lose our social security numbers when somebody else steals the hard drive.
Yeah.
So that's pretty slick.
Brilliant. And so I'm looking at Windows data protection and I'm looking at file protection, and I'm seeing that they're sort of the same. One is encrypting something that's in memory, and one is encrypting a file on the system.
But you hit exactly the difference. So the file encryption uses Windows data protection services behind the scenes, but it gives you a shortcut mechanism to protecting files on your disk.
Brilliant.
This allows you to protect data in memory that you may then choose to write to a web service somewhere. You may choose to write it to a database directly, and so on and so forth. So the data could be stored off your machine, but it is protected and only able to be unprotected, using the vernacular of this particular code,
right,
within the scope of this machine. Anybody else downloads it from that database on another machine, it's just gobbledygook to them. They can't touch it.
So this is encryption, taking the data so I can't read it. I get that. That's really, I mean, it makes sense. We're going to interact with a lot of data throughout the applications that we're going to write. Sometimes you're going to hit data that you should, honestly, just to be a good citizen, it should be encrypted. Too many things are probably stored as plain text. Now there's another step. Sometimes, because encryption is expensive, what you don't want to do is encrypt the entire payload. Instead, you want to start giving assurances around it that people aren't going in and monkeying with it.
Sounds like you want to sign it.
What I would like to do is sign, almost like, yeah, exactly, like a wax seal on an envelope that proves it hasn't been opened since the last time that whoever signed it. That's a good point.
It just so happens that
is there some way to do that?
It's amazing.
Nice.
So, we have the ability to create hashes. And a hash effectively is a value that is derived from the contents of something. And that value is guaranteed to always be generated in an identical manner for the same content. And so we can use that to determine whether some data has been tampered with. It's a one-way encryption algorithm, which makes it really fast, because if you just code something together that loses a bunch of information but effectively is unique, you cannot recover the information from it if it's already lost a bunch of data. And so we can take for example, the MD5 hash creates a 16-character hash. Regardless of how big the data is, the hash that comes out is only 16 characters long. There is no way you can reconstruct the original data from that hash because there's just not enough information there.
I think there's two key things around hashes that developers should lock in their brain. The first one is a hash can't be reverse engineered to recreate the string. But using like brute force, I could figure out the algorithm back down. I could try to cause it, right? And I could finally get to it. So you can't go backwards, even though you might be able to do brute force against it. But I think the other one is it's also not unique. I could have the Gettysburg Address, get the hash of it, and let's say the resulting value is 123. I could also get the Declaration of Independence, and I could get the hash of that. It could be 123 again. They aren't guaranteed to be unique. They're guaranteed to be always the same based on the content that you pass into it.
You always arrive at the same value. Now, obviously, the larger the hash key that you use, the less likely there is to be collisions. If you've only got 16 characters, then the likelihood for collisions increases dramatically. The SHA algorithm allows you to have a number of different encryption types. The 256 seems to be the one that's used most commonly. That's a pretty long character string, and the likelihood of collisions there is pretty remote. One little aside is the SHA 512 and the SHA 384 take about the same amount of time to execute. So if you need greater strength than the 256 algorithm, you might as well just go straight to the SHA 512.
Yeah.
Which is interesting.
That is fascinating.
Yeah.
I can tell you 512 digits of pi.
Well, good. Come back when you've done it.
We'll do that later.
Yeah, sounds good. So, typical use case for hashing is when you're storing passwords or you're comparing files, and also, as Jerry alluded to before, tamper checking. That in effect, rather than storing a password unencrypted in a database, you would hash it. You could store the hash because there is this guarantee that the same information will generate the same hash. Instead, you compare the password hashes, and if they match, then you're logged on. Now, if you're going to do that, you don't want to use the MD5 16 character hash because of the likelihood of collisions of repetition. You could randomly get a different password generating the same hash, which would then be a false positive. I mean, obviously, we don't want to do that.
Right.
So you want to move to the more secure versions of the hash.
Yeah, I would. I mean, obviously, you're going to combine username, email, all these other pieces as well. But certainly, having the risk of having the same hash result is definitely a danger. I guess a danger is the right word to use for it. Yeah.
So let's have a quick look at.
But let me back up just one more time. Another reason you might store a hash is because it's small. Even while we're talking about a long string, a hash for an entire book can be 512 characters, and I can still be checking against the entire book. There's another value of not storing the data and storing it only as a hash, I think.
Okay. So the code that I've got up on the screen right now illustrates how we would use a hash. So what I have here is a pre-generated hash that has been created based on this string. So I put that in already. I ran the code earlier.
That's what happens when you run it, huh? It looks
exactly.
like that.
That's
cool.
the output. That's the byte array. What we're doing a scenario here is we're turning around and saying, assume that this is a password hash that's stored out already. What we're then going to do is we're going to take a password.
You'd store it in Access, Microsoft Access.
Yeah, whichever database. Actually, I hashed this. I didn't hash the one above. So this is my password that I hashed that generated this byte array.
Yeah.
Then what I did is I used the SHA 256 algorithm to create. So this creates an instance of this algorithm.
Yeah.
And then I called the compute hash method on this algorithm instance, and I passed it in the password. which generates this byte array for the hash.
Yeah.
What I am now doing is comparing this array to this array. If they are identical, then because we're using the SHA-256 algorithm, we can be almost absolutely certain that this is the same password that's been entered in.
Very cool use of sequence equal.
Yeah.
Very cool.
This is a extension method that we've been able to pull in because this implements, because it's a password hash, it implements enumerable, and therefore sequence equal applies to that.
If I did use hash on a document, not a password, and somebody were to change a comma to a period, the hash would be different, and I'd be able to detect it. Also, I could compare hashes to see if passwords. It's brilliant.
It's incredibly powerful
and appealing because it's not as processor intensive as full encryption.
It's full encryption, yeah. It really is very useful when perhaps the body itself is not secret, but you wish to ensure consistency.
Yeah.
That you wish to be able to verify. This is what was originally sent to me.
Yeah, and it is, you said earlier signing. This is what it is. When you sign a document digitally, what happens is it creates a hash, and from that point forward, what you sign is associated to a hash that's combined with your identity.
Perfect. But now we're starting to get into the real meat and potatoes of encryption.
Good, just in time.
Just in time. We're starting to get to symmetric encryption. So you've got two main types of encryption that we really talk about once we get beyond hashing: symmetric and asymmetric. And the foundational difference between them is, with symmetric encryption, you use one key to both encrypt and decrypt content.
Yeah.
With asymmetric, there are two keys that are involved, and we'll get to that in a little bit more.
So the classic World War II scenario where you know the secret password,
Yes.
that's symmetric. They couldn't have
could be.
There is no asymmetric. Well, I mean, there is. It's elaborate. Never mind.
Exactly. Thanks very much for playing. Goodbye. The key thing, why would you use symmetric over asymmetric? Fundamentally, it's a lot faster. That you're not having to do a whole bunch of complex algorithmic work to ensure that the product of the public key encryption can only be decrypted by the private key that you use in asymmetric.
Yeah.
So this same key works in both ways. There are 5 algorithms baked into the .NET framework, and really this talks about how algorithms come in and out of fashion over time. Many of the others are included in the namespace for backward compatibility for programs that were written previous generations of the .NET framework. Right now, the AES implementation is the recommended implementation to use. Both AES and Rheindal, which is the funny spelling of second from bottom, is actually the same algorithm. AES has had some constraints placed upon it to enforce that you cannot use an insecure size of key.
Nice.
And so that's basically the fundamental difference between those. I'll flick onto asymmetric, and we'll cover both of those in a quick code view in a moment. So on the asymmetric side of the house, if we look at this slide,
Yep.
another name for it is public key encryption. And the key here is, overloading the term key, goodness, is you have one key that's used for encryption and another key that's used for decryption. So you can share the public key for encryption, so that things can be passed around, but the key for decryption should be kept private and guarded as one of your most secret of secrets.
So I'm going to send you a message. I'm going to take that payload. I have your public key. I can encrypt it. As soon as I've encrypted, even though I have your public key, I could never see it again. It is encrypted, and only your private key could ever decrypt it again. So it's a safe way for me to send you a message and to know that it doesn't matter if Frank gets it or anybody else, they're never going to open it because only you have your private key.
Exactly, and it's used for digital signatures to enforce that what I'm passing across has only come from you. It's a guaranteed source, and a common way of doing it is using certificates. You can purchase these public signing certificates where you purchase a private public key pair.
And they're responsible for ensuring that identity it really is you.
Exactly.
That's what that's about.
And so that's where your trust is established, that you have this external agency that calls you up and says, okay, what's your social security number? Who are you? Where are you?
Right.
Prove whom you are. And then they can issue you a personal one, or the same for corporate, that Microsoft has a public key cert that it leverages for its SSL. And you'll see on browsers, you get the padlock that indicates this is a secure certificate, it hasn't been
Works the
violated.
same way.
It's exactly the same concept.
Same thing with application certificates, to make sure the application that you're installing really was published or built by the trusted brand, trusted name.
Exactly. And so if we look at the cryptography namespace for the asymmetric algorithms, there are 4. All 4 of these are safe. They produce sufficiently encrypted information that you can trust them. However, the RSA algorithm seems to be the most popular, and that's the one we'll look at in a moment.
Great. Let's take a look at the code. I love to see how it's all implemented. I'm sure it's a million lines.
The nice thing is, it isn't.
Oh, good. 500,000.
So, this is the symmetric algorithm. As I mentioned, it uses Rheindahl. Rheindahl.
Of course it is.
Heck of a word. Just rolls off the tongue, huh?
It's Rheindahl. That's my 3rd child.
Oh, good. How unfortunate. Next to reindeer. Reindeer and Tinkerbell. Okay.
They're all sons, just so you know.
Exactly.
Kind of blew it for them.
Okay. So this is the key. And we can actually use different sizes of key, but I've chosen to use 16 bytes at this point.
Size definitely implies processor intensivity, how much work it works.
Yeah, it makes it damn hard work.
Requires. But certainly it also implies security.
Exactly. So the bigger the key, then the more heavily encrypted your code will be.
Yeah.
And the less likely brute force attacks will ever be able to decrypt it. But 16 bits, or 16 bytes rather, of key, I forget the exact figure of how much effort it is to actually crack into it, but this is secure.
Yeah.
It's considered to be secure.
If you were doing it with an abacus, it would take all day.
All day.
Yeah.
That's awesome. There is another part of the key, or part of an encryption vector that we can supply, which is an initialization vector. And what this is kind of, it's similar to seed within random. So if you've used the random class at all, you can use random, and it will kind of leverage your current time as a base seed to generate random numbers. You can inject in a new seed that will change the offset from where it starts to generating random numbers. That's the same kind of principle with the initialization vector. And one of the nice things about the initialization vector is you can use a common key that you've shared, but you can also embed an initialization vector into each message that you send backwards and forwards to add another degree of randomness to the encryption, as long as you're sharing it backwards and forwards. Just don't duplicate that initialization vector across messages. Just keep changing that initialization vector, and it makes it even harder to break.
And an init vector really is more like an additional password.
Exactly.
Yeah.
It's pretty cool. So anyway, in terms of using this is a pretty common pattern. So we create an instance of our algorithm. And I'm not using at this point because I want to save this for reuse for my decryption down below. Here we have 3 usings back to back, and this is actually a handy syntax for nesting using statements. We're not using a block inside each one of these, so it stops it indenting it all the way across the page, which makes it harder to read.
Yeah, I like that.
So this is a nice shorthand for that. But basically what we've got is, we've got 3 levels of disposable object that we're actually using here. And we're actually implying a life cycle that this is dependent upon this, or sorry, the cryptography is dependent upon memory, which is dependent upon encryption.
Yeah.
So as we roll out of this, those things will be disposed out in that order as well, which is kind of
cool.
Yeah,
it's really neat. Yeah. It's really, really neat.
So we've got an algorithm, and effectively we call a method on this create an encryptor.
Got it.
And we pass in our key and our initialization vector. Often you will see people use the same key for both the key and the initialization vector. That's perfectly valid. It just defeats the purpose of the initialization vector.
Yeah.
What we're going to do is we're actually going to encrypt things in memory. And so I'm creating a memory stream, which is going to be where the encrypted data gets written to.
Very similar to Windows data protection that changed or was encrypting data that was in memory. This is the same thing.
Exactly. Now the difference between creating a byte array and using a memory stream is a memory stream will size itself based upon the content that's being written to it, whereas a byte array has finite bounds.
Yeah, you define it up front.
Exactly. So, and then finally we have a cryptography stream. And this stream accepts the memory stream as part of its constructor. It also accepts the encryptor that it will use to encrypt the content. And let's get hold of that. And it will also say, okay, this is the mode that it's going to write to this stream, because we can also read and pull in different directions. But for consistency's sake, we're always going to be writing.
Just a wrapper around the stream is what it ends up being.
Exactly. And that's very, very simple to use. We're basically writing to the crypto stream.
Yep.
The data we want to protect that's already encoded into
or
a byte array.
writing to the memory stream. Got it.
Well, we're writing through the crypto stream, which writes to the memory stream by doing the encryption.
Okay, okay.
And then this is just a simple offset where we want to start in this array. So we're starting at the beginning.
It's friendly.
And we're running all the way through the length of that array. So we could actually just encode a small part of it if we wish to, but obviously in most scenarios you want to encode the whole lot.
Yeah, you'd have to really know what you're doing if you're going to just do one paragraph.
Exactly. Now, because we're dealing with a stream, the way streams are optimized to work is they generally write in chunks. And so if we haven't completely filled a chunk, then it won't have flushed the stream. So what we do is say flush the final block even if it's an incomplete chunk.
Sure.
And that's what we're doing there. Then I get hold of the memory stream, convert it to an array so that it takes that buffer of variable size and outputs it as an array and writes it into symmetric encrypted data, which is a byte array I declared.
It's a simple
up
byte. And I could take that byte array then and write it to something. Put it in a database. I could put it into a file now.
Exactly.
And beautiful. All right.
Yep.
So now I've got my byte array completely encrypted, and I super secret secrets are secret.
Exactly. And then to decrypt it, it's pretty much a very similar set. It's pretty much the same pattern. The only difference is we're using our algorithm that we created up above here.
Right.
Instead of saying create encryptor, we create a decryptor. We're passing in the same key in the initialization vector. We're using a memory stream again. We're using a crypto stream. We pass in the decryptor this time.
Yep.
We're still writing to our memory stream.
We are.
And then we basically say crypto stream write.
And it knows what to do because that's what you created, a decryptor, not an encryptor.
Exactly. And it takes our encrypted data and the length of it. We flush out the block again. And we write it back into the unencrypted data. And then down here, we do a sequence equal to compare those two, and we'll find that they were exactly the same contents, that we have successfully encrypted and decrypted it. So this is both sides of the conversation of using encryption.
And I think what some people don't realize is that in the decryption of text, it will actually correct your grammar. That's probably the only change between the two. It won't actually do that, of course. And now we have this is symmetric, and I think it's worth reminding. I meant to say this at the beginning of the module here that all the code that we have and that we're showing is in a solution that's available to you. You can download it right now. It's at xaml.codeplex.com. You can look there at the Microsoft Virtual Academy link and download it and go through it as well. We just showed off symmetric decryption. Right below it is asymmetric decryption as well. You can look at that and you can use that code in your own application. You just use it for your own learning as well. So let's take a look back. This module has been a very meaty module. I mean, it really has. I mean, we started with the validation of types and this idea that we can't really trust everything that comes to us. And we don't. We can't trust it, and for the sake of the user, for the sake of the stability of our application. And we talked about design by contract and this contract namespace that allows us to not only interrogate things that come into our methods, but we can also do it out. And not only can we do it at runtime, but we can also do it statically while we're developing. And then we talked about the special ways of handling exceptions and how exceptions are exceptional and we raise them on purpose, but when they do, how do we keep them from wrecking our system? We do that with different try blocks, and then how try block can catch, but it also has that finally to ensure some sort of action that needs to be done when all of those operations are complete. And then we went through encryption and the complexity of encryption, and really how that complexity has been sort of winnowed down thanks to the framework exposing both file encryption, the native Windows protection, as well as going all out with symmetric or asymmetric encryption.
Yeah, and obviously we didn't get to the asymmetric part, but you can see that embedded in that solution.
All right, we're going to take a quick break. We'll be back in 10 minutes with Module 5. Enjoy. Got it. All right, good. Hey, welcome back. This is Microsoft Virtual Academy. This is Module 6. We're talking about the Jumpstart for C#. This is exam 70483. We were just talking about encryption. We were just talking about, what was the last thing we were talking about?
I have no idea.
I think it was encryption.
Yeah, encryption definitely.
Yeah.
What was before that?
Oh, it was all the trust stuff, remember?
Exactly.
Yeah, we had all the data. All right, now we've got some more things to talk about. Darren, what's going on in this module?
So this module, we're going to be talking about splitting assemblies
All right.
and the relationship to assemblies and projects. And we're also going to start talking about diagnostics and instrumentation.
Okay, brilliant. Well, let's get started.
Let's dive in.
All right, so I guess we can't use terms without defining them, such as predicate, for example. So let's define some of these terms. All right, assembly. What is an assembly?
I just wanted to put a shout out to Frank and say, hey, your time is great.
Yeah. Oh, hey, yeah. He is killing it with that. He has got it going on. All right, no, seriously. What is an assembly?
You're welcome, man.
An assembly is a container for a set of resources and types. That's a kind of a sterile way of saying it, but it is totally true. If I were inside Visual Studio and I had my solution open, I would add projects to that solution. In a sense, a solution is a container for projects. Projects, however, is a one-to-one for what an assembly is. It's a container of all my code. It's a container of all my resources. I can have more than one. They can reference each other, and by that, they can talk to each other. There's a lot of value in assemblies to logically or really physically group my code together into a single place. We can have multiple files for an assembly. That's quite a bit of work. The general assembly is just a single file. It's just, I feel like it's like United Nations General Assembly here. Here we are.
Exactly.
So there's more to that.
Like a DLL or an executable? I mean, when you talk about files, what are they?
Well, the answer is yes. All right. An assembly is whatever your project ends up being. It could be an EXE, right? If you're creating some sort of executable, okay. Absolutely. Could be a DLL, absolutely. It could be just a library that you reference into your project. Mm-hmm. It could even be a WinMD, and we'll talk about that as a Windows component that we could create for Windows 8 using Windows Runtime. All right, beautiful. Great. There is a little bit of, it's not really a confusion, Darren, but it is a kind of a balancing act between namespaces and assemblies. So if I were talking about specifically a namespace, or specifically an assembly, that's a file, right? And even though it could be broken, let's just talk about it as a single file.
Yep,
single namespace is logical, where an assembly is physical, a namespace is logical. It could span not just multiple files, multiple assemblies as well. It's just a way of grouping logically all of the code, all of the classes, all of the work that we're doing into one place that might span different files.
Could we also have multiple namespaces within a single assembly?
Right. So just like a namespace can be across assemblies, and a single assembly can hold any number of namespaces, because a namespace is such a simple little container. It has no functionality. Just a grouping is all that it really is. That's awesome.
That was only mildly distracting.
Anyway, so that's what that is.
We have somebody who's suddenly playing music in the back of the room.
No, I think he's watching the video, and it's just he's a handful of seconds behind.
Oh, that's
right?
awesome.
Yeah, that's why it sounded so good. I think it was my voice.
I can't believe that for a moment.
The fidelity was beautiful.
Okay.
All right,
back on target.
Namespaces and assemblies. All right, for sure, an assembly defines a scope. It defines where things can be executed, just like a namespace can define a much larger scope. Mm-hmm. And so if I'm inside a namespace, often that's a domain, and we can stay inside it. And so if I were trying to pick between a namespace and I was trying to pick between an assembly, more often than not, all of the code you have will end up being in an assembly when it's geared towards a specific platform. It's geared towards having a specific set of, say, logic. I'll create an assembly of type library whenever it's something reused across all of my applications, and I might have an assembly that is like an executable or some sort of UI whenever I'm building the UI.
So give me an example of what you mean by namespaces.
A great example of namespace are the ones that come with the framework, like system, right? System is certainly a namespace that spans many different assemblies. System.file, right? So so we know that that's a sub namespace, but it's system.file is the namespace. And so we are able to then have all of the file-related classes and extension methods and pieces like that all contained together, and I can put them all inside a single assembly if I want to. In this case, they do. So I would have a namespace that would be when I'm creating, say, a Windows 8 application, I'll have view models inside my XAML application. And often, I'll have a view model namespace. Not only is it nice to have them all contained that way, but it's an easy way to find them too. Whenever you're looking for something that does file I/O, it's neat to be able to go system.file, right, or system.io.file, and be able to see all of it there. And so it's not. I mean, eventually, a large application is going to have a lot of code, a lot of methods, a lot of classes, a lot of things you can interact with. This is an easy way to find them, and a nice way to kind of keep your code clean. It really is more about just discoverability and cleanliness of your code than anything else.
So we also mentioned that you can spread your namespace across multiple assemblies. Give me an example of why would we want to do that? Why would you want to split up what? By giving it the same namespace, you're kind of implying that these things should be grouped together. So why would we have different assemblies?
Well, that's a great point. I may have a foundational namespace that goes across my entire company. And so then I would have, let's say I work for Acme. Let's say I work for Microsoft. I would say Microsoft.
You do work for Microsoft.
Yeah. Are you a company shill like I am?
No. Well, I am for my company.
Ah, very nice.
Exactly. Crank to 11.
Yeah. Oh, don't mind if I mention it now. All right. Yeah, so I might have a namespace that refers to my company. It's often common for your company to be the first namespace in a longer one, and dot my application, but my application breaks into different pieces. There's a web component that sits on all the services where I have WCF services, let's say. I also have a WPF client as well, and then I also have a Windows 8 client and a Windows Phone client. They really do all share similar namespaces, but I've broken them into separate assemblies because they actually don't belong to each other. When I write code specifically for WCF or WPF, either one, I'm not going to share between them the exact same, the UI logic on the service or the service logic or database logic on the UI, but they will maintain that same namespace for the continuity of it as well. So what will happen is I'll still be able to say company dot application dot, and then be able to drill into whatever's local and referenced inside that project. So it allows me to keep some sanity around a lot of code and still be able to have a consistent way of interacting with it, but not necessarily have all of it in one place, and because it just doesn't belong there. Stuff I do on the phone doesn't belong on the server.
Yeah. Oh, and there's another advantage as well. Say, for example, you're writing unit tests, which I hope everybody is. You could create a sub-namespace which contains all your unit tests. You have them as part of your application itself in your development environment where you're running your unit tests all the time, but you may elect not to ship the DLL, the assembly that contains those unit tests.
Yeah, so you would take your unit tests and extract them out to their own assembly.
Correct.
Yeah, absolutely. Yeah, you wouldn't want to ship your unit tests.
I've seen some that do.
Yeah, I've seen a lot of things.
Actually, part of your installation validation, you could run your unit tests in it, for example.
Yeah.
It's pretty cool.
That's an interesting idea, actually. I hate it.
It's only because it's a good idea.
Yeah, I hate everything good. That's the truth. All right. And then, so there certainly is a difference, but it's easy to misunderstand. And you could actually wonder, you're in system looking for something that doesn't exist. You have a reference to that namespace. You would think it's all there, but it's not. You can actually expand the namespace as you reference more assemblies.
One of the interesting things is, we were talking about encryption, and we were talking about hashing, and we were talking about signing. If we've got these assemblies that are being shared publicly, and they are supposed to do something, how do we trust that we've got something that is actually going to do what we purchased it to do? How do we know that somebody hasn't put some nefarious code and shipped it out as the same assembly name?
Well, that's a great point, and it is a dangerous situation if you think about it. I could be buying a suite of components from somebody to make my application look really cool. I get it, but I'm downloading it, from some nefarious operator, and I get it. It looks just like it, but little do I know it's actually a backdoor into my application. Yeah, that is a dangerous piece. How do we solve it? It goes back to kind of what we were talking about with encryption. Explain it to us a little bit.
So basically, you can have an assembly, and you can mark that it should be strong named. So strong naming will allow you to go in and specify a particular private key that will be used during the compilation process. The Visual Studio and the compilation environment would inject into that assembly a signature, and that signature could only be produced via the key that you have available. If you've purchased this key from a trusted source, then you are digitally signing that assembly with your identifier, so that a consumer can verify that this assembly has originated from you. It is also a prerequisite that assemblies have to be digitally signed before you can install them into the global assembly cache. What's that?
And we say strongly named, we're basically saying signed.
Exactly. We're basically saying that we have incorporated into this a contract that expressly guarantees that this assembly is from whom we say it is.
Yeah, and so GAC, what you were talking about before, the Global Assembly Cache. So we all have it. The Global Assembly Cache is in the Windows folder. It is where reused assemblies go, and they're at a global scope. They're then usable by anything that's installed. Very similar to registering a DLL back in the COM days. What's special about it is different versions of these assemblies can sit side by side. And so once they're side by side, it means I'm no longer version dependent. I can use whichever one that I need to, and it kind of removes that, I don't know, DLL hell that they always talked about, where some program would need to update to get the latest version so they could have its functionality. Meanwhile, other applications which relied on those older features or relied on things not to be the way they were in the newer versions get broken. So the GAC solves that by allowing them to be side by side, but the main purpose of the GAC is really to create a globally referenced set of assemblies.
Okay, so fundamentally we can put a using statement at the top of our source files, and we should be able to access them without having to worry about making sure they've been installed for our specific application.
Yeah, that's right. Now there's certainly, it will not be in the GAC if you haven't put it there, right? There are some that just ship with Windows, and you have quite a few, all the system ones, of course. But if you have one and you want to put it so that it can be reused across all the different applications you're releasing, say for your enterprise, it's your responsibility to put it in the GAC. You can use GPO to do that too, of course, and it will.
Is that group policy?
That is group policy. It can put that into it for all. You don't have to go from machine to machine.
Okay, so that's kind of an IT administration activity.
It is. Okay. I hate to talk about that sort of thing.
Exactly. Go wash your mouth out.
Yeah, but nonetheless, once it's in the GAC, then we can reference it globally. And the benefit of having it like that is not just reuse, but it also allows the deployment of my application to the different desktops to be much smaller. I don't have to always include every reference to assembly.
Okay, and also when you purchase, say, vendor toolkits, their installer may well install their assemblies into the GAC for you, so you don't have to worry about doing that.
It's true, and it's a common accident that developers will ship thinking that it's in everybody's GAC when it is really only in theirs.
Which is kind of scary.
Yeah.
Same for source code control.
I've never done that, but I have heard of developers making that mistake.
Yeah. Nobody this side of the camera has ever made that sort of mistake.
We have a session later, on debugging. It was really, I had to learn a lot.
Yeah. Yeah, I've never opened debugger. It just runs first time.
What do you do with that?
Why would you need it? Okay.
Yeah. All right, so now back to sharing assemblies.
Exactly.
I mean, this is the real point, is I'll create an assembly. You can't get away from an assembly. One project is an assembly, and so you can't have a project without one. But the reason I would create multiple is probably for sharing and reuse, right? Being able to hand across. If I were inside the same .NET framework, then I don't really have to worry. I can create a library, a code library, class library, and I can share to my heart's content. And an individual assembly can have other assembly dependencies, and they all ship together. You can't just bring one over and it doesn't wrap all the assemblies.
Because there is actually a disadvantage to using lots and lots of assemblies, because they all have to be loaded when you start your application, especially if you've got hard and fast references that need those things during startup. And so there are actually many patterns of application development whereby you actually have dynamically loaded modules that are done during runtime.
Yeah, that's powerful. And and the opposite is a good practice for developers too, where after they're finished with their application, to start looking at the references inside their project and removing them so that they don't have that extra memory burden.
Exactly.
It's costly in memory and boot time or startup time for their application.
Yeah. So one of the scenarios is, we create these, say, class libraries,
Yeah.
these shareable components, and I built stuff in WPF, and I'm referencing all these WPF capabilities, and I've got all this logic, and all of a sudden, I'm building something, say, for the App Store,
Yeah.
and I've got all this logic, and I can't reference this assembly.
They're totally unrelated, aren't they? They're incompatible with each other.
Yeah.
And
Why
so
is that?
Well, partly because they're built on different frameworks. And so when I write something for the desktop, I'm using the .NET framework. When I'm writing something, say, for the phone, I'm using the framework for the phone. And when I'm writing something, let's say, for Windows Store apps, like you were alluding to, I would be using WinRT. All of those are very similar, and they give developers a similar experience, but they certainly are different technologies in reality. And so as I build one for one for another, they are incompatible with each other, but we've solved the problem.
Oh.
Solved the problem with portable class libraries. So
That's well named.
it is, because it's portable, and
It's a
they
class
are
library.
class libraries. Yeah, it's all fantastic. And a portable class library, often the shorthand is just PCLs. So you'll create a PCL, and what it allows you to do is it feels just like a class library, by the way, and interacts just like a class library, but it generates a common denominator. So, for example, let's say you're writing an application for Xbox, you're writing an application for the phone, and you're writing an application for the desktop. Now, for the desktop, you have everything, because that's the big mama. But all these others have their own limitations.
Is that a technical term?
It is. It's on page 42.
Okay, awesome.
And anyway, so the reality is lots of the functionality that's on the desktop is not in the Xbox, right? And so as a result, because it's a portable class library, you can only include technology that is true for both. And so now, regardless of the fact that it's supported on the desktop, the portable class library removes capabilities inside the PCL.
So I can specify what platforms I want to target on that portable
Yep, that's
class
exactly right.
Okay.
When I create a new one, it lists all the platforms, and I select the ones I want.
Excellent.
Every one I select reduces more functionality, right? It can get pretty brutal.
Potentially.
Yeah.
Potentially.
Yeah, I mean, for example, reference to directory services, right, is not available when I'm on the phone. And references to other subsystems like that are often not available when I'm on Xbox or when I go to a web client or something like that.
Okay, so some couple of best practices to think about then for using these portable class libraries. They should be focused mainly on behavior, functionality, and so on, and not necessarily system-level interactions. They could be data shapes, my data objects, my business rules applying to those data objects. They may perhaps define contracts that interact with systems, and we can use things like dependency injection and so on and so forth to abstract out the implementation of those services.
Right.
But it's more of a concept.
Yeah, there's a pattern, interface design, and that's an important pattern when you use PCLs, because often, now here's an example. If I could build a console application, and I have a PCL for it, and I create a service reference out to a web server. That's really handy. But now I've included the capability of, say, Windows Phone 8. Windows Phone 8 doesn't have that capability. So now in order for me to still be able to interact with it, now I have to handle, instead, an interface, allowing each of the systems that consumes it to pass a reference to it using just the interface. So these kind of design patterns are just things you can't get away from when you're using a PCL, because as you start making it a lower common denominator, you're going to have to work around that so you don't lose all the functionality, and there's no reason to share code in the first place.
Absolutely.
Yeah.
Great guidance.
Thanks. Now, Windows 8 is a little bit different, and it's not really a portable class library. It is a class library for sure, but it's specific to Windows 8 store applications, and those are WinMDs, or Windows component libraries, right? WinMD is the Windows metadata. It's really describing everything that's inside this library. And so I would create a WinMD not because I want to share with other platforms. I would create a WinMD because the logic that I have inside my library should be shared with other languages. So, I mean, there's a whole mess of snakes here, but the reality is this: if you're writing a Windows 8 application, you have choices as far as languages that you use, just like if you're writing a desktop application, you have choices as far as languages that you use. And in the case of Windows 8, I could write it in C++, C++CX, or I could write it in a .NET language like VB or CSharp, but I could also choose JavaScript. All three of those, and we want to give support in parity all of those different languages, and the way that's accomplished is through a Windows component library, which basically takes your code down to a lower level that can be, and we use the word projected, into all the other languages. So I can write something in C# that I can take down to a Windows component level that can be projected up into a JavaScript application and used in complete parity. It can also be projected up into C#. I could also, or into C++. I could also go the other way. I could say I could write it in C++, which is a common scenario. You know, like game developers may have a lot of their game logic in C++. So they bring all that logic down into a Windows component, which is actually quite rich and capable.
Yep.
And then they can expose it to JavaScript developers. A lot of power there.
So it's very similar to the value of the unified type system and the ability to write something in C# and share with VB in the managed world, but it's a different infrastructure that is tailored to support the Windows App Store environment.
That is a great way to say it. It is a different infrastructure tailored just for the Windows App Store, and they are foundational types rather than common types.
Yep.
But same concept all the way around. And the point is, foundational types can be translated into the consuming technology. So you may whatever types you interact with in C++, when they are projected up into C#, they're .NET types like I would expect. And when I interact with it with JavaScript, those are I interact with types that I would expect in JavaScript as well. So those are WinMDs. In fact, I have a little walkthrough here. I want to do that. Let me pull up my Visual Studio here, and you know what? Let me start from scratch. It's kind of fun to do that sometimes. Okay. And I'll start a Windows 8 app.
Can we see his?
And so that's the whole demo. What'd you guys think? No, just kidding. That was for you, Barry. All right. All right, so I'm going to create a new application.
Oh, the power.
I'm going to create a new application here, but it's going to be, I want to demonstrate WinMD specifically. So here we go. So I'll create a XAML application. And so a simple XAML application using C#, I'll go in and I'll start building out an easy UI. And so let me just do that real quickly. I'll say, I'll use a tool, I'll just build it out with the designer. And let me see, how about a toolbox, or text box, there we go. Text box, and maybe another text box here. I'm gonna add a quick, text block, so I can just have some simple text here, and then a button. So this is cool. The entire designer for Windows 8 development matches the experience that you would have in Blend because it's the same code base for the designer. It's really rich and nice. I'll add a button here, or a button I mean. There we go. It's something to cause the action to happen, and then we'll have some sort of result right there. Very nice. And so let me give everything a quick name so that I can talk to it. This will be, and we'll make it real. This will be T1. This will be T2. These are terrible names, by the way, Darren. And T3. Terrible name. Not a best practice. Not what I was intending to show there. All right. So let's make this in fact, let me make.
You're a dev designer, aren't you? I can tell just from that UI.
I'm an awesome dev designer. Are you kidding me? Nice indeed. All right. So there we are. There's the plus. This is going to be an addition application. So I'll go in here, I'll say, let's default it to 1 and 2. Well, that's not 2. And then this will be where the result goes. We'll make this 3. All right, so it's just simple enough. I just wanted everything to have some default data. Here's the button. The button obviously should not say button. It should say equals or calculate or something like that. And let's see, I'll also make it nice and big as well. Let's see, that's probably too big. There we go. All right, good enough. I'll have a handler then for this, and I'll say when it's actually clicking, I want it to process the two values, and I want it to add them together. Now, I know that logic is too sophisticated for me to allow it to be rewritten over and over again. So instead, I'm going to add another project here, and I'll say add new project, and I'll go again to Windows Store inside C#, but I'll take instead the Windows Runtime component, and this Windows Runtime component, here we are, is going to have class 1, and I'll just leave its name for now. And I'm going to create a static method. That's just so I don't have to new it up every time. And I will create a static method called sum them up, all right, just like so. And it's going to take in 2 values. And boy, I've got all kinds of problems because I'm doing a terrible job. There we go. All right, it'll pass in value 1, and it'll also accept value 2. Now, I know in all reality this is simple logic, but just imagine that there is a computational piece here, and it is the sort of thing you don't want all of your logic to be repeated, tested twice. Instead, you want to reuse it. And so now I'll just return v1 plus v2. Simple enough? So far, so good?
So far, so good. Is there any restrictions on what we can return back?
Yeah, there really are. Now, there are fewer restrictions, of course, when you create a class library, but because this is a Windows component and it's going to be brought down and shared, there are several rules to make sure it doesn't become incompatible with the other languages. One of them is that we can't use generics. We don't want to expose generics or require generics to be passed in, because not all languages support generics. We can certainly use generics inside the implementation. We just can't have that as some of the exposed pieces.
So we also wouldn't want to try and return like an anonymous type or anything along those lines.
Right. Anything that is specific to one language is something that you shouldn't do. Also, when I create a class, all of its members need to be public. There actually are several rules that we go through. I mean, probably about 6, right? 6 rules that we go through to make sure that you don't write a Windows component that is invalid. The nice thing here, though, is the compiler's on your side again.
Okay.
Right.
Compiler's awesome.
You are not going to be able to write a component that is incompatible and build it. You can write it, but you won't be able to build it. All right.
Okay,
so here,
awesome.
this is my reused logic. Let me kind of nuke some of the stuff that's here so we can have. I don't like having too much so it looks like it's real complex when it's not. All right. So here's the button 1 handler. This is my project, app 1. I'm going to add a reference, and then when I do, I'll add only from this solution. And I can see here's my Windows runtime component. It's called Windows Runtime Component 1. Again, an excellent naming convention. This is what I would recommend for everyone.
Your muse has not yet deserted you, that's for sure.
Yes, yes. It's wow, that's great. All right, so here now you can see all the references sit side by side, and they're all indicated specifically on what types they are. The little boxes next to them show me that it's a Windows runtime component. If I were to add a class library specific to CSharp, it would look. It has that. It has a little box with the CSharp next to it.
Would that be an icon of some sort?
Yeah, it has an icon.
Yeah.
There's no color to confuse you.
Yeah, it's awesome.
We got rid of all the confusing colors in Visual Studio, so that's one of the best parts. All right, so now I can reference it directly. So if I say Windows runtime component 1, this is me referencing, or me making a referral, I suppose, to what I referenced in my application. And I can say dot, and I can see there's that class 1, and I don't have to invoke it because I made it static. And so I can say dot again, and there's sum them up. It expects 2 things to come into it, two different values. So let me go ahead and get those from the text. Let's see, it was t1.text.
Okay, whilst you're typing that, we had a question that came in that talked about does the compiler remove unused references at the top? So one thing to bear in mind is those usings are just shorthand so that you don't have to type the full namespace. It is not that is not what includes your references. If you could flick out to your references on your solution there for a second.
Yeah, let me jump up.
So here we have a long list of namespaces that we've imported so that when we start typing a type, this is where the compiler checks to see if they've been implemented. If you look over into your references inside solution, this is where you can add references to external assemblies and bring them in.
If I add a reference for an external assembly and never use it, it's still there even when I build.
It's still there. It's still placed as a dependency for when this component is started up. So the compiler doesn't take into account and roll all the way through your code to say don't use these references. There are actually third-party plugins such as ReSharper and some other tools that can do that for you and remove unused references, but that's not something that's baked in. Great question, thank you.
So here's the implementation, just 3 quick lines. I needed to parse the text to turn it into the right type of a double. And so I have my double and my 2 doubles. I pass them in to sum them up. It returns it. I just convert it quickly to a string so that I can set it.
You're passing T1 text to both of those? Is that what you wanted to do?
No, I actually mean T2. I appreciate that.
You're welcome. Because it would be nothing more embarrassing than having an add method that didn't add properly.
I could think of something more embarrassing. And so, and then I just set it in there. Now, so if I were to run it, and I'll go ahead and run it, the nice thing is that logic, and again, I recognize it's actually very simple logic, is right here, it's abstracted out into a reusable assembly. This is a special assembly that is not meant to be reused from app to app, but reused across languages app to app, which is very special.
But you could use it app to app as well if you wanted to.
You could use it just like a class library. Yeah. But unfortunately, not unfortunately, but just the reality is, you would still have to obey those rules. And you can't go break it for other languages, even if no other language actually works. So I'm going to hit debug and let it run on this local machine. Here's my beautiful UI that I put together. 1 + 2 equals, and I'll blank this out so I can actually see that it runs, and then it comes back to 3.
Awesome.
Let me show you something. If I said 1 plus 2.1, that also works.
Ooh,
I just wanted to prove it wasn't
magic.
smoke and mirrors.
That's just magic.
Demos are never realistic.
What happens if you put Fred in there?
It would not parse, and it would.
And we would get an exception.
We would get an exception right where it tries to parse.
You were paranoid. You did not protect yourself from some user.
It's because I know who the user is.
Exactly, and that's why you should have protected.
He's trustworthy. He's trustworthy. He's my favorite user so far. He's the one who doesn't try all the edge cases. All right, so let me add another project. So here's a second project, but this time I'm not going to go to C# Windows Store. This time I'm going to go down to other languages, JavaScript Windows Store.
Goodness. I wonder if Palermo's still on. He's dancing a happy jig right now.
You know what? He's probably, yeah, that's right. Never has he seen me write a JavaScript app. But
I'm not entirely sure he's going to yet.
Oh gosh, it's easy. It's easy not to like you very much. All right, so. All right, here's my UI. It's a simple little UI. I'm going to just throw it together really quickly because I don't want to do a bunch of HTML anything. That's just because I'm a XAML guy. You know what I mean? But the reality is, different applications need different technologies. Different development teams need different technology. That's just the way it goes.
Yeah.
For me, it's XAML today. So I'll create
there's a lot of value in being conversant across different languages and different environments and so on. In general, as developers, we should strive to be competent across a number of different technologies because it really helps round out our experiences, and we can also understand where certain features come from. We mentioned earlier on that contracts came from Eiffel. There are a rich source of different languages out there that really complement your skill sets. So if you've only focused on one language, I really do recommend looking across a broader scheme.
Yeah, that's just good career advice.
Exactly.
Yeah. All right, so I'm going to give
This is just the course that keeps on giving.
Yeah, this has become like a self-help kind of course.
Exactly.
Yeah. If you find that the technology seems stale, just try another technology.
Exactly.
All right, so let's see. I want to give some default values as well. Equals 2, and then we'll do it down here. Instead of 3, which made it seem too easy, I'll set it to 0. All right, very good. I need let's see. I'll say on click. And then, you know what, obviously, if I were writing a true HTML application, I know that I would separate everything out. CSS classes, Java files, things like that. I'm not going to do that here because it's a demo.
Because it's a demo.
Right. And so let me, here we go. So let me call this in the on-click here. Oops, on-click equals, do work, ORK. Everything look all right?
It looks pretty good to me.
Okay, just making sure. All right, so just like our previous project, these all act exactly the same. So I made a reference in app 1 over to my Windows Runtime Component 1. I'll need to do the same thing inside this one. Okay. So I'll go to its references. It's the same dialog. I go to the solution, and they're all listed here.
So wait, you're saying that this will be available in JavaScript?
Now, yes, I'm going to say this is going to be available in JavaScript. You read my mind, or the slides. And so we.
But there's something on the slides.
So what's beautiful now is this runtime component written in C# is about to be leveraged by a JavaScript application. So here I can say it'll be Windows runtime component 1. Class 1. This is the same experience as I was having over on C#.
So you've got IntelliSense as well.
That's right. The tooling around JavaScript for Windows 8 development really is rich. I mean, it really is. But I want to show you something interesting. Here's my sum them up. But look what's special about it.
Is that a different case?
Isn't that interesting? Yeah, the convention for JavaScript is for the first letter in a method to be lowercase, and yes, in a method to be lowercase. But I didn't do it that way. If we were going to go back to it, you would see I would have followed standard C# notation instead. And so here I'll call sum them up. It's neat how this is all done by the projection. Again, I didn't write sum them up with a lowercase s. I actually created the metadata for it that was projected into JavaScript. It's very powerful.
So this is interesting. So we're in JavaScript and we're consuming something that's been implemented in, say, C#. And you've mentioned that we could do it in C++. Can JavaScript be used to produce a WinMD component that could be consumed by C#?
You cannot. So the only languages that can create WinMD files or Windows components are only the .NET languages or C++. If you try to create it in JavaScript, well, there's no way to do it.
Okay.
There's no option. In fact, I don't know if you remember that file new, when we went to JavaScript, there was one. Right, there was one option to choose from. Okay, so here we go. Now here I am. I'm calling it. I'm just breaking onto another line so it doesn't go too far over, and I'll set t3 dot value. So the value with the lowercase v. There we go. All right, so this is this logically is almost identical to the implementation of the of the logic that. What is this? Can you help me?
No. You're on your own, Jack.
The logic for the button click is almost identical to the logic that we implemented for
And what we can actually see there is a
JavaScript.
very common syntactic root. As we were talking about beforehand, how many of these languages are inspired from the same sort of foundational base. We can see that it's very much the same syntax there.
Well, that's a great point, yeah, with open and closed little squirrely brackets. You're absolutely right. All right, so this will run the same way. I'm going to set app2 now to be my my startup project and go ahead and debug it. It'll deploy it out for me and run it. It's very similar looking. I didn't take any time to do anything fancy with it. 1 + 2 equals. Now when I click on the equals button, it'll execute inside the runtime component again, the exact same logic that I'd saved from before.
And there is 3.
And if I were to put a decimal or whatever, it all works the same.
That's amazing.
And just like you said before, if I was going to put Fred, it would fail. There's no reason for me to show a failure. Just trust me, it'll fail. Right, there you go.
Well, it's handled gracefully in JavaScript.
Yeah.
Because of the dynamic typing.
Yeah, you should see it in C#.
Exactly.
All right, so that is a WinMD. A WinMD is a Windows runtime component. It's what you can create specifically for Windows 8 app development. Okay, so that's how we share code across languages. Class libraries are how we share code across assemblies or different projects. And then portable class libraries are how we share code across platforms, right? We're not specific to Windows 8, but specific to really the Microsoft platform.
You want more the .NET ecosystem.
Yeah, the .NET ecosystem is probably the best way to say it. Yeah, it doesn't go everywhere, but it certainly goes wherever fine .NET is sold.
Indeed.
No doubt. All right.
Okay, so let's moving on. We're going to touch on diagnostics and instrumentation right now.
Another important part of your application is
and I
to
know
make
one of your
sure-
personal favorites.
It is. It really is. It's kind of like code contracts. If you're going to write an application, you need to be able to make sure that it's a good experience for the user. One way to do that is to design the UI, but another way to do it is to make sure that it performs properly. And now, being able to determine if your application is performing properly is difficult. It's very difficult. Odds are the developer that is creating it has a monster machine that is awesome, and it could load on almost any your application on almost any other device, and it's going to be less powerful than the developers. I mean, that's kind of a universal
Well, why
truth.
don't we just tell the users to upgrade?
Yeah, just get some more RAM, get some more.
Exactly.
Yeah, but in case that doesn't happen, we can do some profiling and analysis on your application for performance. How do we do that? Well, let's talk about some of the terminology first because it's important. So it starts with instrumentation. Instrumentation is the part of the code that you include that stores performance information. So every time a method is run, you might want to have that as an instrumentation point where you log it, right? That's a possibility. Or perhaps when you call a database and it takes 10 seconds or it takes whatever seconds it is, you want to take that and that resulting number and let that be instrumentation points as well. And so the instrumentation is just the practice by the developer to go into their code so that they can go to these specific points where performance might be measured and be able to contain those points or be able to expose those points so they can be stored somewhere and analyzed.
So it's like web analytics, but for your code instead.
It's like web analytics, but for your code. That's a great way to say it. And it's effort. This isn't automatic. There are tools out there that will analyze your code, but the best way to add performance measurement to your code is for you to do it. You understand your code, not a generic analysis tool. Although those tools are very powerful.
Yeah, I mean they can certainly give you a lot of insight, but as you say, there's nothing better than intentionally introducing instrumentation into your application.
So you have instrumentation that takes these data points and puts them out somewhere. Wherever it puts them, that is your telemetry. That is the data that you can use for diagnostics. And then you perform analysis against that telemetry, not only to try and figure out why something went wrong, why something went slow or whatever, but also because you might be looking for trends. And telemetry can give a great example is Internet Explorer. We went from one version to another and the favorites button changed, or the favorites menu changed, right? And the location changed. It was a little harder to get to, and that's because of telemetry that showed us that people weren't using that way, that method.
So you could bring something that was more popular to the forefront and move something that was to the background.
That's right. It's not just about finding bugs. It's not just about making it faster. It's making it better.
I mean, also, there's a lot of value in running instrumentation in a non-critical scenario because it allows you to establish a baseline so that you can then determine when you've deviated from that baseline.
That's right. If you think it's going slow, how do you know if you don't know how it runs when it's not slow?
Exactly.
Yeah, that's right. And creating that initial baseline, and you may have several baselines when you're all done, because you may have baselines based on device configuration. Right? That's a big deal.
Yep.
Okay, so let's talk specifically about performance counters. This is a Windows Windows capability, I guess is the best way to think of it. Performance counters are out there that you can leverage as a .NET developer. You can go and create new categories for counters, create new
So the .NET framework already has instrumentation baked into it?
It does, it does. And no, the Windows does. And then the exposure of performance counters is through the .NET framework. And so, and then of course probably the framework has instrumentation, by the way, of its own.
Yeah,
you know?
like memory allocation and those kind of things, so you know what's going on there.
Yeah, but your app, it doesn't implement it for you, of course. It just allows you to easily kind of access the performance counter subsystem inside Windows. And so performance counters are really a discrete number, and they're a number that reflects the current state. So let's say it is how long it takes for a user to log in and this process of calling the database and encrypting their password, or whatever it is, right? You're going to measure that time with a stopwatch or something so that you can determine how long it takes. You're going to write that out to a counter, and that counter is going to say how long it just took. It's not going to keep an eternal history of it, right? So if you do want that history and you do want trending, then you use tools, and they have tooling to be able to capture what the performance counters are and then pull those down into some sort of store. And so we use like Performance Monitor can do something like that.
That's a great tool.
Yeah, it's a tool that we've all used to analyze other people's code that is slow, because ours so far is not a big problem.
With our 3 lines of code?
We kill it, don't we?
Exactly. It's like you need to run code that runs this fast.
That's right.
So do you need any special privileges?
Yeah, I think that's important, is that you can't just write to it, right? You can't have somebody with no privileges on this machine to go creating categories, creating performance counters. No. You do have to have the right permission. Permissions change if you're just writing to it or reading from it, but certainly to go and create new ones, you have to do something.
Awesome.
Yeah, absolutely. Okay, so let's see. This is a presentation, or this is a snapshot of performance counter. It kind of shows the graph that you can get back. It's not necessarily real time, but it certainly can be real time.
My screen, Barry.
When you're done, guys.
Barry, my screen, please.
It's the other one.
That's it. Thank you.
So
it's all about us, guys. Come on.
No, it's about the students. Okay. Yeah.
Stay on target.
Yeah, exactly. Working. Got it. Okay. So anyway, so this can show real time reading it as almost. It is actually connecting to it and treating it like a stream, because this sort of trace information is very voluminous. And so here I can pick the individual ones. This one is just the processor utilization, and you can start to see how it goes over time. But the code on the left shows how I can attach to it, and I can read from it, or in this case, I'm actually incrementing it. I can decrement it, of course, set it to an explicit value as well. The most common is to increment or decrement a count. There are raw values that are going to be important when you're coming to timing and things like that. Anyway, with this sort of data, once it's exposed, extremely, extremely valuable. What you do need to remember, though, as you write it out, it can be so voluminous that you start impacting the performance of your app by measuring the performance of your app, right?
Exactly.
Profiler for SQL Server is notorious for that, right? You go in and you're like, what do you want to, there's something is wrong with the performance of this query. What do you want to listen to? Everything. Now your query is so slower. Yeah, the tracing itself is the performance killer. So it is important to have all the instrumentation there, but it's also important to have some sort of mechanism or method that you can dial it down, and so that you don't have to have all of it being logged out. If nothing's going wrong, just leave it alone. And then, and so that's, again, that goes back to trace listeners, which we talked about before. And the trace listener can implement switches then that determine the kind of the state of the environment.
And the cool thing about traces is obviously it can be part of a released application, and you can change it through the application configuration to toggle how verbose it is, or whether it's on at all, yeah?
Yeah, you don't want to beat up a production user, but you do want to deliver this into production, because this is where problems happen. They never happen on your machine. They happen usually on the CEO's machine. That's kind of how it if
normally
CEO,
around
then
annual review time.
Yeah, exactly. Let me pull up your app for a second. What is this dialogue that says close? All right, very good. And then we also have event logs. I think it's worth at least pointing out that event logs are an excellent. You may not have like deep instrumentation inside your application, but you may have some. And a user just logged in, an invoice was just submitted, something like that. And there's no reason to not just use the event log for that. It's a great place to put high-level major events inside your application. It's not really meant for performance measurement, but it's a great way to kind of debug scenarios so you can see what's going on.
And also capture diagnostic output. Say, if an error does occur, you don't want to necessarily present to the user the internal stack trace of what's going on. You're going to give them a user-friendly message, but you could drop out into the event log and write that stack trace.
So that really you do two things when an error occurs. You do say to the user, we're sorry, right?
You do.
But you don't give them a whole bunch of mess.
Yeah, don't scare them.
You give to Windows, or the event log specifically, everything, so that we can diagnose what's going on. Exactly. Why did that happen to you?
Yeah.
Yeah. Just reboot is usually what we do.
Exactly.
That's the truth, isn't it? All right. So before we do anything, before we do this, let me pull up in Visual Studio here a project that has some performance issues. And let's look at some of the built-in diagnostic tools that we can use here that really not solve the problem, but just give us a mechanism to diagnose it, be able to find out what's going wrong.
Okay, whilst Jerry's bringing that one up, we just want to remind people to vote about the poll during the break. Reminder done.
Yeah, don't forget there's a poll. Don't forget, vote once, vote often. That doesn't work right. Vote early, vote often.
Get your demo going.
I don't know how vote often ever worked. All right, so here we are, diagnostic.
It worked often in Chicago, apparently.
All right, let's take a look at an interesting method that we have called run. And so run is a for loop. It goes from 0 to whatever it is I pass in. And then inside it is yet another for loop identical to it. And it goes from 0 to the number I pass in. And then it adds to a variable, and in 64 here, whatever that number is.
I don't know, but that looks like it might be a bad idea.
This is all a bad idea.
Oh, okay.
This is. We'll just call this.
Is this a best practice?
Performance simulator. No. Of course, it's a best practice when you're simulating bad performance.
I see.
Yeah, I guess you'd simulate poor performance. Mm-hmm. Yeah, but that could be bad. All right, so here we are. Inside my app, or when the application runs, I call these 5 methods. So this one is sort of nestled down here so I don't have to see it. These are the ones I want to investigate. I have a method called run 1, 2, 3, 4, and 5. Each one executes a little bit longer or a little bit shorter of a loop that's going to go there.
Okay.
And this sort of loop is difficult to optimize. It's a great way to show just burdening a system, right? So another thing I could have done is while true. Yeah, we talked about that.
We'd never got anything come back.
Well, that's right. We do want it to end eventually,
Exactly.
right? You can't diagnose eternity. You can, but it takes a while. So here we go. I'm going to write it out.
Result is infinity plus 1.
We know that
Consider.
it'll loop through, add these numbers together for us, and we'll write out the value. And the only reason we're writing out the value is so that I can see that it's finished, right? So we'll go through 5 iterations, and so let me go ahead and do that, and you'll see it takes just a couple seconds to really go through these. And, it takes, that one was quick, but this one's kind of hard. It's only getting harder now. And so if I had my processor, let's see if I can pull it up in time. I can't, I bet. Well, you can actually see it was peaked out, and then it dropped back down because the application just finished. Right?
Okay.
So I got to figure out what's killing my
thousands
CPU.
wouldn't.
What's that?
We'll believe you, thousands wouldn't.
Yeah, thousands wouldn't. This is good. And so this happens, when a user is trying to self-diagnose an application, this is almost all they've got. And so they'll pull this up and they're like, golly, my CPU is peaked out, what's going on? It's pretty neat. All right, so I'll go through the same scenario, but this time I'm going to select to use the performance profiler.
Okay.
And so this is built into Visual Studio, and what it does is it will run my application, perform all the tasks just like I would, and then it'll give me some feedback on what was actually going on. And because it's inside Visual Studio, when it does give me feedback, it won't say at this time it was this long. It can even tell me down to the method that was being called, down to the line that was being called.
Show me.
It's very powerful. Can I show you?
Sure.
All right, so it's under the Analyze. I want to make sure that everybody saw. Under the Analyze menu, I'll just select Launch Performance Wizard, and I'm going to just do implementation for now. This is the quickest way to kind of show this off. It's going to ask which inside this solution, we've got a lot, but the only one I really want to show is just this one I've set up for it, Diagnostics, after 26. I'll say Next, and here we go. I'm going to say Finish. It'll launch my application. Of course, it's a self-running application, so I don't have to interact with it. So it'll go ahead and launch it. It'll do
right
the
now
same process.
It's capturing all of the instrumentation outputs.
That's right.
Okay.
As well as all the common instrumentation like CPU utilization, memory utilization.
So this is an
like
example where observing it may actually change what's being observed.
It could. Yes, that's exactly right.
Cool.
Just because the analyzer is running, it might actually dial down its performance a little bit. Yeah, absolutely, it could. Okay, so there was a checkbox on the wizard that popped up the profiling report for me, and the profiling report shows me really interesting information. So along the bottom timeline here, it shows me in real time, real seconds, like wall clock time, they're saying. Here's the application that ran. It ran 13 seconds, and the line itself is showing CPU utilization during that time. And so this is good. It balanced out CPU utilization, but I want to be able to see, inside this period what is going on, or I want to be able to drill into individual methods down below. But what's also nice is it by default gives me all the hot paths. So the hot paths are those methods that take the longest, right? As far as time. And so here I can see run 3 takes the longest of all. And so if we were to look at what run 3 does, let me pull that little sample.
Can you just click on it and I'll take you to it?
Oh, yeah, it sure will. Thank you. Yeah. So if we were to look at run 3, that makes sense that it's the hottest on the hot path because it is 40,000 and everything else is a little bit lower.
Okay.
If we were to go back to that hot path and say, well, what's the next one after that? It had better be run 5, right? Because that's the next one down. I mean, that's the way that it's measuring it. So if we go back to it, we can see 3 and then 5, then 2 and then 4, and this is great. And I'm seeing the application. Maybe I don't know yet what is really causing it, but it certainly gives me the place to start rather than just saying how much RAM do you have installed.
And so obviously this is a contrived demonstration scenario, but we would encourage everybody to run this on their existing applications just to get a good idea of what's going on. One of the key traps that we sometimes fall into as developers is a thing called premature optimization, which is we look at something and we go, oh, I think this is going to be a waste of time and it's going to churn for too long and so on. The reality is this thing that we love so much, the compiler, is actually incredibly smart and will do an awful lot of optimization for you. It will look at an inefficient set of syntax, and behind the scenes when it emits the intermediate layer, the output of this compilation, it will actually do some optimization. So don't presume that something that you see is going to be the slow. improve it by using the profiler and do the analysis, and then only spend your valuable time and energy rectifying problems or performance hiccups that are actually identified by the tooling instead.
This tooling is great because it's built into Visual Studio. We talked about before, there's third parties out there that do probably quite a bit more, right? But this is a great starting point, and it almost takes away the excuse for developers. We don't have the tool. You do have the tooling. It's right here inside Visual Studio, and it makes your application that much better by adding diagnostics around it. I could also include now custom performance counters that I'm incrementing as well, right? I want to see, how many people are logging at once and different pieces like that.
Exactly. So really do an analysis of your domain. The other point I want to point out is make sure that you do this profile analysis in the release build, the build that's going to go out to production, because when you change your build configurations in Visual Studio, it enables optimization, which will actually change the execution path of the code behind the scenes. So you actually want to be measuring performance on those, on the true environment, rather than spending a lot of time and effort trying to optimize your debug build. Again.
Not every version of Visual Studio is going to include all of this advanced tooling, right? I'm using Ultimate right now, and you're going to need Ultimate, and I think Professional will include all of the diagnostics tools that we've shown tonight, or today, or whatever time it is.
Correct. You won't get this in the Express Edition.
It certainly will not get it in the Express Edition, also known as the free edition of Visual Studio.
Absolutely.
There's a free version of Visual Studio for every technology that we have.
Sure.
Very good. So, you can control the cost of performance counters by perhaps you could just you could write to them less frequently. You certainly don't want to do it too much. The way that you measure inside your application, you need to think about that and make sure that's not too costly as well. Well, you want to add this instrumentation so that you can make your app better. But the core takeaway is, don't add so much instrumentation that you have now made your application perform poorly because of it.
Sure.
Absolutely.
So let's do a quick recap.
Okay.
So at the outset, we talked about splitting up assemblies and their assemblies' relationship to projects. We also talked about sharing assemblies, be they through the portable class library for across platforms, or by leveraging WinMD components for sharing across languages. We also just did a deep dive into diagnostic capabilities and explored the value that the performance profiling toolkit can provide in the Ultimate and Professional editions.
That's right. One more reminder to all of our audience here is that the code that we're using and many of the examples that we aren't showing are all in a solution that we made available to you. It's at xaml.codeplex.com. You can find the Microsoft Virtual Academy link there, download the solution, follow along with us, or go through at your own pace to learn things that we may have skipped because we just don't have time today.
Great. And please remember, please vote.
Please remember, please vote. Absolutely right. All right, we're going to take a 10-minute break. We'll see everybody soon. Goodbye. Okay, and welcome back. This is Microsoft Virtual Academy. This is the Jumpstart for C#, exam 70384.
438.
438. Well, 359. 483.
It's been a long day, and it's just got longer. Let's start that again.
All right, here we go. Module 7. Module 7, specifically, we'll be talking about some interesting things, Darren. What will we be talking about?
We'll be talking about how to interact with the file system. And yes, we have touched on that very lightly earlier on, but this is going to be a much deeper dive into those areas.
Yeah.
And then we're also going to be talking about working with REST services.
Yeah, and just web services in general. I mean, it's a reality that service-based architecture is everywhere, and knowing how to interact with it properly, knowing what your options are, and
So did you just make up another term there?
Which
SBA instead of SOA?
What's SBA?
You said service-based?
Service-based architecture.
Jerry World.
Service-oriented architecture.
Awesome.
Based on services.
Okay, let's move in.
Okay, let's get started. All right, reading and writing. So we can read and write from the file system. We will just assert that at the beginning, but let me just ask, why in the world would we read or write from the file system? we have memory that we can interact with, and allow me.
It's basically persistence. I mean, ultimately, you've got memory, but that's volatile. That requires the system to be powered. That requires that you have available memory to store things. As you create more and more information, you may overflow your available memory space. So you need somewhere to be able to put that out. Many traditional systems would use the file system as an intermediate store for that data.
So it's a way of taking data out of memory and putting it down into the file system so that we could, there's a lot of good reasons for that. Not only to save memory, but also to be able to cross certain boundaries. Session boundary, so the next time you run your application, it's still there. Whatever you put in memory would be lost. I can also cross other boundary. I could say to a share, out to SharePoint, something like that, and it would go from user to user as well.
So you're crossing machine boundaries as well as user boundaries?
I could save out to a network share that way. Another reason I might use it is because the user is giving me something. I'm interacting with the user. Let's say Photoshop is an interesting example. Let's make it black and white. What do you want me to make black and white? They give me an image. Okay. So I need to be able to read from the file system in order to accept data that the user gives me. Another one might be because I need to sniff out the environment, and kind of figure out the configuration of that environment. Do they have this folder? Do they already have the file? Do they have a previous session XML file sitting there?
Okay, so it's almost like session persistence as well. So you can go in, say, have I already been here, read in those values, any default settings, and so on.
Yeah, and so like we would expect, the framework has given us a lot of value back. They have given us a lot of methods and ways to interact with the file system that are very simple. Reading and writing is just a breeze. It's almost as easy as your decrypt and encrypt.
Yeah, almost.
All you have to do is find, almost. It's almost. And and there are different things I can do. So I could open a file, and of course we saw that before where it locks that file, right, for reading. And I could open it and directly read it and close it again, right? So here we can see in the slide, write all text, read all text. That's an open-close, kind of an open-shut kind of operation. It happens, it opens it, it locks it, it reads it, it closes it, and it's unlocked. Right?
Awesome. So it kind of encapsulates an atomic operation.
It does. I mean, honestly, it saves you quite a bit of code that you could have done without it, but that's quite a mess. And so it's nice just to have these helper methods to do it for you. Another thing we can do, and this is special not just for file reading, but also talking to services, is to interact with a stream. You could have a very, very large file. So for example, the user could point me to a file that I need to read. It's an XML file, and it's a 5 gigabyte file. I can't go take that and put it up in memory and then start operating with it.
So another example of that would be something like Netflix, where you have a very large encoded video that's sitting out on a server. You're not downloading that entire movie before you play it. You're actually streaming it across chunk to chunk. That's
right. Streams are important because it allows me to operate on it in smaller portions. Of course, it has to be formatted in such a way that I can do that. But it prevents, for one, just waiting. A movie's a great example. You don't want to wait the 20 minutes or 10 minutes or whatever it would take to download the entire movie before you start to watch.
And this actually ties into a question that we had earlier on around unencrypting streams. If you think about movies are all encrypted. They have digital rights management embedded into them, so you cannot just download any old movie and play it. Anything that's streaming across from Netflix or whatever is encrypted, and so that's being encrypted on the fly, chunk by chunk, before it's being played.
Let's take a look at this simple sample. This simple sample is just being able to write all the content into a file. So here we can do something that is it's mine. That's all right. So
Barry thought that was Visual Studio.
Yeah, that's all right. It looked like it. So the first thing that's nice is that I can start fetching directories, right? I can ask for things and not have to figure them out. Asking what my current directory is certainly valuable, but others that we'll talk about in a minute. But it's nice to have that. Again, it's the framework giving you so much. The file then we'll create, you did this in your demo as well, right? Using the path object to be able to combine, it returns back a valid path. I mean, we could do the same thing by saying, directory plus slash plus file name, right? But you don't have to fiddle around with that, and you don't have to worry about you don't have to worry about invalid characters that may cause that path not to work. This fixes all of that for you.
And the other thing as well is that although we generally consider C# and the .NET environment running onside the Windows platform, it actually is multi-platform. There's Mono, which is an implementation of .NET. You have it. Silverlight runs on the Mac platform and so on.
Right.
And so things like path.combine and environment.newline, they will return the correct path structure for the system on which it's running.
Yeah, if you were to reflect into those and look at how they're implemented, they certainly are not just directory plus slash plus file name, right?
Exactly.
They're doing real work behind the scenes. Okay, let's look at just the write. The write's easy enough. The write is system.io.file is that namespace where it's all put for me. And then there's a static method I can call write all text. This is certainly the simplest way you could possibly write to a file. And so here it is. I pass the file. The file is just the path to it. And then I pass the content. And so in this case, it's how now, brown cow. How now, brown cow. And so I pass that as the content, and it's done. I don't have to worry about using a using statement wrapped to make sure I close it. This does it all for me. And to read it, there's a converse method that allows the same simple operation. This time it's returning the content of a file, and I can pass additional parameters to it to how I want it to handle if there is no file there.
Okay, so these show you've got system.io in front of those. If we had a using for system.io, you wouldn't need to do that, would you?
You're right. That would be the shortcut. I could put system.io up into a using, and from that point forward, it's just file dot.
Okay.
File really is the class that holds all those static methods.
Perfect.
Beautiful. All right, let's jump to the next one and talk about finding the file. So we alluded to the fact that you can get the current directory from the framework, but there's so much more. In Windows puts together its full operating system. So you have temp folders and you have directories that are for your desktop, for your favorites, and it just goes on and on and on. Each one of those you could hunt down by.
You.
What's that?
Much like you.
Much like me. Going on and on. Yeah, this is not. Let's see. Counting to 10. All right.
Okay.
But the reality is, being able to find those, you can find most of them by convention. I know that my fonts folder is in my Windows folder, so all I have to do is figure out where Windows is installed.
Yep.
That's a pain, right? And also kind of unreliable. And so all of those Windows special folders are presented back to the developers so that they can reference them directly and always rely on their value. And so if I want to ask where the Windows folder is, I can immediately get it back and not be worried that it's not right. I also have this thing called isolated storage. I think developers have underutilized something that's really special. And so every .NET application has the opportunity to use isolated storage. Isolated storage is both unique to your application and to the user, and basically it's a dedicated folder structure that you can store anything. Isolated storage, isolated to your app for that user. And what's great about isolated storage is it's kind of hidden away, so you don't have to be worried about the user coming in and tampering with your files. Doesn't mean they can't, but it means they shouldn't. And it also means that isolated storage is dedicated for you, so you don't have to worry about other applications getting into it. Probably the best part, there is sort of a boundary around it so other apps can't tamper with it, even though the user can come in and kind of
So it's kind of part of the sandbox in which your application runs.
Yeah, it really is. It really is. It's in the profile, under the profile folder, and it's great because it allows you to kind of have your own temp folder or temporary folder structure so that you can throw files in or whatever it is. Anyway, so I can find out where all of the special ones for Windows are. I can find out where my application is. I can even find the isolated storage folders that are for me, and then I can hand code anything I want. This is special, of course, for development that's not Windows 8 development, where there is a caveat. You can't just go anywhere in Windows 8 development. The sandbox has a thicker wall, so to speak, and you can't just go out and do anything.
It's very similar on the phone as well.
Very similar on the phone. Very, very similar on the phone.
Yep.
In fact, it may have the ultimate of all the walls, to be honest.
Exactly.
Having said that, a desktop developer can just say C:// you just go to it, right? And there is no intermediary broker that says says you can't do this because of a
Other
type
than
of policy.
NTFS file system security.
That's right. Just like writing to a performance pointer requires certain security, and you can't overcome that with code. At the same time, certain folders may have security. You can't overcome that with code either. You have to have the permission.
Yeah, you can't iterate through your Windows installation and delete every file.
Right.
Not unless you've got a very big hammer.
You got that right. All right. So let's take a look just at some of the implementation, just generally. The special folders, this is just a touch. I mean, there are probably 25 special folders inside Windows. Here's an easy way for me to go get the path to my documents, to common application data, which is great. That's a hidden folder that applications can store their data in one place. And that's really a great, another underutilized piece of Windows, without a doubt. Where I can go directly to program files. This is where I would find your application and do some mess to it. And find the desktop. You just go on from there. There's a whole list of them. How I could get the application folder. Often that is important. You may have embedded a file or some sort of data, some sort of resource that you want to access when your application is running, and it came along, it kind of tagged along during installation. And so the current directory is really valuable and a difficult thing just to figure out if it wasn't given to you. That's for sure.
For sure.
And here's the way we would get to isolated storage. And isolated storage has a scope about it. And anyway, we're not going to talk too much about isolated storage, except for to say everybody should use it more. No doubt about it.
Absolutely.
And then manually, this is how we just go grab it. I could go instantiate a new directory info. And directory info is a special class that we would use inside System I/O that would give us back the size. It would allow us to iterate through it, when it was created, when it was modified last. It's a great way to get metadata for a directory. No doubt about it. But then there's more to it, right? I don't want to just write to a file. I don't want to just read a file. There's more things I need to do. I might need to move a file or rename a file. Of course, rename and move are really the same operation, right? They're just wrapped together, and we treat them differently, but they're exactly the same, right? When I move a file, I'm actually renaming it. When I rename a file, I'm actually moving it. I guess really they're always moving. Rename is just a cutesy
It's
wrapper.
just basically how the Explorer actually shows you the file at the end of the day. If you move it, you're actually changing it to another node in the file structure, whereas if you're renaming it, you actually remove it and then put it back in the same place.
Yeah, that's right.
Different name.
Just like directories have directory info, files also have file info, and so that's where I can also interact with, whether or not it has an archive bit, whether or not it has a hidden bit, and go on from
whether
there.
it's encrypted,
and whether or not it is encrypted. Yeah, I mean, no doubt, if we were to look at the implementation of
almost
encrypt,
as if this all hangs together.
Yeah, these are very related. What if these teams talk?
Could well happen.
You know they do. All right, let's take a look at the implementation itself. So here's a nice iteration of all the files in a directory. So I get dir, that's just the path to wherever the directory is. I can use system.io.directory.get files, and just like you said, I could use a using that would make it a little easier syntax, so I don't have to put the system.io. And then I can just iterate through those. And in this case, I can use the path object again, this time not to combine, but to correctly extract the file name. Boy, how valuable that is. And instead of, what would you do? You'd have to find the last slash, and then after that, and it's just a pain, right? All that logic is wrapped up inside path. Here's the rename operation, right? And so I can say system.io.file.move, and I give the before name and the after name, and now it's done. Pretty nice.
Yep.
And then we were talking about file info. In this case, I'm getting the length, in this case, or the size of the file. It comes back as bytes, so I just go quick divide by 1,000. It tells me how many kilobytes there are.
That's awesome. And so you could see how you could easily build utilities that kind of measure disk space usage through these kind of things. You could crawl through all your files and say which are the big files that are occupying my file system and so on.
Yeah, you could write your own file explorer.
Yep.
I mean, anything that Windows can do, you can do.
Absolutely.
That's not totally true, but certainly a majority of the things that Windows can do, you can do against the file system too. There's a lot at your disposal and a lot of danger. I mean, you can shoot your foot, no doubt about it. You've got to be careful. All right. So that's the file system. Definitely a great way to persist data. Definitely a great way to read data, give utility to your application insofar as the local machine. But then there is the data that's outside, right? We need to pull data in. I can talk to a system directly as long as I'm not worried across my network, as long as I'm not worried about firewalls, as long as I'm not worried about things getting in the way or reliability, right? I mean, that's important.
Yeah, absolutely.
Right? We've done remoting for a long time, and that's basically what that is. And but now we have web services, and web services have kind of solved many of these problems, not just about reliability, but also access and firewall problems.
Yeah, well, it's addressed a number of the initial problems. You mentioned, we used to have arbitrary services that used to be running on different TCP ports, used to be running on different IP addresses, and we're not all sitting at home without a firewall. These days, we're all working inside, our corporate environments. We're connected through firewalls and so on and so forth. And so the industry has kind of settled on the idea of web protocols as being a great way to share information across all of those boundaries, because port 80 is generally open.
And it's turned out they were right. It is. It's a very good way to do it. All right. The benefit of web services is a lot like the benefit of object-oriented programming, to be honest. It allows us to take a lot of functionality that's on the server and encapsulate that away, right? And be able to expose these endpoints that often are just like methods, right? That you can call to, pass information to kind of change the variability of what's operated inside.
Facebook has a set of web-based APIs. We don't know how Facebook has implemented that, but we can interact with those APIs because they've encapsulated and packaged them up.
Squirrels, mostly squirrels. Right?
Wow, I'm glad I don't read your posts.
Yeah, it's crazy. Twitter is it's just hamsters jumping on keyboards.
Awesome.
It's the weirdest thing I've ever seen. If you could see, it's just a warehouse full of hamsters.
Yeah.
It's
everyone's
they can
now
scale.
starting to understand what I mean when I say awesome.
They can really scale. All right. What were we talking about? All right. One of the things it really does, and this is probably back to service-based architecture, service-oriented architecture, is that web services allow me to expose my system to anybody. You could actually be running on an iOS device. You could be running on an Android device. You could be running on a Windows Phone. I don't really care. I'm exposing this as a standard that allows you to consume it and allows me to expose it. That's a lot of value.
A lot of value because you're not building multiple implementations for these different platforms.
Earlier, we were talking about sharing libraries. I mean, there were some limitations around sharing libraries. This really breaks some of those boundaries. It also introduces loose coupling. How would you define loose coupling?
I would say it was the opposite of non-loose coupling.
That's the way I would
My muse deserted me there.
No, seriously, a loose coupled system, a tightly coupled system is brittle. I mean, it's not necessarily brittle, but it kind of is.
Well, you've really hard-coded dependencies. You've turned around and said, this will not work without that, and you've really put them hand in hand and turn around and make them so dependent that touching one will break another.
Yeah, that's exactly right. And I can, thanks to web services and loosely coupling, one of the things I can do is change, let's say it is all hamsters and we know it's really not. Let's say I want to change it to all monkeys jumping on the keyboard. Nobody really cares as long as what I'm exposing is a reliable interface. That is completely loosely coupled. I could bring in any animal I wanted to implement my service. And the reality is, as long as I'm a reliable interface to the user, or to the consumer, in this case it's an application, I'm loosely coupled. I can do whatever I need to. I can upgrade, I can downgrade, I can change implementation, change technologies, whatever it is I want to. And that's one of the best parts of web services being standard, is that I really could change technologies.
Okay.
Yeah.
Sounds awesome.
Yeah, it sounds like I've convinced you. All right, so let's talk for just a second about SOAP. I'm a big fan of SOAP, Darren. Big fan. All right, one of the benefits of SOAP, of course, is that it is also a standard, and probably the biggest benefit, it was one of the first really successful standards, allowing you to take payloads of structured data and put them into a format that you could pass around through standard web protocols, right? I could take it, it is just text in the end, looks like XML, I'm passing along, it ends up being just an envelope with some pieces inside it, I pass that around, I know how to serialize it, which means to turn it into a string or turn it into XML in this case, and I can serialize it on the server, hand it to a client, and because it's a standard, they can deserialize it into some sort of object that they can use.
And there's a lot of value to SOAP in terms of the way that it describes its own format. You have the WSDL web service description language that defines exactly how this web service is going to interact, exactly what format of data you're going to be passing to and from it, and so on. But there's some downsides to SOAP as well.
There are, no doubt the payload is heavy, right? The way that we actually serialize it is very voluminous, very big, no doubt about it.
Yeah.
And so as a result, there are other standards emerging that try and solve that problem because, as it turns out, I think Facebook's probably an excellent example here, so is Twitter. You might save, 400 bytes? Big deal. Until you have 400 million calls. Now suddenly those 400 bytes really matter. Yeah. But back to the defense of SOAP though. What's great about it is the full support inside Visual Studio. I can point to a SOAP service, and Visual Studio will build all the local client proxies for me so that I can interact with it without even having to think about it as a service. I almost talk as if it's a local class, and I can access its methods, access its properties, access its types.
Yeah.
Very easy to use. I think probably inside an enterprise, and again, it depends on performance and probably scale. Still an excellent option.
Especially if what you're really considering is not only the performance of the service itself, but also developer productivity. If you're building this in-house, you're not necessarily going to be exposing it out to a broader standards-based consumption. You can constrain within your enterprise exactly what devices are going to be interacting with it. Then why not use something where you have all the tooling, you have the ability, it's just going to generate everything for you.
Yeah, so here's a quick sample of the envelope and how it looks for a SOAP service. It's simple enough, right? And we're going to talk about some of the alternatives here. And probably a good alternative to start with, and the one that's next to the slide, is...
as if we planned it?
It is weird. It's how... All right, so is REST, right? REST stands for...
Representative State Transfer.
Golly. I'm so glad you're here. Never thought I'd say it. So
only for a moment.
At that moment. All right, so REST, without a doubt, is becoming the industry standard. This is the way to interact with a service. You don't
Some
have
might
to
say
have.
It is now.
It has already become the standard. Yeah. If you look at major services on the programmable web, it is resoundingly REST. It doesn't mean you don't still see SOAP. Often you'll see dual implementation. Some systems really do prefer one over the other. REST is really nice. Some of the features of REST, of course, that it doesn't require XML parsing, right? Because it really puts everything on the URL string in a lot of cases, and it doesn't require a large header that SOAP requires.
So that's kind of inbound you're talking about there, that you can specify on the URL. This is the resource that I'm after, and this is some additional information about it that I may want.
Yeah, and what's great about it is because it's in the URL, people can see it.
Or URI, I guess.
Or URI, people can see it. And one of the things about REST is it's human readable. And now, not always, but often it's human readable, which means I can look at the URI and kind of make out what I'm getting. It is my service / invoices / customer / whatever, right? And I can kind of go from there and kind of, it all kind of makes sense. It's not all bundled together in some cryptic format.
I remember what it was that we needed to do. Install the JSON viewer for Internet Explorer.
Yeah, remember that? What's it matter now? All right.
Indeed.
We only have Internet Explorer installed. Doesn't matter. All right, so one thing that's nice about REST, of course, it uses less bandwidth because you're passing so much less to it, right, in order to retrieve it. But typically what they return back is not this SOAP standard, not a serialized set of objects inside this envelope, but instead a simpler format, like just a simpler version of XML. That's very common to return, but probably most common isn't XML to be returned, but it's JSON to be returned. What does JSON stand for?
JavaScript Object Notation.
JavaScript Object Notation. Yeah, that's right. Well done. I was wrong again. All right, so let's see. So JSON is without a doubt one of the most prolific standards now. I mean, people just love it. It's easy to interact with.
Yeah.
Has some gotchas to it. It's not all golden, but at the same time, it really is great. Very, very light payload. Very light payload comparatively, right? That's the reason people love it. Let's look at just a basic implementation using a web client. The web client is a wrapper around the HTTP client, and the reason it exists is because it handles common operations for me. It's really nice. Anyway, so we're going to use the web client because it's the easiest. So we'll create our first URL, and that's going to localhost 1, 2. It's just going to a service, right, that returns JSON. Once I do that, it returns back as string. I don't get back JSON. I mean, it is JSON, but it's not a thing. It's just a string. And so then we can see in the middle block there where we start to deserialize it that we get a JavaScript serializer as part of the framework. There are a couple serializers to interact with JSON. And then we just call for it to deserialize. And when it does, instead of the string, it truly becomes objects at that time. And now instead of parsing the string, interacting with the string, or mess, now we really are dealing with objects in a type-safe way like we would expect in the first place.
That's awesome.
It's very nice. It really is. And then we can use those. That's all the bottom is really showing is how we use that.
So is that data an anonymous type there?
That data?
That data.
No.
Their data.
That data is not an anonymous type. And let me just make sure I know what you're talking about. You're talking about the data that's returned from deserializer, right?
Correct.
Yeah, absolutely not an anonymous type. In fact, this is a generic method, and so we're passing in that it's JSON sample.data. That is the strong type that it is going to be when it comes back.
So that's awesome because we can share that across our application. It's not just scoped to where we're interacting with it right now.
You're right, it's not. And even better than that, of course, this is not defensive programming either. It's not a guarantee I can deserialize that JSON. There could be a typo on the server, and I need to be a little more careful, but this is certainly the vanilla implementation.
Perfect.
I'm going to pull up Visual Studio for a second. I want to kind of show off in general.
Sounds good. I mean, one of the things we should point out in that the code snippet we just had there was you might have looked at the URI and been concerned that you see .svc partway through the URI. If I bring that back up whilst setting up. And that's just because we used a very simple implementation of a service. There are many other technologies in the Microsoft stack that we could have used, such as Web API, that would have got rid of that extension on that service and made it much more in line with what we're talking about with REST-based services.
That's right. So let's see. Trying to think of the best way to access that JSON that's coming back. I really don't know. I mean, without taking the time to actually go through the. It's okay. It doesn't matter. If you want to see what JSON looks like, it looks like a bunch of squirrely brackets and items in quotes. I mean, that's what it is. It certainly doesn't look like XML.
Or you could debug and actually have a look at it.
Oh, you know what? That's great. I'll do that. Thank you.
You're welcome.
Idiot. So let's see. I am in Visual Studio. Why wouldn't I just use Visual Studio to do it?
I have no idea.
Excellent idea. Absolutely excellent. All right. Right.
So let's show his Visual Studio.
Yeah, show mine, and I will actually let me. There we are. And let me copy the URL here. But let me first show how this URL. It really is an interesting way to interact with the service where I can say service slash, like you were showing before. It doesn't have to be SVC. That's because I'm using WCF. Like a slash, and then I can, from that point forward, start to pass logical pieces to it that hopefully make sense to me. If you look at the code implementation, what I'm actually expecting is slash JSON and then a number, and then we're going to get multiples of that number.
Awesome.
And so I'll just say slash JSON slash 5. Right? I'm going to copy it for a second, and when I run it, it will. Oh, that actually would be just fine. That would.
Now you need to save as. And
no, I'm good.
There we go.
All right. So this is JSON notation. This is easier than anything, and. What happened? What it's doing is, so this is the notation for an array, right? Brings it back as an array, and which is inside this type, what I'm actually getting back. In this case, it has two properties, one of multiples, which is of type array, and one of number, which is an integer whose return is 0 in this case. Interesting.
Interesting.
Yeah, all right. So that's just what it looks like. Let's look at how we might consume it, and I'll go into and I don't want to show the service, so I'm gonna close out the service here. Just know that there is a service. It's a REST service that returns multiples. I want to be able to interact with it and kind of show off how the serializer works. If I were so if I were to show you here, it would basically use that sample that we looked at in the slide. Again, I'm going to use web client, and the purpose of using web client is just because it wraps all the simplicity around it. So I'm going to go ahead and do like you said. I'm going to go ahead and put a breakpoint here. I want to make an interesting point about breakpoints. This is probably another one of those underutilized developer features, and that is I could have breakpoints everywhere. Right? Just like kind of like this, right? Just everywhere. And that becomes really burdensome. I'm constantly having to continue. But I might actually need a breakpoint there in a certain case. And so what I can do is I can create a conditional breakpoint.
So did you right click on that breakpoint there?
So I go to the breakpoint, which all I do is click in the margin to get that. I could hit F9 as well in order to make a breakpoint come and go. And yeah, so I right click a breakpoint. It gives me this special menu, the little context menu where I can select what the condition is. It's pretty powerful because when I go in there, all I have to do is create a small predicate that indicates when that breakpoint should fire. So, you know, if it has to be when value equals true. Now when value is true, or whatever value might be, right, that is going to return whatever the true or false is, the breakpoint will fire. And that allows me to have breakpoints in strategic places throughout my project that do actually fire and raise whenever I need them. It's really nice.
It is. I mean, another great scenario for that is when you have a loop. And you may have a problem that, you know, after 3,000 times running through the loop, you run into a problem. Nobody wants to sit there and hand debug through the first 2,999 iterations because that gets old fast. So instead, you would put a conditional breakpoint in there that would break once you hit that scenario.
Yeah, it's really great. It's just another little piece of developer candy that's kind of in Visual Studio. Excuse me. Okay, so I'm going to go ahead and debug this so we can kind of take a look. I will debug right here, though. Actually, let me debug one line up. It's nice we're using the async syntax. We'll talk about that a little bit later. We're certainly not going to skip over that, but that's the reason await is there. So let me set this to be the startup project and go ahead and debug it.
Just time.
Oh. Nice. All right. So it ran. Of course, you can see it's blank here, right? Everything's good to go. And I'm about to step into it. Now, before we do, I want to make sure you see the whole context of this application. That's the whole. There's very little code.
Yeah. We'll pause whilst everybody reads that.
All right. So there is a lot about to go down, but I want to kind of show that off. First of all, this is going to be showing off the JavaScript serializer. That's in the web script namespace, and you may or may not want to include that in your project. And we'll talk about that, and that's one of the reasons you may choose other serializers. Also, I'll dial on down to show that when I do receive back that JSON, what I want to do is I want to cast it into a type. And so this is for the JSON sample right here, and this is the type I'm going to cast it into. The deserializer understands that as long as all of the properties are named the same and all of the types are properly set, it knows how to go ahead and serialize it back into the objects that you want. And so take a look. Here I am in the first one. And we'll do 3 iterations of this. So I'll say F10, and as soon as I do, this is the JSON that was returned, right? There we are. Simple enough. And when I do, now I spin up the serializer, and it's with the serializer that I'll deserialize. At the same time, I might say, it's with the serializer that I would serialize it as well, right? It goes both ways, just like the encryption tools can encrypt and decrypt. All right, so now the serializer is ready. I've passed in the type that it's going to be deserialized to, and here's the string that it's going to receive. I'll say go, and as soon as I do, data goes from null now to a strong type, and it has all of the multiples already set the way you would want them to be. Pretty nice.
That's great.
Pretty nice. And now from
Saves
this point,
you a lot of code manipulating that string.
Yeah, so now from this, yeah, no doubt, and errors and everything else. I mean, regular expressions are powerful, but that kind of string manipulation is brutal. All right, great. So now I can, from that point forward, I use it just as if it's a regular object. Very, very nice. All right, so now let's look at the second scenario. The second scenario is using data contract JSON serializer. The main reason you might want to use this is because it's in a namespace that you are willing to include in your project. There are times when you don't want web.script in your project. That's not unreasonable. And you might also find the the use of data contracts very valuable, so that if you have if you do have a property and it just doesn't match the strong type or the defined type, then you can use data contracts to decorate. We were talking about decoration. You can decorate your classes, and so let me kind of dive down to show that.
The key powers of WCF is the ability to automatically generate different data types of endpoint. And so by using this data contract and data member, you can have a common type that is then exposed out as a SOAP endpoint, as a REST-based endpoint, and so on and so forth. And so you've got that common nomenclature that you can use across them.
That's right. And so data contracts are special. Right? A data contract is basically saying, I guarantee that it will look like this. Right? That's very nice. It's a lot like an interface when we move back to strong types. And so if I were to go down and show you the layout for that, so see how nice and simple it is for JSON, right? But at the same time, there's a certain level of brittleness there that you never know if everything's going to be laid out, if number is going to always be 0, things like that. And so here's the same thing, but using data contract. And here I get to decorate it with the fact, first of all, that the class is the data contract. And here I've made them all match, but I don't really have to. I can go in here and set specifically that the name is different, that the name is specifically Bob, even though I'm putting it into a number property. That allows me to have my strong type look the way I want it to, regardless of how it might actually be.
So what it looks like is that the data contract serializer is actually using reflection to go and find these attributes that are placed on these various members, and then it can look up and see those attribute properties such as name, and it can actually map a different incoming name to this property.
That's right. How would it ever know about these attributes if it didn't reflect into it? That's exactly right. Under the scenes, so much of the framework does use attributes. I mean, does use reflection, absolutely. That's right. And attributes too, but certainly reflection was what I was going to say. All right, great. So here's a little bit different. I'm using a data contract this time, so I have to set up my receiving type with data contract, and set up all the different members as they are, make sure the types are correct as well. I can also manipulate types as they come in as well. There's a lot of power that I can really go through. All right, let me go back to the scenario and kind of walk into it. Just as before, I'm going to use web client to go get that JSON. Here's the resulting JSON. This time it's a stream, and I can say to the serializer, which is expecting a stream, I can say, it's at instantiation that I tell it what it's going to be deserializing in this case, right? Just slightly different syntax. So I'm going to pass in, the type is going to be data contract.data. That was the one.
Wouldn't it be great if that was a generic?
Yeah. So it's not. But hint.
But it's one of those things that has been around for quite some time.
Yeah, exactly. I'm actually a little bit surprised that it's not. In fact, now I'm curious. No, it's not. All right. Okay, so here we are. I have the serializer. The serializer now understands what it's about to deserialize.
Before you jump in, the service is actually part of the solution that you've downloaded, so you can actually run that at the bottom of the solution and interact with it just exactly as we're showing right now.
Yeah, it's called Simple REST Service, and it's just sitting there, waiting to be run. Right here. That's right. If it's not working, it might be just because you need to spin it up. So just right-click the service, and you can say open in web browser somewhere. Oh, it doesn't show up while you're debugging, but you can select open in web browser, which would show up for you if you're not debugging. That will cause the service to spin up in case it's not. Yeah.
Perfect.
Yeah, and okay, so back to the serializer. So now the serializer is ready. I'm ready to deserialize my JSON into an actual object. That's in the read object method. Read object then comes back as an object, not good enough for me, so I'll do a quick as and make it specific what it comes back to.
And because you're constraining this environment, that's perfectly safe for you. But obviously, if you were building this in the real world, you want to put some guards around that.
I would indeed. Not only would I want to make sure that this didn't return an exception, but I'd want to make sure it didn't return a null.
Perfect.
Yeah, well done. All right, so this is the second JSON serializer, and really the only other JSON serializer in the framework. And it depends on the namespaces that you're in. If you are writing a web service, odds are you will already have web.service, web.script in your already referenced. But if you don't and you're writing a client application, you might be using the data contract serializer.
And of course,
instead.
We do have the client profile for .NET that doesn't include some of these server-side assemblies. different variations of the .NET Framework install.
Yeah, that's right. Now that would be only for .NET 4.5. .NET 5. What current version of .NET are we at?
It's 4.5 right now.
Yeah, so that would be for .NET 4. 4.5 we got rid of the client, but it is a big source of confusion for developers, especially back on 4, where they suddenly are using they have a reference by default as the client, and they're wondering why things aren't working the way that they're supposed to, and it's because they have the abbreviated client framework. Yeah, exactly. That's one of the reasons we got rid of it as well. And some refactoring, some rework of the existing framework actually saved so much space that really the gain was quite trivial. In size. That was the reason client was originally created. Okay, now once again, data is strongly typed. I get to see everything like I would want to. That's nice.
Yep.
Here we go again. This is exactly the same as before. And then I'll come down, and now we'll do it. What if it returned XML? So if we were to look at the service is nice. It's really simple. All we have to do is add this web get into our methods. And as soon as we do, that says we know that we're going to be using REST to access it.
So that's another attribute that's being applied to it, so that the WCF environment now knows to start changing how this is being dealt with.
Yeah, that's exactly right, and it's actually a very neat way of notating something without having to go in and spin things up or put them in new files. Or yeah, that's a great way to be able to change the behavior of something and still keep the same syntax that you had before, because I didn't have to then change anything that I did inside the method. So in this case, if my URL says /JSON, I know that I'll be returning JSON. And I partly know that because even in that same web-get, I say what the format's going to be that's returned, and it does it all for me. I don't have to worry about the serializer behind the scenes. I know that it does it. And then at this one down here is exactly the same, except for it has a different name, of course. And it returns XML. But from the user's point of view, they don't have to know the name of this method. They just know, because REST is very easy to use, right? We wouldn't try and expose everything for encapsulation's sake. We can say /XML/ and then it's whatever the name of the parameter is. Of course, we could have multiple parameters here as well. It's very nice. All right. This is the service, and this time we'll be calling XML to return it, and we'll be using the XML serializer. So this is the third and final scenario, so that we can kind of look at what's returned. All right. So here we go. Same as before, I'm using the web client. And now I'll be returning, once again, a string. This is the XML. In fact, let me close this. This is another neat thing. I can sniff what the value of variables are while I'm debugging, but I can also view them different ways. I could see it as text, as I just did, but I know this is XML, so I could use a visualizer so I can see the data the way I need to see it. Very, very nice. This is looking at it as XML. You can see what it's coming to me as, and what the serializer is going to receive. So when it deserializes it. All right, so here we go, and here's the. And so you can see there's a little bit more because I use a memory stream. Oh God. No, that's 8.
That's what I've been telling you at the time.
All right. Nonetheless, just as before, it takes in the data and returns strongly typed. So now, regardless of how you want to do it, JSON, XML, SOAP, we can use strong types on our client and interact with any of the standards that the services may have implemented. All right. Transitioning on to probably one of the most important topics, and
that will incorporate into the next module. That
we'll have to split because we just can't do this one too much injustice, right?
Yeah.
And it's the introduction of async and await, the core keywords to allow us to do asynchronous programming in .NET. We didn't need them to do asynchronous programming before, but let's look at it at least quickly.
We'll do it in the next module.
Well, let's look at least the fact that there are in async. Let's see. Here we are. Asynchronous programming. And this will give some homework over the next break.
10 minutes.
Yeah, they can kind of take a look. And asynchronous programming, generally speaking, is the ability to release, right? If you do things synchronously, it means everybody waits for you to finish. But that's not what you want to happen. What you want is for you to be able to do something and nobody has to wait for you. And then once the operation is completed, you can return. That's really the fundamental differences between synchronous and asynchronous. And we would of course, say it does maximize all the resources that you have. If you don't do it asynchronously, your resources become very constrained. And so asynchronous allows you to spread things out. You can also use, of course, parallel libraries for the same sort of tasks. It also frees up the system. So from a UI point of view, especially a UI point of view, you can do some long-running task and not have to wait for it and not freeze up your application at the same time. That's sort of that's a very good user experience as well. You don't want to make it so that when they click the button, the 5 seconds that it takes for the operation to complete, the button is frozen in place and you don't see any kind of operation. The user can shake your application and all it gets is the not responding dialog. Asynchronous development allows us to have long-running applications not affect our apps. So that's the beginning of it. Of course, we're going to implement that with the await and async. You can go to msdn.com and search for await and async, do a little pre-reading, and we'll hit those at the beginning of the next session. And for now, we'll take a quick break. This is going to be a 10-minute break, and we'll go back to our final module. That'll be Module 8, and we'll see you soon. Over there. Okay, so here we go. Start from the top there, Frank.
Yeah.
All right. Welcome back. This is Microsoft Virtual Academy Module 8. We're ready to go with Jumpstart for C#. We left off where we left our hero. He was talking about async and await. That is for those are the new keywords introduced to C# to handle asynchronous development. And we were. It's interesting. Asynchronous development kind of is a native piece for developers of Silverlight, wouldn't you say?
Yes. So basically, the Silverlight environment really constrained developers for the very first time to have to implement interactions with services as an asynchronous operation.
You say for the very first time. It was there, but it was just something that developers didn't get into.
But they weren't forced to. Yeah. And that was it. Silverlight said the only way you're going to interact with a service is via an asynchronous operation. And that, as I mentioned earlier, is based upon the Netscape plugin standard that states that no browser plugin can actually hog the UI process for a browser.
The winner is truly the user, right?
Exactly.
They're interacting with your application because it's asynchronous now. We don't have to worry about the application freezing whenever you're doing some sort of long-running process. And so we all have long-running processes. Sometimes it's calling a service. Sometimes it's just crunching numbers. It could be just about anything. Often developers, in the past, would just kind of bite the bullet and they would just let it run. And you would see applications with the not responding at the top because they hadn't set that off and allowed and freed up the UI to continue. And so now we have asynchronous more and more being pushed at us. Of course, Silverlight, as you said, ushered it in to really kind of force the hand. And Windows 8 has done the same thing with the Windows runtime. The Windows runtime, very aggressive into asynchronous development as well. How can we make that simple from a C# point of view? That's why we see the introduction of await. That's why we see the introduction of async. They are certainly friends with each other. You wouldn't see them apart. Async is the keyword we would mark a method to say, inside this method, we're going to do some sort of asynchronous operation.
It's eligible for this pattern.
Yeah.
That by putting that on there, we're letting the compiler know you can expect there to be an await keyword, and we can expect you to be interacting with tasks within here. And it's kind of a hint for the compiler. Okay, now do the legwork.
The actual asynchronous work occurs with await. Async is the hint, right, that it's going to be coming. It doesn't actually have to, right? You'll get a compiler warning, like, what are you doing? But at the same time, once it's in there, there's a wait that does the asynchronous work for us.
And you can have more than one await.
You certainly can. You can start stacking them as much as you want to. Where we would have built this scaffolding before without await and async, we would have had so much code and so much. It's not bloat. It's just what you would have to do, and you'd have to keep a very clear mind to be able to trace the flow and to, if this has occurred yet, if it hasn't occurred yet. Doing things in series, it would be very difficult. Actually, how you could have await.
Exactly.
Very
you have
difficult.
a lot of breakpoints all over your application based upon where the callbacks were being invoked.
Yeah, absolutely you would. Absolutely you would. And so so, in fact, did you find this slide?
I did.
Okay, so let's take a look at this slide because this really shows the, not the old-fashioned, but the only option we had prior to await. And so this is a class that gets HTML using the web client. We've seen this sample before when we were getting JSON. And so you can see what happens is two things. In the get HTML method, it is spinning up the client, but before it calls to download it, it first handles the completed event. This is basically saying, go download it. I don't know how long you're going to take, but when you do when you raise this event, I'm going to handle the completion. And so when we do handle the completion, we raise our own event called completed. Now, I call get. If I'm the outside consumer, I'll call get HTML, and of course I'm going to also subscribe to completed. And who knows when completed will take? I mean, it could take a minute, 2 minutes, 3 minutes. Who knows what it will take?
It depends how big the file is you're downloading.
Right, and it depends on what kind of processing I'm going to do to it as well.
What
this
happens
is very simple.
Is get HTML will return immediately. And so we cannot assume that when get HTML completes that we actually have that data.
That's why get HTML returns void. There's nothing to give me, and it's not until I have completed that I actually get it back. That's very powerful, very useful. And it was our only option. It seems simple.
It seems simple now because we've only got one asynchronous operation here.
Yeah.
But say we needed to turn around and say, okay, go away and get the movie title information. Okay, I've got the movie title information.
Right.
Now go away and get something else related to this movie,
which
again is going to be an asynchronous
and it's
operation.
ratings now.
Yeah, and then go away and get this. We'll have 3, 4, 5, 6 nested callbacks, all of which we have to create all the scaffolding, we have to create all of these environments. Then we also have a challenge. What if we want to kick off a couple of those at the same time?
Right. But not more than 3 at a time, not more than 2 at a time. Now it's a real pain.
You've got to do all of that management yourself.
Yeah, and so where we have, just for one asynchronous operation, we have to have all of that code. Now you start having 2, 3, and you need to have them in a certain series. It's very, very difficult. All right, now let's see what it would look like with the async keyword. So here's the same method, but and already you can see there's a lot less scaffolding. We don't need a handler. We don't have an event that we raise. And even better, the event itself returns the result. Very, very powerful. Of course, we didn't have to even have return HTML. We could have done this in 2 lines. Shoot, we could have done it in 1.
Yes.
We could have minified our own code, but what's the advantage of that? This method is different, and partly the reason it's different is because it is decorated with async, that warning or that hint to the compiler that we're going to do some asynchronous operation.
But wait a second. It looks like that method is returning a task of type string.
Yeah, it's the task object that enables all of this for us. So we return back a task, and the reality is that's the reason we can release. We have already returned whatever it is we need to return, but it's incomplete. And so now I've returned whatever it is I need to. It's of type string, which means the resulting value is going to be string. But now the consuming client is going to wait for the task to be complete. So now the task can be completed, again, with an await keyword as well on their side. So now instead of having the complete, because remember we had the completed event here, and then we would have had a completed handler in the client in the previous demo. So now we don't have to have that. We would have a completed, we would have an await here, and then we would have await in the client. And we've dropped it down from 7 lines, 8 lines, to just 2 or 3 lines. And even more importantly, we can wrap it in a try, which you cannot do in asynchronous program in the standard way, right? Because you wrap it in a try, but you're outside of scope when your event is raised.
Absolutely.
That does not happen when you're inside await and async patterns.
So this is obviously a very brief and speedy introduction to something that is a very powerful capability, but we would have been remiss not to at least show you some of this code.
Yeah.
We clearly don't have time to dive much deeper into this, which is very unfortunate.
And it really is too bad because it is very important. And I think developers are hesitant to approach it because it feels complex, but it's not complex, right?
Yeah.
Let's go into other common tasks. We know that asynchronous now is going to become a common task. Another one is just talking to data sources, like a database.
Accessing a database.
So a database, I think most of us are going to know what a database is, but just for the fun of it, Darren, what is a database?
So, database is, at its simplest, it's merely a data store.
Yeah.
Now, it's a system that provides a way to interact with data. It allows us to store data in a more structured way than we would typically do. Say, we talked about writing it out to a file system.
Yeah.
You know, a file is effectively just a bunch of binary.
It's a blob
that you throw data into.
That's right.
You know, any structure there, you interpret and you place based upon how you interact with it. It's not defined within the file itself. Within a database, you have the ability to create tables, you have the ability to create columns within those tables, you can apply types to that, and so it's very rich.
What's great about structured data is that it's reliable. You know how it's going to be laid out, you know how to get it, and because it's reliable, it also can be optimized. And so you were saying it gives us a way to query it, and allows those queries to be very performant because it knows about the data, how it's going to be used, and they can also apply indexes and other strategies to make it even faster.
Basically shortcuts to jump to the correct place in the file.
Yeah, you're absolutely right. Now, databases themselves, I'm at a disadvantage.
Oh, you have a problem.
After you.
Okay, do you want to pop up the slide on the screen?
There we are.
So, databases, what databases can we use?
Well, there's a lot of them. Only Microsoft databases. That's not true, of course,
That's not
right?
True.
No. The databases that we can talk to, of course, are ones out in the cloud. You know, we could have a database that isn't here for us locally, such as Windows Azure SQL database, where we could talk and store that data so they could be shared across clients, and so that we don't have to worry about backup performance and things like that. Very nice. A local network, something inside our environment. Also a local machine, so I could have SQL Server installed on this device, and I could interact with it just as I would if it was on my on my local network. And then we also have local DB, and of course local DB is new to SQL Server, slightly new to SQL Server. It allows me to, I will leverage SQL Server Express, but it allows me to deploy that database with almost no setup inside my application. And then very powerful and very cool, SQL CE, that's the compact edition of SQL, that basically allows me to ship all the runtime necessary to host it, to query it, to make it performant. SQL CE is a neat way to have a very easy data store inside a CSharp app. Perfect. Or a VB app, frankly. The way that you would talk to a database varies, right? You might talk to a database manually, and there, of course, all of the namespaces are there. You can do that the way that you want to. You can talk directly to it, very, very raw. You don't see that as much as you used to.
Just really using ADO.NET.
ADO.NET is that namespace that gives you everything, that data reader, the database connection, all those objects that you need. But we can wrap those as well to not just simplify and increase productivity, but sometimes to abstract it away as well. And so those are usually object relationship models, ORMs, and ORMs are very popular. You see ORMs all the time. The likelihood of somebody doing a raw call to a database is not unheard of, certainly not. It's very performant, and that's the reason you might choose it. But at the same time, a typical application is going to include some sort of ORM. Microsoft makes one. It's the Entity Framework, but there are certainly others out there like
Hibernate,
and Dapper is there. Dapper is very performant. And yeah, you're right, CSLA. One of the benefits of using an ORM is that it does allow you to do conceptual modeling of the data, and basically it's a bridge between the way you want your classes, the way you want your objects to look in code, and the way they really are stored in the database may not be one-to-one. So you can do this kind of mapping so that everything goes the way that you want it to. And then the ORM allows you not only to read, but also to write, so that mapping can go both directions. Very powerful.
You may find that there's a disconnect, an impedance perhaps, between the way that your application will view the data and the way that the data should be stored in a relational model for optimization purposes. And so by having this intermediate layer that allows us to take our concept of how the object should be modeled within our application domain and map them to a third normal form that may be expressed within the database itself. Now, clearly what we're focusing on in this section is really talking about relational databases. There are a whole class of other databases out there, such as Mongo and those kind of things, that are the NoSQL type of databases and those that are really document-oriented. There are many frameworks available to leverage those inside the .NET space, but we won't be touching on those today.
Those are sort of opened up to us by the provider pattern, a very cool pattern that basically says it's a database, I don't know what a type, and then you can start creating the provider that's that in-between section that says, yes, it's a database, this is a SQL Server database, and this is how you're going to access it. I interact with just that interface, and all the direct conversation with SQL Server is kind of abstracted away from me. Encapsulated, no doubt about it.
Sure. Why don't you show us some interaction?
Yeah, this is great. Let's create an application here. I've got my console application running here, or loaded. Doesn't have anything. If I were to open up a program, it's empty, right? I am going to, let's do some, I want to create a database. So the easiest, without a doubt, is to ship a database with it, nothing to install. I don't have to worry about the service, the version, or anything like that. So that's going to be SQL CE. So what I can say is add new item, and from here I can say data. And so I'll filter data to see all the different options that I have, and I'm going to select local database. Local database is an SDF file. SDF is just the extension for SQL CE. And so I will select that, and as soon as I do, it adds the file you can see over here, database1.sdf, to my project. And what's great is from this point forward, it is part of the project, ships with it, it's all there, all of the DLLs I needed in order to make it work become referenced inside this project, and they all go together. It makes it very reliable. Now, to be fair, SDFs or SQL CE databases are not the same as SQL Server, right? There are things it cannot do. There are sizes it can't take, right? And I mean, it's not the same
concurrent access,
robust, right? It's not the same robust as a real full-fledged RDBMS that's installed somewhere. But it really gets the job done on application data.
Absolutely, yeah, and also other things that SQL Server can maintain is obviously spreading that file across multiple spindles and so on and so forth to really give you the performance to interact with large volumes of data.
There's only so much you can do to really improve performance of SQL CE. And having said all that, let's put it together. So the first dialog that comes up, because I added it, is the ability to add an entity data model. This is part of the entity framework. That's what the ORM that Microsoft has put together. And so I'll go ahead and select it. And when I do, it says, okay, you're going to create an ORM model. That's great. What is that model going to be based on? It's going to be based on, in this case, the database that we just added. And so here's my SDF that I can select. And as soon as I do, it's going to ask which tables inside that database. Now, before I can do this, I have to go in and create some tables, because this database is empty. If I go through and create a data model, it's totally insufficient, right? I mean, we don't want to interact with an empty database. So I'm going to cancel out of this, both. And I'm going to right-click the. Oh no, I'm not. And then I'm going to go to View Server Explorer, so that I can interact with it. Here's my database right here. I can say refresh, and when it does, you can see the little green that shows that now it's connected to it. It's pretty nice, the little sniffing to find out that it's in my project. And I can look at the tables. There are no tables, this is what we'd expect. And look what it doesn't have. It doesn't have views, doesn't have stored procedures, doesn't have so much. It does have indexes and basic query syntax. And so I'll right-click and I'll say I want a new table, and this is going to be for, let's say, products. And now I've got a products table, and I want to create a few columns in it. I'll just create real quickly an ID. It's going to be, we'll make it a number, and a number. Bam, bam. Oh man, no. There we go. And then we'll give it a name. I don't want to make it too complex, because you'll create the database that you want anyway. I mean, let's just be honest. I'll set this to be the primary key. I'll say a primary key has to be unique, and life is happy. There we go. That's a very simple database table.
It's about as simple as you can get.
It really is. You can see it's here in the tree. If I expand it out, I can see where the columns are. I can right-click it, and I can say open the or show table data. This gives me the opportunity to say, I can have gloves, gloves. And 2, I could say scarves. 3, I could say coats. Give me another one. 4, I could say
lion.
Lion. Obviously, there's a pattern.
We've missed our animal meme here.
There's a pattern here.
We have missed our animals here.
Lion fur. The hat.
Oh dear.
Oh boy, that is.
Yeah, now let's move on.
Certainly sounds awesome. All right, and 5, the last maybe boots. All right, there you go. So these are the products that you may have, and whatever it is you might have. Okay, so I'll close this out. It's updated the database for me. It's still over here. This was just my pane to interact with it. Now I can create an entity model. So I'll right-click my project and say Add New Item. And when I do, I can ask to add an entity model. This is me just repeating the same operation that it was going to give me in the first place. The there we are, got it. ADO.NET Entity Data Model. I'll say go, and when it does, just like before, it's asked me from what. I'm going to say this is from the database 1. I'll say next. When it does, now it's going to list the tables and say, which ones do you want to include in this model?
I think we should include products.
I think if we don't include products, this is not going to be a fun demo. Right, exactly. I'll go ahead and say finish. And it's using T4 templates. T4 templates are very powerful. Earlier we were talking about code generation. That's how you do code generation inside .NET. It's with T4 templates. They're all done behind the scenes for Entity Framework, but you could create your own to build your own.
Are you speaking so fast now? Just squeeze this in?
Yeah, I don't want to miss it. I do not want to miss it. All right. So here's the model. This is the beginning, right? I could make different relationships and define them. And this is the code model, not the actual database itself. And so I'll close out this model just because I don't want to make any changes to it. Like so. It'll ask me if it wants to run the code generation behind the scenes. And now it's done. What I really mean is now Entity Framework has all the information that it needs, both to reach out to my database and to query it. And so let's do that. So here we are. I will. So here's my console application. If I were to run it right now, black screen. So let's give a little functionality to it.
Sounds like a good plan.
All right. The first thing we need to do is recognize that the Entity Framework uses a context in order to talk to the database. So you create a context, and from that point forward, the context sort of handles all of your connection operations. So I would say var context equals new data1 entities, right? That's what we called it. I would have picked a much better name if I were
revisiting the demo?
If I weren't clicking so quickly. What it also allows me to do now is now I can interact with the products, not just as if it's a table, but as if it's a class or an enumerable of products, which is really valuable. So now I've done the context. I don't have to say context.open or anything like that. The rest is handled for me. So now let's go get all of those products. All right, so now this context.products will return the enumerable of the products.
Wow.
And I can do some fancy stuff here. I can do some really fancy stuff here. We were talking about predicates before, and I can actually inject a predicate right here using a lambda statement. And we had talked briefly about lambdas in the second module, and how lambdas allow us to define a predicate with shorthand. And so lambdas are that shorthand. So let's go ahead and do that. I'm going to add a where clause, which is what you would really probably want to do.
So what is the where clause?
The where clause, just like in T-SQL, allows me to interact. So Entity Framework will take a lambda where and translate that into T-SQL for me, allowing me to interact with the database as if I'm typing SQL to it, but it handles all that translation. What's beautiful about it is it also gives me compile time checking. So because I treat these as strong types, not as just strings or objects that come back, but I treat them as strong types, I can also have compile time validation on my where clause, which of course you can't get that in SQL Server.
Yep.
That's an interesting benefit that you can get. But don't be misled, that benefit does have a cost to it, right?
Yes.
Because of that, we have to use an ORM to do it. There is going to be a performance impact, but sometimes that performance impact is negligible, and sometimes it's acceptable because you want to add the productivity of being able to leverage it.
And the other thing, where is obviously an extension method that forms part of link.
It totally does, yeah. And so we'll talk about link here in just a second, where link has a series of extension methods that give you all sorts of manipulations against enumerables like products.
Sounds good.
All right, so now just to do it for fun, let's create a for each loop and loop through all the products and output their name. So now it's going to be item.name. That's pretty nice. It's kind of cool that I could say dot, and of course I call it item here because it's defaulted, but I could just change that quickly to product. Did you see that change down here as well?
Yeah, that was awesome.
Symbolic renaming inside Visual
Studio. That looks
Studio.
like refactoring to me.
Yeah, only the compiler can do it for us. I mean, it truly is a magical thing. All right. It is certainly refactoring, but that's not just a rename. It's not a find and replace. That is symbolic renaming, finding objects that reference it. All right, so now I can say object dot or product dot, and when I do, I can see that ID column that we called, and I can see name. Of course, I can see those other methods because just like everything else, this inherits from object ultimately. Fascinating. All right, so now I can go ahead and select name. Now when I write it out, hopefully this will write out a list of all the products in the database.
Yeah, it would be disappointing if it doesn't.
In fact, it makes me cautious to do it. It would be so disappointing if it doesn't. I'll go ahead and do it because I'm pretty confident. Oh, look at that. Look at that hat. Looks nice.
It does.
Doesn't it?
It does.
Lion fur. It's like a dodo bird omelet there. That's nice. All right, so the Yeah, so here we are. This is a simple operation of read, but let's look at it for fun, and let's say only let's see, good. Only products that have the letter O in them will be returned. So now I can add that where
That's
predicate.
a real world scenario.
Yeah,
I do that every time.
It really is. I would say, price is greater than or something like that, but we've only got 2 columns. So I'll put it on a second line just so we don't have to look at it and implement the lambda. This is the lambda right here.
Okay.
Interesting little syntax for sure. Certainly, we were talking before about takes a lifetime to master. Lambdas don't take a lifetime, but it does take more than about the 3 minutes we will give it credence right now. So now I can say X, of course, is going to represent an individual product.
So that is like an argument that's being passed into the lambda. Yes, it is. Move on.
Yes, sorry. Right, where the lambda represents the entire expression tree, and this is the argument portion, yes.
Exactly.
I was typing at the time, I apologize. Yes, earlier I was just being contrarian. This time I was truly baffled. All right. So now it's exactly the same as before, but this time I do have this quick little where I say the name has to contain a lowercase o. Right? Of course, like you pointed out before, I could make it ignore the case if I wanted to. And so if I run it again, now what we don't see are scarves. We don't see scarves. No O in scarf.
No O in scarf.
As far as I know. And there might be in other languages, but that's not where we're headed. Okay, so now we've added an interesting little predicate, but what's allowed us to do, you cannot talk to SQL or SQL CE with a predicate like this. You have to talk with T-SQL. This really does output the T-SQL necessary to interact with it. It's nice how it's abstracted away so that I don't have to do that. In fact, I could write an entire database-oriented application and never learn T-SQL because I can allow the ORM to do that for me. That is a common scenario. You find developers who just don't know how to interact with the database. It's sort of sad in a lot of ways, more than it is a compliment. It is interesting that the ORM enables that, but I think the goal is so you can have this sort of checking at compile time.
Absolutely. And part of the features that enables this to happen is the fact that LINQ, as we mentioned before, the compiler will either compile it straight into code that is executed, or will build it into an expression tree. In this situation, because we're interacting with the database, it's actually building an expression tree that the SQL Server provider for Entity Framework then evaluates that expression tree and translates it into SQL for us.
It does, and it's pretty neat. And so if I had there's a lot of power there. There's a lot of controversy here as well, because the SQL that it does create sometimes is not optimal. And if you have a lot of data, if you're scaling very, very large, you're going to have to address that. You're going to have to look into how you can change performance. Sometimes it's as simple as calling a stored procedure instead.
Yep. For those of you who work with DBAs on large projects or in environments where there is a separation of roles that you don't have access to the database and so on, they will be seeing the types of queries that come across, and you may get hit with a question from a DBA, why are you doing all these inner or outer joins and so on and so forth? Here's a much more refined query you could be passing to the database, and that's where you need to work with them in terms of perhaps, as Jerry mentions, encapsulating that query into a stored procedure so you can leverage it in a more optimized way.
So in the first block here, what we do is we go get all the products from the table and then we iterate it. Here I'm going to just get the first product, and this will be important because I want to do some fun things with it. And so let me let's see. Let me just run it so I can show you what it looks like and make sure that we got the right one. You can see we got the first 4 filtered out, the one that doesn't have an O, and then we go and get gloves, right? And so that's the first one in the list, cool. and it's pretty nifty because I'm able to use first, another extension method provided by LINQ, and what I would otherwise do is be able to maybe ordinally get it like this, but I can use first, and it also allows me to add a predicate inside the first method, so I can apply a filter there if I need to.
So you say, give me the first one that starts with lion.
That starts with lion. You want me to do that?
Sure, why not?
Oh my gosh, it's so cool. X.name starts with lion.
And so this is the other real power of LINQ, is look how readable that is. Once you get in your head exactly how a Lambda works, you can look at this in pretty much plain English. Say, I want the first product that name starts with lion.
It's really powerful. There's no getting around it. And so now I'm not saying first in the list. I'm saying first in the list that obeys this predicate.
Yeah, that's awesome.
And so let's run it again. And hopefully it'll say lion. I don't. Was it capitalized? I just can't remember all about C. Beautiful.
Yes, it was.
All right. So that works nicely. And now let's make some changes. You know, I kind of meant to say not lion fur. Faux lion fur.
Oh.
That's what I meant to say. And so here's what I can do. You know, here's the product. Here's the product dot name, and I want to make an actual change to it. And so what I'll say is this equals faux lion fur. You totally spelled that wrong. You know what I mean? And so now changes the meaning of everything. All right. So let me. Whoops. I don't need this. So now I've changed the class or the object that represents the data in the database. What's beautiful now is Entity Framework allows me to write that back. And so now I'm doing full backwards and forwards communication with the database. So now I can say, and everything is done inside the context, I can say context.save changes.
So basically your context is doing some dirty tracking and knows that you've modified that record, and so now you say save changes, so that's going to save all changes that are currently pending within the context.
It really does. And so now I can recreate products again, query the database one more time, and say for each products, forget about this business for now, and just write them back out, and it better say faux fur.
It better say it.
It had better say faux fur. And that will show us that it has saved back. I mean, it's really neat. All right, so let's go ahead and run it so we can see it. It spit out the list. It showed the first one, lion fur hat. It requeries it, and now it's faux lion fur hat. F-I-R. Turned into a tree by mistake.
Yeah, not only is it a fake lion.
It's as fake as you can get. It's faux everything.
Exactly.
It's faux fur. It's not a real pine tree. You just oh gosh.
Now let's move on.
Yeah. All right, beautiful. Let's do one more thing just to show the full database interaction. I could also create a new product, by the way, and I could inject it. But let's go ahead and delete it.
Why don't you delete that crazy fur?
Let's delete it because this is nuts. I don't even like it anymore. All right, so let's go ahead and delete it, and we'll do it like this. I'll say inside the context, I have my products table, and here I need to, there we go, remove, and then it's asking what it is I want to remove. This will translate then to the SQL delete statement for me. And so I'll pass in the prod, that's the faux fur. And then just like before, I'm going to need to save this change. It's not going to do it just yet. And the reason it doesn't, I might have a lot of operations and I can batch them together this way. So now I can say
that's
context.
for efficient communication across the SQL Server.
Yeah, it's probably better to say it's for more efficient.
Okay.
Who knows if it's going to be efficient? We are at the mercy of an ORM. We do need to remember that. I use this, by the way. I have no problem including Entity Framework in a project, but you have to do things in measure.
Yep.
And so now I've saved it. If I were to read it yet again, and I'm going to just add a space this time. There we go. Now I'll add a little line, and I kind of wish I had done that here because you know how they all kind of blur together. Anyway, so here it is. I remove it from the table. That's the way I indicate that it needs to be deleted. I'll save it. That delete statement will run. Now we'll just go get it again, and lion had better not be in that table.
Yeah, certainly no fur.
Certainly no fur. Now, we've got a small problem in that our predicate will never be found. We renamed it so it doesn't actually start with lion. So if it's all right with you, I'm going to just delete that. So we just take the first one and change it to, instead of starts with, we'll just change it to contains. What's pretty neat here is I'm using these string manipulation pieces that we talked about before, and all the standard stuff inside the .NET framework. So I'm not having to learn yet another language. I can learn what I've already learned and be able to apply it, but this time into a different context. So if I run it here I get them all. And then here I operate in between these two. I conduct the delete, save that delete, and now you can see I've returned all four, and lion is no longer present. That's really, really nice.
It's really awesome.
Yeah. Running it over and over again actually created a second one. That's pretty humorous. But nonetheless, this is the syntax for updating data, querying data, deleting data, a lot of power. Entity Framework is right there. You can add it to almost any project. And
now, obviously, this has been a pretty trivial exercise in terms of we have a very simple table and we don't have any relationships out with other objects. You can create a very rich object graph where you have dependent objects that could come in as properties. If you have one-to-many relationships, then they would be a collection of those child objects. You could bring those in. You could specify that they're lazy loaded or they're loaded in advance as you bring back. There's an awful lot of power there, so I really encourage everybody to go out and have a look at those things. But as you can see, it's very, very simple and straightforward to do this initial kind of interaction with Entity Framework.
Other things that you get for free are LINQ. So LINQ is the language integrated query language, which is basically when I need to iterate with or interact with something like a list of products. We showed how we can say .where, and there's so many other things that you can do, and they're all really given to us by LINQ, and it's right there, part of the language, and it can be extended so that it can talk to SQL Server if you want to, but at its foundation, it's linked to objects. My ability to interact with the objects that are right here with me, to filter them, to be able to project them, all kinds of neat things. Let's kind of go through the power of LINQ. One of the things I get, of course, is IntelliSense. IntelliSense allows me not only to kind of discover, but also not to get it wrong, right?
Yep.
It's hard enough to write some of these predicates, let alone not to have IntelliSense on your side. Absolutely brutal. One of the things that LINQ includes is the ability to traverse down into deep objects. You know, so this was very simple. It was just a list of products, but sometimes products can have children of their own. And you know, you could have invoices, and invoices have payments, and payments have customers, and it could go on and on from there. I can do all of that with just using LINQ syntax. Now, LINQ syntax is complicated, and it would take a while to really get proficient at it and become very fluid in writing it. But once you are, it really opens up your code to a lot of possibilities. And if nothing else, it collapses your code, where you may have had line after line, loop after loop. I mean, how many times have you written
That's
a bubble
the key for
sort?
me, is because all of these things are operating against collections, fundamentally, things that implement IEnumerable, you can condense a lot of scaffold code, to use a term you talked about before, into just these very simple expressions that are doing all of the work behind the scenes. You're delegating, again, that activity to the framework and to the compiler.
Yeah.
We love the compiler.
The compiler does a lot of work for you. LINQ behind the scenes is just blown out beyond belief. But that talks to its power, because had it not done that, you would have had to have written all of that insane. And so not only it is often repetitive, right? But it is just another opportunity for you to get it wrong. It's just another opportunity for you to not do a bubble sort, for you to not do and oh my gosh, it really is complex, right? If I were to say sort by this, but then by this, but then by this, but not if it contains an O, right?
Yeah.
Wow. I mean, you've really asked for, you've basically given a developer a week's worth of work, where I could do the exact same thing in the wink of an eye now.
Sounds good.
Yeah. And so we have a demo actually put together to kind of show it off. LINQ comes to us in two flavors. It comes to us as a query syntax that sort of does feel like SQL Server, or I mean SQL, T-SQL. Sort of, right? The fact that it doesn't match it exactly it makes people frustrated, and so it's better not to. It's not like SQL at all, but it is kind of like SQL. So if you know SQL, you'll at least have a head start. But it also comes to us in a method syntax. That's basically all we've really shown so far. .where, .first, something else we did early on.
Exactly.
And let me pull up the demo, because the demo shows that it doesn't just give us the ability to add predicates to it, but it also gives us the ability to add aggregates and really powerful pieces that really would be difficult. I mean, just figuring out the average of something is hard, right?
Yeah.
I mean, if you think about not having these at your disposal, the average, but only even numbers and only the ones that are available in certain aspects. So let me close out this demo and open up the LINQ demo. What number is it? Do you know?
33.
Thank you. Thank you. Oh, it's an 8. Here we are. Beautiful. Bam, bam. Got it. Okay, so let's take a look. So enumerable.range, it's just a helper that returns a list of numbers to us. So you can say enumerable, that's just the namespace. .range, that's just a static method that you give a low number and a high number, and it gives you everything in between. It's nice, especially for demos like this. So now we have data, and it's just a list of 1 to 50. And so here I am using the method syntax. Pretty neat, right? So I can say data, that's my same object right there, data, dot where, and we showed how we could include a predicate when we were interacting with the database. Exactly the same here. This is lambda syntax where I say x lambda, and then here is the actual predicate itself. And so in this case, I'm saying whatever the object is, x is the represented piece.
So just to refresh people, a predicate is effectively something that returns true or false. So what we have here is we're passing in the value of x into the expression that is being evaluated, and x would be the item, the current item from data. So as it moves through, iterating through data, x is the current item, and then that gets projected into the predicate there, which then returns true or false if the number is odd or even.
It does. Yeah, that's exactly right. Good job. All right, so, but then we get one extra piece, and that's down here in select. And you would think select is somehow the filter, or what columns you want and things like that. But what it really is a projection tool. And so projection is an interesting word that a lot of developers don't use in this context, and they don't necessarily doesn't have any meaning to them. Projection really means to create a new type, or take the data and project it into a new type or a new structure.
Yeah, it's basically changing the data's shape to a certain extent. So that's the other major type of Lambda, is the projection. And so here we're taking the input, which is x, and we're transforming it into a string.
That's right. It starts off as integer, and here it's going to become a string because I'm doing this. Now I could also create a full class in this. I could say new whatever, and I could pass this as part of its properties. I could even create an anonymous type here. And again, earlier we were talking about anonymous types. I may only use them for a line or two, and so it's a handy way to store data and shape it the way you need it for your operations. Excellent. So I could do all three here. I could just return a simple type like this, an anonymous type, or a fully defined type. Okay, so this is the method syntax. Very nice, very easy. This is the query syntax. Does the exact same thing, just as easy, I'd like to say. Maybe more readable in simple formats like this. So it goes like this: query equals, and it's from D in data, and that's where I am actually defining that D is going to be all the items in data, where D modulus 2 is 0, so that's saying only the even. And what I'm selecting, just like before I project it out, I select d.toString. The results that go into method and the results that go into query are exactly identical. One just uses the method syntax of link, one uses the query syntax of link.
And one quick pointer, if you're first starting to work with link itself, is sometimes you might start typing out this syntax, and you might start seeing some compiler warnings and so on. That's probably because you don't have the system.link namespace included in your using.
That is a good tip.
That is a good tip.
Yeah. Especially things like .where, you have some sort of enumerable, you say .where and it's not working.
Yeah.
You got to manually go up, say using space system.link.
Exactly.
Yeah, and then it works.
And then it works, as if by magic.
As if by magic. Excellent. All right, so let me go ahead and set this as the startup project, so we can kind of debug into it. It's kind of fun.
Oh, debugger.break, that's a handy command.
It is neat, isn't it? That's to make sure that it breaks there. Sometimes I'll put debugger.break in my catch statements. Yeah. That way I know that when it goes to release and into production, it would never do that, but it would cause me to always see some sort of problem. Right? It's really nice. Because it's debugger, the compiler, our best friend, will take that out when I go into release.
So that's hard coding a breakpoint. Awesome.
It is. It's hard coding a break. It is awesome. Exactly. I can't turn it off.
Yeah, how scary is that?
It's not scary. Yeah, you're so easily scared. All right, so we can see data. All it really is a list of numbers, just like we would expect. Here's query. All it is a list of strings. You could see that because it has the quotes.
So there's an interesting feature of link that you just exposed there. The result wasn't populated at the time when you brought that up, and there's an interesting aspect to link.
Awesome, not interesting. Awesome.
Deferred execution.
That's right. Whatever it is I asked Link to do, it didn't just do it. Right here on what happened to my line numbers? We're gonna fix that,
but not whilst we're running.
Oh gosh. We're not going to fix it right now. All right. So right here is the definition of the action, not the execution of the action. It is really fascinating because it allows me to have yet another line. I could append to that, add another where, add now an order by, add and keep on going, and they all get applied when they are finally executed. Delayed execution is is marvelous.
Is marvelous. So basically what we have there is a queryable object that each extension method is basically implementing queryable and returns a queryable, which then allows you to chain together multiple methods.
You're right.
Yep.
Yeah, no, you're right. I was just trying to pull up the queryable interface.
You didn't believe
to show
me,
it.
that's what it was. Yeah.
I did believe you. Of course I believed you. I knew it.
Stop bickering.
Dork.
So basically, that allows us to chain these things together, refine them, as you mentioned, add new wares as we go on. We can also write services that return these queryables serialized across platforms and use different values. I actually did this an awful lot with Silverlight. That Silverlight had a constrained version of link implemented in it. Server side, I could actually build out a more complex link statement and return it back, and then continue to append my link queries client side, and then evaluate the expression.
I think it's worth at least pointing out some terminology. There is an expression tree, and the expression tree is the entire query. And as you add a where, as you add an order by, as you add a select, you're appending to that expression tree that can get very complex, but that's how it's all managed.
That's
right?
how it's managed.
Inside this tree.
And you can actually directly manipulate the expression tree should you so wish. You may want to do this if you're building very complex inquiry screens in your applications, where you have a number of fields that a user can enter in to filter.
Right.
You can dynamically build out your link query. By default, most of the queries append in an AND format. You may want to add something in an OR format that says whether it's this value or this value.
You're right.
The only way you can do that is by going in and directly manipulating the expression tree.
Not a trivial task, but it's there for you
if you
need
wish
it.
to peel back the onion.
Yeah, that's right. There's plenty of blogs out there.
But remember, if you peel back onion
process.
skins, your eyes water.
They do.
They do.
They really do.
They really do.
Okay, so we have the same values here. Let's go to the next block here and talk about projection. So here, I'm going to take the same value, and look, it's really nice. What I'm going to return, it's just data. Remember, that's just that list of numbers. And I'm going to return a new object, an anonymous object. That doesn't have a name, doesn't have a direct definition. And I'm going to return 3 properties, whether or not it's even, whether or not it's odd, and what its original value is. Easy enough. So let me just jump to, let that be complete. I can look at projection. Here's the way we can go into that, and and when we look at the results here, did you know about this? When you are debugging, of course you did, of course, but I mean, did you know? It's a neat thing. I'm looking at the results here, and I always have to drill into it and see what the count is or whatever, and I can pin this so that I can jump right to it. And so I can. It's even more interesting when you look at values, right? If you look at like the count, for example, and so I can pin it right here. You can see it's right here. Every time I debug, that will always be shown, so I don't have to drill into that object again. Very powerful, very handy. And I can even do a little magical piece here, and I can say, this is the count, should never be more than 50. Right? Very cool. So this can be shipped to all my other developers that we work with on a team, but it's great also for me, right? When you're iterating through something and you have to click, 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 click.
Absolutely.
Okay, so now I've projected, and when I look at the type that's been projected, this list is no longer just a string, but it's a full-fledged object, and you can see it has 3 properties: even, odd, and value. Each of them have been correctly populated, like you would expect, and there is no name. Of course, we know the compiler does create a secret name behind the scenes, but we don't have to mess with that, and now we don't have to either mess with the definition or updating it if we never needed to alter it just to do this demo.
That's awesome.
Yeah, it really is neat. So let's look at the next one. So we're going to have a list of letters this time. A, C, B, E, Q. And of course, the point is they're out of order. We need to sort this. How are you going to sort an array? Well, prior to LINQ, it was a nightmare, right? Not that it couldn't be done.
Implement your own bubble sort? Or?
Yeah. And then if it's an array of an array, heavens, that's serious.
Fun.
Yeah, and so here we are. I'm ready. How are we going to sort this? Here's how we do it in the query syntax. So the query syntax basically from letters, from D and data. Wait a minute, from D and data. I'm sorting data instead of, that would have been so much more cool. I'll just make a change real quick.
Yeah, let's stop debugging first then.
Are you say soon? All right here.
See, this is the value of pair programming if you've never tried it.
Yeah. Yeah. All right, perfect. Let me, I want to jump to here. I just put that so I'd know I was there. Okay, good. Yeah, I just didn't want to, I just need to visually see
a break point on your break point?
I know, and it broke twice is what's funny, because it breaks before it breaks and then it breaks.
I know.
Anyway, so here I can sort ascending, right? That's a nice feature. So I can see now it's ABCD or ABCEQ, right? To make sure that everything's in order. And then I can sort descending, and you can see it's still there. One uses the QECBA, and one uses the query syntax, one uses the method syntax. Each is available to both. It's really nice. I mean, just having order by, and you can do more. You can say order by, then by, and it does the next one. These are complex sorting. All right, so here's a little bit more fun we can do. All of the, of course, we've used first, right? That allows me to get the very first. Really neat that we can do last. Go all the way to the end. I don't have to count first and then go to it and then go back one because it's ordinal.
Is that doing a shortcut, or did you think it's still moving all the way through the enumeration?
No, it's certainly not moving through the enumeration. It is. Ask me what you mean.
Basically, it looks like it's very short and a low-cost operation there, but the reality is it still has to evaluate your enumeration because it doesn't necessarily know, because it just has enumerable, so it has to move all the way through. So just because it looks like it's very simple and straightforward here doesn't necessarily mean that if you've got 10,000 items that it's going to know how to jump straight to the end.
That's right. These are helper methods that ultimately are doing what you would have done.
Yes.
Right? They don't have a secret backdoor to go do whatever it is that you want to. Now, so I can see that here's A, B, A, C, A, D, all in this list. All right, there it is. Looks really nice. And now I can go to distinct. This is a powerful one. Being able to do distinct. I use it all the time. And now I can see the results of distinct. A, B, C, D. That's what you would expect. It took out all the duplicates. That's really nice. And of course, it's really easy here to do a distinct, but we might have to pass in a custom comparator, thank you, that evaluates whether or not it is distinct or not, because it may be a deep object. And of course, here's first. We know what that does. First or default is really neat, because there may not be anything in there at all.
It may not be there, because if we're doing first, and it doesn't find anything, what comes back?
Yeah, nothing. I mean, it's going to be a failure if you do first, right?
Yep.
Boom, there is no first. First or default comes back as null. But you can tell it what to bring back as well. Default for an integer is not null, right? It's negative.
So we need to move on.
Yeah, let's do. I want to talk about paging first, though, because it's probably one of the neatest parts of LINQ, and that's the ability to skip into a list and then create a page aside. So that's skip and take. Very valuable, very, very valuable. And then we have aggregate values as well, where we can use sum, min, max, average, different things like that would almost be, not impossible for sure, but just gobs of code in order to implement prior to LINQ.
So let's basically do a recap of what we've covered over the module. So, we obviously revisited our asynchronous activities and kind of talked about async, task and await.
That's right.
So visited that. Then we really spoke about how we can interact with databases and the type of technology that we have available to us and the patterns and practices that we can leverage. We also showed a fairly trivial interaction with the database, but we did demonstrate how quickly we could create a database and put some things up. Well, the real power of that particular local DB scenario is how quickly you can mock out a application if you want to prove a concept, demonstrate some techniques. It's awesome. And then finally, we touched on LINQ, and we did a bit of a deeper dive into the LINQ capabilities, the types of methods and capabilities that it exposes out. Whew.
If we got paid by the word, we'd be millionaires right now.
Exactly.
No getting around it.
Here's hoping that your video playback does allow you to slow down the stream.
That's right. Okay, one more note. This is Microsoft Virtual Academy. This has been the jumpstart for C# fundamentals. That's course 70384. You can get the code that we've been going through out at xaml.codeplex.com. There's a Microsoft Virtual Academy link there that you can go and get. Go through these with us, learn a little more. We have certainly many more demos that we didn't get to go through. There's so much to C#, Darren. We covered it so thinly. Honestly, it was embarrassing.
But we hope it was valuable. So it's goodbye from me, Darren May, and it's goodbye from him.
Jerry Nixon, jerrynixon.com, crank211.com for you.
Absolutely.
Have a good day.
See you guys again.